네, 여러분 안녕하세요. 가을바람입니다. 오늘은 어떤 정보를 좀 여러분들한테 드리면 좋을까 고민을 하다가 예전부터 해보고 싶었던 게 있었어요. 그래서 제가 처음 아이온큐 투자했던 게 이제 2021년 9월부터였는데 그때 이제 이런 아이온큐나 양재에 대한 정보도 너무 없고 궁금해하시는 분들도 많고 해가지고 같이 공부하는 카톡방도 여러 개 만들었고 이제 유튜브 채널을 본격적으로 하면서 많은 한국인 주주분들이 함께하게 됐죠. 그래서 거기서 제가 여러분들이 궁금하신 거 있으시면은 제가 경영진들한테 이제 여러분들의 의견을 좀 대리해서 물어보고 이런 것들 해도 되겠느냐 했는데 많은 분들이 해주세요라고 하셔가지고 그때부터 좀 아이온큐 장기 주주들을 스스로 뭐 대표하는 이런 역할을 자처했었는데요. 그걸 해오면서 제가 많은 경험들을 했죠. 특히 아이온큐 임원들을 여러 번 인터뷰했는데 지금 보니까 제가 총 6번 정도를 인터뷰했더라고요. 그래서 2022년 1월부터 최근에는 2025년 6월 말에까지 6번 정도 인터뷰를 했는데 하나하나 이제 풀 버전으로 제가 묶어봤어요. 그래서 어떤 일들이 있었고 임원들이 어떤 말을 했는데 이걸 지켰는지 안 지켰는지 이런 것들을 보면은 또 투자자로서 여러분들이 이 회사와 이 경영진들을 제대로 파악하고 거기서 이제 현명한 투자 판단을 내리실 수 있을 것 같아서 오늘은 제가 지금까지 했던 아이온큐 임원들과의 인터뷰를 풀 버전으로 한번 만들어 봤습니다. 각 인터뷰 처음에 언제 했던 인터뷰고 누구랑 했던 인터뷰인지 이런 얘기를 좀 서두에 넣어 놓도록 할 거고요. 첫 번째는 제가 김정상 교수님과 단독으로 줌으로 이제 인터뷰를 했던 거고 2022년 1월이었습니다. 네, 여러분 안녕하세요. 가을바람입니다. 오늘은 참 기쁜 소식이 있어서 영상을 또 이렇게 제작을 했습니다. 그래서 여기에서 보시는 바와 같이 제가 이 세계에서 최초로 주주로서는 처음으로 이제 아이온큐의 공동 설립자이자 CTO인 김정상 교수님을 짧게 인터뷰를 했습니다. 아이온큐 측에서는 이제 국내 메이저 언론에서도 이런 인터뷰를 요청을 했는데 거절한 것으로 알고 있고 딱 한 군데 했었죠. 근데 이제 주주로서 이제 제가 한국인 장기 주주 커뮤니티를 대표한다는 소식을 아이온큐의 CFO 분한테 전달을 했고 인터뷰를 하고 싶다라고 조정을 해오다가 김정상 교수님을 바쁘시지만 어떻게 잠시 동안 섭외를 해서 짧게 얘기를 나눠봤는데요. 우선 시청하시기 전에 앞서서 제가 말씀드리고 싶은 게 지금 화면에 보시면은 제 화면이 스폰지밥 배경 화면으로 되어 있습니다. 이게 제가 의도한 게 아니고요. 원래 좀 프로페셔널한 배경 화면을 가지고 있었는데 이게 저도 그렇고 이제 아이온큐 측에서도 이런 인터뷰가 처음이다 보니까 중간에 뭐 녹화하는 이슈나 뭐 기술적인 부분의 이슈가 있어서 인터뷰가 완벽하진 않습니다. 그래서 이제 미리 양해를 부탁드리고요. 하지만 또 이렇게 바쁘신 아이온큐의 핵심 인재 중에 한 분이신 김장산 교수님이 시간을 내주셨다는 것만으로도 저는 참 감사하다고 생각을 합니다. 네, 그래서 한번 인터뷰 시청해 보시죠. 제 소개를 먼저 드리겠습니다. 저는 이제 권중현이라고 하고요. 지금 뭐 유튜브도 하고 있고 이제 아이온큐 쪽에 관심을 많이 가지고 있어서 한 카카오톡방 있는 건 아마 아실 거예요. 한
예,
4천 분 좀 넘는 한국인 분들이랑 이제 아이온큐를 같이 공부하면서 장기 투자를 한번 해보자라고 해서 지금 그
예,
커뮤니티를 이끌고 있고
예,
이제 또 이번 인터뷰에 임해주셔서 너무 감사하고 이제 골드만삭스, 피델리티, 소프트뱅크, 뭐 삼성, 아마존 등 세계
예,
글로벌 대기업들이 이제 아이온큐에 투자를 하고 있는데
예.
왜 그런 투자를 했다고 혹시 생각을 하시는지.
예, 뭐, 물론 저희가 그런 사람들의 마음 깊은 곳에 들어가 보기는 어렵지만은, 예,
네네.
최소한 제가 보기에는 양자 컴퓨터라는 게 워낙 물론 이제 초기 단계라서, 물론 아직 리스크가 없는 건 아니에요. 계속 개발도 많이 해야 되고 그렇지만, 만약에 성공을 해서 이게 실제 프랙티컬한 솔루션들을 해결하기 시작하면 응용할 수 있는 분야가 무지무지하게 넓습니다. 그러니까 예를 들면 기존의 컴퓨터를 그 처음에 개발했을 때 사람들이 뭐 전자계산기 손으로 그러니까 인텔에서 처음에 마이크로 프로세서를 만들었을 때 전자계산기부터 시작했는데 지금 컴퓨터가 쓰이는 영역은 거의 무한하게 넓죠. 인터넷도 마찬가지고. 그래서 그런 정도의 사회적인 변혁을 가져올 수 있는 가능성이 있는 그런 기술이라고 생각했기 때문에
네네.
굉장히 다양한 영역의 인더스트리에서 다 관심을 갖고 있는 게 아닐까 그렇게 생각합니다.
아이온큐의 임직원 규모나 이제 하드웨어, 소프트웨어 엔지니어들이 그 중에서 비중을 어느 정도 차지하는지 좀
예,
궁금합니다.
예. 지금 저희가 지금 현재 직원이 약 100여 명 정도 되고요. 굉장히
네네.
빨리 변하고 있습니다. 지금 올해는 저희가 이제 상장한 이후에
네.
회사 규모를 많이 키울 거기 때문에
어,
거기서 빨리 훨씬 더 늘어날 거라 생각하고 현재 저희 임직원의 한 80% 정도 대부분의 직원들이
80%.
이제 소프트웨어 하드웨어 엔지니어랑 기술진이고요. 뭐 그런 비중이 조금 앞으로 사업이 커지면서 변할 수는 있지만은 아직까지는 이제 굉장히 테크놀로지 포커스 일단 앞서가는 기술을 빨리 개발을 하는 게 우리 회사의 성장에 가장 큰 도움이 되기 때문에 그쪽에 집중해서 투자를 하고 있습니다.
그리고 이제 아이온큐 양자 컴퓨터가 상용화에 도달하면 얼마나 걸릴지 뭐 그쪽 부분이랑 이제 제가 여러 가지 질문을 사전에 보내드렸는데 이제 뭐 clear path towards commercialization 이라는 프레이즈가 여러 번 나옵니다. 그래서
예,
2023년에 rack mount scale for data center가 나온다고 이제 피터맨 사장님께서 말씀하셨고 2025년에는 이제 broad quantum advantage를 달성할 수 있지 않을까라는 로드맵을 주셨는데 이
예.
부분에 대해서 뭐 진척도나 실현 가능성에 대해서는 혹시 어떻게 생각하시는지.
예. 예, 제가 이제 커머셜, 상용화라고 하는 게 이제 여러 가지 의미가 있을 수 있는데,
네네네.
이제 제 생각에는 이제 첫 번째는, 이게 아주 새로운 기술이기 때문에 당연히 지금 양자 컴퓨터를 기반으로 해서 그 사업 모델을 가지고 있는 그런 인더스트리가 있는 게 아닙니다. 그러니까 완전히
네네.
새로운 모델이기 때문에. 근데 이제 이런 경우에는 상용화가 두 가지, 측면이 있어야 되는데 하나는 이제 기술의 성숙도가 충분해서 뭔가의 솔루션을 제공할 수 있어야 되고 두 번째는 이런 기술을 사용을 해서 실제 문제를 풀 수 있는 애플리케이션을 개발을 해야 되는데 그 두 가지가 다 이루어졌을 때 이제 진정한 대용량의 기반의 사업이 생기게 되는데 이제 지금은 그 두 가지가 이제 접점을 찾아가는 단계인 것 같아요. 그래서
네네.
저희도 실제로 기업들에서 R&D 쪽에서 이 양자 컴퓨터를 활용해서 어떻게 우리의 문제를 풀 수 있는지 좀 심각하게 들어가서 달려들어 보자. 뭐 그런 거는 충분히 굉장히 많은 기업들에서 이미 벌어지고 있는 겁니다. 아시다시피 뭐 골드만삭스나 저희가 하는 일이라든지 피델리티, 어드밴스 테크놀로지 쪽인데 그분들이랑 일을 하는 거라든지 아니면 뭐 현대랑 일을 하는 거라든지 그런 거는 이제 약간 연구개발 측면에서 양자 컴퓨터라는 기술을 활용해서 우리 문제를 풀 수 있는지 그걸 사실 도메인에서 실제로 산업계에 계신 분들이 그런 노력을 해서 당신들의 문제를 갖고 와서 풀어야 돼요. 저희가 잘 알고 있는 게 아니라서. 그러면서 이제 그런 협업은 지금 이미 시작됐기 때문에 이제 그거를 뭐 상용화의 첫 단계라고 할 수도 있을 것 같습니다.
네네네.
이미 커머셜 인트레스트가 있는 거니까.
어,
예, 근데 물론 지금 단계에서는 이제 그런 방법론을 개발하는 거기 때문에 약간
네.
R&D 쪽에 상용화로 볼 수가 있겠죠.
음,
근데 저희가 그걸 해보면 기존에는 저희가 처음 시작할 때만 해도 양자 컴퓨터 애플리케이션이 기존의 컴퓨터보다 이 성능을 능가하기 위해서는 정말 아주 파워풀한 퀀텀 컴퓨터를 만들어야 돼서 작업하고 있었는데 뭐 그게 많이 바뀌진 않았지만 들여다 볼수록 이 양자적인 방법론이 가지는 어드밴티지들이 조금씩 더 구체적으로 보이기 시작해요. 그런 면에서 굉장히 encourage하는 것 같습니다.
네, 현대차와의 차세대 리튬 배터리 개발 협업이 이제 엊그저께 나왔는데
예,
이제 그 크리스 먼로 박사님이 다른 업체 이 미디어와의 인터뷰에서 단순히 양자 컴퓨팅 하드웨어 기업이 아니라 소프트웨어 알고리즘까지 뻗어나갈 계획이 있다라는 말씀을 해주셨는데
예,
그쪽 분야의 기술력에 대해서는 혹시 어떻게 생각을 하고 계시는지 궁금합니다.
예. 예, 사실 제가 보기에는 그 알고리즘, 특히 애플리케이션 개발, 애플리케이션은 뭐 우리가 얘기하는 뭐 아이폰 앱 이런 게 아니라
네네.
양자 컴퓨터를 활용을 해서 실질적인 문제를 풀어갈 수 있는 방법을 찾는 그 분야는 제가 보기엔 거의 블루오션이에요. 왜냐면
그쵸, 그쵸.
물론 사람들이 연구 차원에서 학계에서 양자 알고리즘을 연구하시는 분이 많이 있었지만 그런 분들은 굉장히 원칙적인 아주 펀더멘탈한 리서치를 많이 하시는 분들이고 막상 실제 인더스트리에서 페이스하는 문제들을 어떻게 태클할 것인지를 찾아가는 과정은 제가 보기에는 이제 굉장히 앞으로 가능성이 많은 길입니다. 그런 면에서 저희가 이 일을 해보면 이 양자 컴퓨터의 하드웨어, 그러니까 지금 우리가 기존의 컴퓨터 같은 경우는 워낙 컴퓨터 기술이 성숙돼 있어서
네.
하드웨어를 잘 모르고 소프트웨어만 알아도 뭐 굉장히 밸류를 크리에이트할 수, 가치를 창출할 수 있는 애플리케이션을 찾기가 쉬운데, 사실 제가 80년대에 제가 처음에 이제 컴퓨터 두드리면서 그 프로그램을 짤 때만 해도 저희 그 프로그래밍 강사님들이 그런 거 가르쳐 주세요. 이거를 이렇게 짜면 메모리를 더 적게 소비를 할 수 있기 때문에 더 큰 문제를 우리가 이 작은 컴퓨터에서 풀 수가 있다. 그게 이제 왜냐하면 그 기술이 초반기에 퍼포먼스, 그러니까 성능이 굉장히 제한이 되어 있는 그 컴퓨터에다가 그 알고리즘을 돌리기 위해서는 그 굉장히 버티컬리 전부 다 인테그레이팅 옵티마이즈를 많이 해야 돼요. 그런 측면에서 그 저희가 하드웨어도 만들지만 저희 하드웨어에다가 어떻게 하면 더 효율적으로 알고리즘을 적용할 수 있는지, 그러기 위해서는 어떤 옵티마이제이션이 필요한지, 그러기 위해서는 애플리케이션을 어떻게 그 효율적으로 프로그램을 짜야 되는지, 그런 데 대한 그 옵티마이제이션이 굉장히 폭넓게 필요합니다. 그런 측면에서 저희가 그 클라이언트들이 문제를 갖고 왔을 때 그 문제를 같이 들여다보다 보면 훨씬 더 효율적으로 그 문제를 풀 수 있는 그런 방법들 많이 찾을 수 있기 때문에 그런 소프트웨어 쪽의 가능성은 굉장히 많다고 보고요. 그 소프트웨어도 워낙 그 레이어들이 많은데
네네.
그런 측면에서의 옵티마이제이션의 기회가 많아서 저희 쪽에서 그런 그 소프트웨어 엔지니어도 많이 모시고 연구 개발 많이 하고 있습니다.
네, 감사합니다. 지금 깨달았는데 제 배경화면이 원래 진짜 화면인데 이게 방금 초기화되면서 제가 네, 캐주얼하게 쓰는 화면이 나왔는데 좀 양해를
예.
부탁드립니다.
괜찮습니다. 예.
그리고 이제 가장 궁금해하셨던 것 중에 하나가 이제 제가 보기엔 이제 큐비트 구현 방식의 메인스트림이 이제 이온 트랩 방식이랑 슈퍼
예.
컨덕팅 이렇게 두 개라고 보고 있는데 이 두 개의 장단점이 명확하잖아요. 그래서 이제 아이온큐의 이온 트랩 방식이 더 우월하다라는 이제 회사의 주장이 있는데 그 부분에 대해서는 혹시 어떻게 교수님은 생각을 하시는지 좀
예.
궁금합니다.
예. 뭐 물론 이제 그 각각의 그런 기술을 추구하시는 분들은 다 자기들의 장점을 얘기를 할 수밖에 없는데 제가 보기에 결국의 결론은
네.
그런 연결 컴퓨터를 활용해서 그 우리 커스터머들, 그러니까 실제 유저들이 얼마나 쓸모 있는 문제를 해결할 수 있는지가 제일 중요한 것 같아요. 사실 그게 담보가 된다면 저는 기술을 바꿀 준비가 돼 있습니다. 결국 양자 컴퓨터 성공하기 위해서는
네네.
그 실제 유저들의 문제를 해결할 수 있어야 되고, 그러기 위해서는 점점 더 복잡하고 큰 알고리즘들을 엑스큐트를 할 수 있어야 돼요. 그래서 저희 양자 컴퓨터, 저희 아이언큐의 모든 그 개발 포커스는 어떻게 하면 더 커다란 문제를 시간이 지나면서 점점 크고 점점 더 복잡한 문제를 풀 수 있는 양자 컴퓨터를 만들 수 있느냐, 거기에 집중이 돼 있습니다. 그런 면에서 생각을 해보면 이제 가장 그 얼마 전에 그 벤치마킹을 한 논문이 나왔는데 그 벤치마킹을 보면은 거기서 이제 뭐 컴퓨터의 큐빅의 개수가 아무리 많아도 실제 우리가 깊은 계산을 할 수 없으면 그러면 그 나머지 큐빅들이 다 소용이 없어요. 그러니까 양자 컴퓨터가 기존의 컴퓨터랑 다른 이유가 기존의 컴퓨터는 연산을 하는데 그 오류가 별로 없기 때문에 연산의 길이가 굉장히 길어질 수가 있는데 양자 컴퓨터는 아직까지는 그 오류 때문에 연산의 깊이에 제한이 있습니다. 그래서 예를 들어서 내가 큐빗이 1000개가 있는데 실제로 할 수 있는 연산의 개수가 100개밖에 안 되면 그럼 나머지 990개의 900여 개의 큐빗은 아무 소용이 없어요. 어차피 활용을 못하게 되는 겁니다. 그래서 지금 현재로서는 이 연산의 오류를 줄여가지고 점점 더 깊은 연산을 하는 것이 실제 알고리즘을 엑스큐트 하는데 가장 큰 걸림돌입니다. 그래서 이제 저희 같은 경우는 그런 면에서 그 오류를 줄여줘서 보다 더 깊은 폭이 넓고 깊이가 깊은 커다란 연산을 하는 게 이제 목표이기 때문에 그런 측면에서 저희는 기술 개발에 집중을 하고 있고, 그 벤치마킹 데이터를 보면은 실제 알고리즘을 점점 더 크고 복잡한 알고리즘을 해봤을 때 아이언큐가의 시스템으로 할 수 있는 계산이 가장 복잡한 계산을 할 수가 있어요. 그게 이제 저는 그거 매트릭으로 봤을 때는 저희 회사의 기술이 앞서가고 있다고 생각하고, 또 마찬가지로 이제 저희 회사의 아키텍처나 미래 기술의 로드맵을 봤을 때 이제 그거를 푸시라는 포커스가 있기 때문에 그 갭은 뭐 제 나름대로는 그 갭의 앞으로도 점점 더 키울 수 있도록 그렇게 기술 개발에 집중을 하고 있다고 생각하시면 되겠습니다.
이제 100큐비트까지는 뭐 EGT나 RMQA 이런 거 기술을 활용을 하고 1000큐비트 위로는 뭐 이제 업틱 스위치, 제가 그런 건 잘 모르지만 뭔가 이제 교수님 전문 분야이신 광학이나 광자학 쪽을 접목을 해서 여러 개의 칩들을 뭐 연결해서 이제 엄청난 스케일을 만든다 뭐 이런 얘기를 크리스 먼로 박사님이 또 다른 데서 해주셨는데
예,
그
예.
부분에 대해서 좀 쉽게 설명을 부탁드려도 될까요?
예. 그러면 이거는 비유를 해보면 굉장히 쉬운데요. 비유가 아주 간단합니다.
네네.
우리가 이전에 클래시컬 컴퓨터를 봤을 때, 이제 처음에 한참 동안은 386에서 486, 486에서 586으로 가고 그 프로세서가 펜티엄으로 그러면서
네네.
실제 그 프로세서 하나에 집적도를 높이는 게 그 컴퓨팅 파워를 향상시키는 데 가장 주된 척도가 됐었어요. 근데
네네네.
이제 얼마 전부터 이 멀티코어 칩이라 그래가지고
음.
컴퓨터 칩 하나에 CPU 하나에 코어가 뭐 4개가 들어가고 8개가 들어가고 그렇게 가잖아요. 근데
네네.
그거 이유는 그 CPU 자체 크기를 키우는 것보다
음.
그 여러 개의 코어들을 동시에 넣어서 그 패러럴하게 그러니까
음.
병렬적으로 계산하는 게 더 좋기 때문에 그렇습니다. 그래서
네.
요즘에는 컴퓨터를 사다 보면은 이게 듀얼 코어인지 뭐 쿼드 코어인지 옥타 코어인지 뭐 이런 것들이 중요하잖아. 근데 그게 멀티 코어로 가는 거고 그 다음에 거기서부터 더 스케일을 하려면은
네.
우리가 컴퓨터 칩을 뭐 이렇게 책상만하게 만드는 게 아니에요. 어떻게 만드냐면 컴퓨터 칩은 하나가 있대. 우리가 컴퓨터를 만들고 그런 컴퓨터를 그 데이터 센터나 슈퍼컴퓨터에 가면은 그런
네네.
컴퓨터를 뭐 수천 대, 수만 대를 모아가지고 걔네들을 이제 통신망으로 연결을 해서 그렇게 해서 작업을 하거든요. 근데
네네.
실제로 그 클래시컬하게도 컴퓨터가 스케일을 할 때는 처음에는 집적도를 높이고 그 다음에는 여러 개의 컴퓨팅 코어를 한 개의 칩에다 집어넣고 그
네네.
다음에 여러 개의 컴퓨터를 수천 개, 수만 개를 네트워크 연결을 해서 만드는 것이 그
네.
컴퓨테이셔널 파워를 키우는 방법입니다. 그러니까 저희가 아까 크리스 먼로 교수님께서 말씀하신 거는 저희가 물론 지금은 이제 현재로서는 하나의 컴퓨터, 아이언큐 쿼антम 컴퓨터에 들어가는 칩의 숫자를 늘리고 걔네들이 할
네네.
수 있는 계산의 깊이를 높여주는 게 지금의 포커스인데
음.
그 다음에는 멀티코어로 가야 돼요. 그런
음.
프로세싱 유닛을 여러 개를 한 개의 칩에다 인테그레이트 시키는 거죠. 그 이제 저희가 멀티코어 칩을 얼마 전에 시연을 했는데 이제
네네네.
그게 거기로 가는 첫 단계입니다. 그렇게 해서 멀티코어로 가고 그 다음에 이제 포토닉 인터커넥터라고 해가지고 그 다음에 이제 컴퓨터를 우리가 만들어서 그런 거를 여러 개를 연결할 수 있는 그런 기술이 필요한데 그런 기술을 위해서는 이제 저희가 하는 그 원자들이 빛을 발하게 해가지고 그 광자를 통해서 이렇게 양자적인 얽힘을 할 수 있는 그런 기술이 있습니다. 그런 것들이 사실 크리스 먼로 교수님이 2007년에 처음으로 그 기술을 이제 기본적인
네네네.
프로토콜을 데몬스트를 하셨는데 이제 그런 기술을 저희가 많이 축적을 하고 있어요. 그래서 결국은 이제 미래로 가면 하이 퍼포먼스 퀀텀 코어, 그다음에 멀티 코어, 그다음에 모듈러 시스템. 그래서 스케일러블 시스템을 네트워크로 가는 그런 방향을 이제 저희가 기술로 잡고 있습니다. 그래서 그런 것들을 실현하기 위한 일단 기본적인 원론적인 데몬스트레이트 컨셉 데몬스트레이션 저희가 이미 다
네네네.
하고 이제 그거를 저희가 그 프로덕트로 어떻게 집적을 하고 그 기술 개발하는지 이제 그런 것들이 이제 저희 기술적인 로드맵이라고 생각하시면 됩니다.
그리고 뭐 이제 여러 가지 파트너십에서 뭐 이제 피델리티와 양자 머신러닝도 하고 계시고 골드만삭스는 이제 뭐
네.
몬테칼로 시뮬레이션 뭐 이제 현대차와 배터리 뭐 이런 쪽도 하고 계시는데 어느 부분이 제일 먼저 결실을 맺을 거라고 혹시 생각하시는지 그 부분도
좋은
좀
질문인데요.
네.
사실은 어느 부분이 제일 먼저 결실 맺을지 뭐 제가 지금 확답을 드리기 어렵습니다. 이게
네네.
예측하는 게 쉽지 않기 때문에. 근데 막상 이게 들어가서 하다 보면 프로그레스가 점점 빨라지는 건 있고요.
네.
사실 머신러닝 같은 경우는 처음에 우리가 시작할 때만 해도 이게 양자로 해결이 될 수 있는지 해결이 된다면 클래시컬 고전적인 머신러닝에 비해서 얼마나 장점이 있을지 그런 것들 잘 몰랐었는데 막상 이제 해보니까 이제 그런 것들이 보이기 시작하는 거예요. 물론 그게 뭐 학문적으로 양자 컴퓨팅으로 하는 머신러닝이 트레디셔널한 것보다 뭐 학문적으로 얼마나 더 잘할 수 있다 이런 거를 사람들이 정확하게 이해하는 데는 아직 연구가 더 많이 필요하겠지만 되게 이제 실용적으로 봤을 때 막상 해보니까 잘 되는 것들이 있어요. 그래서 그런 것들은 이제 저희들이 조금 더 연구를 해보고, 그 다음에 저희가 로드맵이 있지 않습니까? 미래로
네네네.
갈수록 얼마나 더 복잡한 그런 문제, 새로운 방법론을 개발했을 때, 이게 우리 기술이 앞으로 계속 양자 컴퓨터의 성능이 좋아질수록 어느 시점에 가서 실제로 쓸모 있는 애플리케이션들을 활용할 수 있을지 그런 것들 좀 프로젝트를 조금 더 해봐야 되는데 이 미래로 가는 이 슬로프가 기울기가 아직 언서튼티가 많아요. 그래서 저희가 그게 연구개발 계속해서 그 기울기를 조금 더 이렇게 높여주면 더 빨리 미래로 갈 수 있는 방법이 있기 때문에 어느 게 더 잘 된다라고 말씀드리기는 어려울 것 같고, 제가 아까 말씀드렸듯이 이 양자 컴퓨팅을 응용해서 잘 풀 수 있다고 생각하는 인더스트리가 워낙 많기 때문에
네네.
그런 쪽에서 굉장히 시리어스하게 그 연구 개발에 투자를 하실 그런 파트너들을 찾아가지고 빨리 깊이 들어가 보는 게 제가 보기엔 중요하지 않을까 생각합니다.
그럼 그 양자 기술의 진보가 빨라진다는 거를 저도 공부하면서 느끼는데 그게 제가 느끼는 게 맞는 건가요?
예, 근데 이게 저는 이 양자 컴퓨터를 지금 17년, 18년째 이제 하고 있는데,
네네네.
처음에 연구 개발할 때는 굉장히 느려요. 왜냐하면 속도가 느린 이유가
네네.
아이디어는 많은데 일단 그 인력이 많이 없고 거기에 투자되는 그 투자 비용도 많지 않습니다. 그래서 왜냐하면 이게 정부에서 작은 연구비 받아서 하는 뭐 이런 쪽에서 시작하다 보니까
네네.
근데 이제 저희도 이 좋은 아이디어들이 나오고 기본적인 게 데몬스트레이트가 돼서 시스템을 만들기 시작하면은 뭐 저희가 학교에서 연구를 할 때도 연구비의 규모도 많이 커지고 그러면서 우리가 훨씬 더 엔지니어링이나 전문 인력들 많이 투입을 해가지고 하면 일이 그만큼 빨라져요. 근데 지금 이 회사에서는 훨씬 더 집중적인 투자를 할 수 있고, 훨씬 학생들이 아니라 대학원생들이 아니라
그쵸,
훨씬
그쵸.
전문 인력들이 모여서 일을 하다 보면 이게 점점 가속도가 붙는 게 저도 느껴집니다. 그래서 앞으로도 제가 보기엔 가속도는 점점 붙을 것 같고요. 투자가 늘어나고 그다음에 그 전문가들이 참여를 하는 한에 있어서는 이제 점점 더 가속도가 붙을 것 같습니다. 얼마나 빨리 갈지는 두고 봐야
네네.
되겠지만 historically 지난 17년을 봤을 때는 뭐 가속도가 굉장히 빨리 붙고 있다는 느낌이 저도 아주 피부로 느끼게 듭니다.
네.
예,
이제 시간이 거의 다 돼서 이제
예,
저희가 전해드리고 싶었던 말씀이 이제
예,
대한민국의 양자 생태계의 조성이나 이제 양자 정보과학 발전을 위해서 열심히 노력해 주시고 계시는 거를 저희가 다방면으로 보고 있거든요. 그래서
예,
주주들과 국민들을 대신해서 감사하다는 말씀을 드리고 싶고요.
예,
저희가
감사합니다.
단순히 주식을 매매하는 그런 종이 쪼가리로 생각하는 게 아니고 이제 회사의 오너십을 가지고 같이 동반 성장한다라는 마인드로 투자를 하고 있기 때문에
예,
항상 응원하고 있으니 힘내시고 네, 항상
예, 감사합니다.
건강하셨으면 좋겠고요. 네,
예,
바쁘신데 이렇게 또 시간 내주셔서 하락장에 주주들한테 큰 도움이 됐을 것 같습니다. 네,
예,
시간 내주셔서.
예, 저희 아직 초기 단계에서 저희들도 물론 굉장히 애를 많이 쓰고 있지만 믿고 끝까지 주주로서 회사에 참여해 주셔서 감사드리고요. 혹시 주주 입장에서 뭐 저희가 이렇게 더 잘했으면 좋겠다, 아니면 이런 쪽에 노력을 해봤으면 좋겠다, 그런 인풋이 있으면 뭐 언제든지 전해주시면 감사하게 듣도록 하겠습니다.
네, 알겠습니다. 교수님 바쁘신데 시간 내주셔서 감사합니다.
예,
네,
감사합니다.
나중에 또 뵙겠습니다.
예, 또
감사합니다.
뵙겠습니다.
네.
감사합니다.
자, 다음은 2022년 8월 달에 이제 아이온큐 CEO, CFO, 최고 기술 책임자 이런 최고 임원진들과 줌으로 서로 이제 Q&A 시간을 가졌던 자료고요. 2022년 8월입니다. Hello everyone, welcome to IonQ's Fireside Chat event. My name is Sean Kwon from Korea, and I'm part of IonQ's long-term investor community in Korea. Today, I'm honored to host the Fireside Chat with IonQ's President and Chief Executive Officer Peter Chapman, IonQ's Chief Financial Officer Thomas Kramer, and co-founder and Chief Technical Officer Jung-Sang Kim. Peter, Jung-Sang, and Thomas, thank you so much for taking the time to hop on a call tonight to discuss IonQ and your latest earnings announcement.
Thank you for giving us the opportunity, Sean, to speak to both you and our Korean investor base. We're very pleased to be here.
I hope you and IonQ employees know that we fully support you and look forward to seeing quantum computing become a major industry in the near future. And of course, IonQ staying as the number one company in the industry as well.
Thanks, Sean. It's certainly an exciting time in quantum computing, and we, as Thomas said, we appreciate the support in Korea as well.
Thank you. To start off, I would like to ask some questions about the company's latest technical progress. Can you talk us through some of the key differentiators with IonQ's technology? What are the advantages of trapped ions to other approaches of building quantum computers?
Well, let's see. In general, you could start at the very beginning about the qubits themselves. They either fall into man-made qubits or natural qubits. And IonQ happens to be in the camp of natural qubits. And that has the advantage that natural qubits, especially in our case, are absolutely perfect. We don't manufacture them. Mother Nature made them. And they're literally identical because we're using individual atoms. Every atom is identical to every other atom within an atomic species. So that has the advantage that the manufacturing yield for the qubits themselves are 100%. So in people who are in natural qubits, you don't have a manufacturing issue, and that gives you kind of a big advantage. The man-made qubits, on the other hand, which are the ones being made in silicon, they're not, they're not a photon, they're not an ion. Instead, they're being made out of silicon. And they might be, for one qubit, 10 to the 14 atoms just to make one qubit. And every one of those has to be identical to every other one. And that's where you start to see some yield issues and a lot of the noise come into their computers. Now, what we all do share, even independent of kind of where you got your qubit, is being able to control the qubit. And in IonQ's case, that's where the error actually shows up, is our actual control of the qubits.
Okay. Then can you explain AQ, algorithmic qubits, a little bit more?
No, I'd be happy to. Maybe we could pull up an AQ slide to kind of help you understand this. So if you look at this, and this was when we announced the 20 algorithmic qubits, not the current 23. So this is a little out of date here. But if you look at the very simple definition, it says that to hit a particular AQ, you need to be able to do the square of the number of qubits that you have, because most algorithms require square of the number of qubits to be able to run. So if you look here across the x-axis, as you can see circuit depth or the gate depth. And you can also see that for various algorithms that they have different slopes. Like for instance, the Bernstein-Vazirani it's very vertical. So this one consumes qubits quickly, but doesn't consume gates very quickly. But then if you look at the Monte Carlo sampling as an example, it's more horizontal. And so that's consuming more gates more quickly. And so each algorithm consumes gates in a different way. But generally, for most customers, for most algorithms, you need roughly the square of the number of qubits. So if you look, for instance, in the Rigetti, this is one of their larger systems. As you can see, that they can run, let's say, roughly 20. It looks like from this, about 20 gates is the circuit depth. And if you were to say, okay, well, that's about somewhere between 4 and 5 algorithmic qubits. Even if they had more qubits, it really wouldn't matter because their gate fidelities are limiting the what they can run. Once the algorithm gets into red, then that means that it's now kind of returning noise. It's no longer working properly. So what you do is you draw a bounding box around as high as you can go, and then as wide as you can go for that particular thing, and that tells you what the number of algorithmic qubits. And the reason this is a good benchmark, and I'll just mention, the algorithms that are being used here, they were decided by the QEDC. This is not an IonQ set of benchmarks, and the actual code that we run is actually sitting in a repository. It's not IonQ code or anything else. So these are meant to represent the kind of algorithms that we think customers would actually want to run. So it's a benchmark really based on kind of what can you run on the quantum computers, and you can compare them from one to the other. And I'll just point out that this is logarithmic scales. So you can see across the bottom that it's growing kind of exponentially. And also the number of useful qubits is also kind of logarithmic. So if we were to draw this on a regular scale, you would see, maybe some of our competitors would be 1 pixel and we would be the rest of the page. But, so the boxes here don't seem like that much, but since it's logarithmic, then it's, there really is a huge difference here.
So this means that IonQ has the most powerful computer in the world in the application-based perspective, right?
That is correct. It means that IonQ's systems can run much more complicated circuits. So as an example, in the Rigetti case there, it suggested after you run about roughly 20 gates, it started to have problems. If you looked in the IonQ case, there was an algorithm there where it was running 672 gates before it started to run into problems. And that's kind of the size of the programs that you can run. So in an IonQ piece of hardware, you can run a much more complicated circuit.
Okay. Thank you for explaining that. To the next question, we'll talk more about commercialization later, but for now, at what AQ do we expect to be able to see larger scaled enterprise applications?
So, the experts kind of say that about 70 logical or algorithmic qubits is the area where quantum really starts to take off. What's interesting is that we expected actually much earlier for that to happen, in particular in machine learning. And we've been running a number of different projects with commercial customers and had some excellent results showing that we can beat the best classical. So I would expect kind of machine learning to be the first area where people start to say, I think I'd like to use a quantum computer for that. That won't require 70 algorithmic qubits. Maybe by the time we get to 35 or 40, we might start to see kind of very valuable machine learning applications.
Okay. Now I think we can move on and talk in depth on some of the technical progress that IonQ has made this quarter. IonQ area saw a massive increase in AQ this quarter. Can you talk about what made this possible?
Yeah, so something new, actually, kind of a little unexpected happened. We had thought before that there was two ways that you could run larger programs. One was make the hardware better, and the other one was to do error correction. And error correction just allows you to remove the error out of the hardware. What we found was a third way in the last 6 months, which is error mitigation. And so this is a software technique where you can remove the error. It's not the same as error correction. Error correction is really something you have to do down at the hardware level. But we could post-process some of the results to remove some of the error that was coming out of the calculation. And so ARIA is actually doing better than what we thought it would do, in part because the compiler and the software layer that runs it has gotten better over the last 6 months.
Okay, and from the roadmap, I saw that IonQ's goal is to have 25 AQ by this year, right? So what is your confidence on that?
Yeah, actually, I can try to step in and answer that question. So as Peter mentioned, we've been the algorithmic qubits is a measure from a user's perspective to run useful algorithms. So it is actually the probability or the confidence we can get good results out of bigger circuits. And what we are finding out is there are many different areas that we can improve to actually impact the algorithmic qubits. As Peter mentioned, we've introduced some new error mitigation techniques, new software and compiler tools, and better calibration, and on top of improving some of the hardware. So looking at where ARIA is today, and some of the early measurements we have done in our next generation system Forte, where we're starting to see much better gate fidelities compared to what ARIA is, and all of the advances that we have made on compilers and error mitigation techniques, that all carries over. I think we're very confident that we'll be able to reach this milestone before the end of the year.
Okay, then moving on to error correction. Is IonQ working on better error correction over it, or how far are you guys on the error correction?
Yeah, actually, that is an interesting question. I'm going to take a step back and share a little bit about what error correction is. We use error correcting codes during communication. I am sure when we're doing this video call, through the fiber optic channel that's connecting Korea and the US, there are lots and lots of error correction protocols that are going in to fight the channel's errors. And usually in error correction, what you do is you use additional resources or additional bits of information so that you can actually detect if something goes wrong in the middle of a transmission. Now that concept carries over to quantum computing. But when it happens, just because all of the operations in quantum computing it tends to cause errors, it turns out that the overhead in error correction for quantum tends to be very large potentially. And people have been looking at all kinds of different code families to see how to better implement it. But here, our goal is not necessarily to reduce the error overhead. Usually when you pick a code, the overhead is pretty well defined. What is really an issue is once you encode so that you have error corrected qubits, then you actually have to compute using the encoded qubits or error corrected qubits. And that computation tends to get very cumbersome. And that, if not done properly, will actually require very low errors before the error corrected qubits can perform better. So there's just a lot of optimization and studies that are still needed to make sure that once you pick a code, you can actually improve the computational result and reduce the error after implementing this overhead of error corrected codes. And that is actually theoretically, it's been analyzed quite a bit, but realizing that in the real world is a very complex process. People have started making some progress in some parts of error correction, but in order to show that you can do a fully error corrected computation better at the circuit level requires still a lot more progress. So, IonQ is making substantial efforts in taking a swing at this challenging problem. I think starting with quantum computers with low gate errors really helps. So I think improving our gate fidelities is really important at the physical level. And then all-to-all connectivity allows us to explore many, many different types of codes that are known and still to be explored. So our goal is to continue to realize improvements in circuit performance after applying error correction. And that is an ongoing effort that we're making a lot of effort in, and we're making some great strides in. We're not ready to share any of those results quite yet, but hopefully very soon.
All right, noted. Then could you highlight the difference between ytterbium and barium that are?
Sure. So ytterbium is an atomic species that we have been working with for a very long time. Actually, Chris Monroe and I, the two co-founders, have been performing research with this atomic species for over 20 years now. And we understand this qubit very well. Actually, when it comes to the real fundamentals of the qubit, the two systems look very similar. I mean, as Peter mentioned, both feature near perfect qubits in storing quantum information. But Peter also indicated earlier that the errors comes in when you're manipulating or controlling these qubits. And that's where some of the key advantages of barium comes in. So first of all, the lasers that are used to manipulate these qubits, barium, most of the lasers, if not all of them, are in the visible and in the infrared wavelength range, whereas the ytterbium qubits require lasers in the ultraviolet. And although those are available, they actually are technically a little bit more challenging to work with, and therefore the access to available technology to scale the systems is so much more accessible in the barium systems. We've also shown that some of the intrinsic errors, just because of the atomic structure and the wavelengths of lasers that we're using, the intrinsic error rates and therefore the associated gate fidelity is expected to improve in barium. And we're definitely seeing some signatures of that. We have shown that you can do better qubit state detection with barium. We actually improved it by almost an order of magnitude in terms of state detection errors. And those, I think we have room to improve it even further. And just because we have access to more laser powers at these wavelengths, we are quite confident that we can increase the clock speed and actually run faster quantum computation. So there are many technological advantages, but it actually is something that we're not as experienced in. Meaning, ytterbium we've been using for 20 years. Barium is a relatively new atom, so we are actually going through the process of verifying that we can actually build robust and higher performance quantum computers with barium at this stage.
Okay, so what is your roadmap for shifting to barium in the long term?
Well, as Jung Seng said, there's a number of advantages to barium over ytterbium. So I think the long-term kind of plans for the company would be to use barium. There's another aspect too, which is you really want to keep on working on your native fidelity of the systems, for as long as you can, because it allows you to run larger and larger programs. And you'd like to hold off for error correction, until you have enough physical qubits. And so what barium will really allow us to do is to hit even larger AQ numbers without having to go to error correction, kind of early. I think when people start to say 100% of their focus is on error correction, you could probably also interpret that means that the company is giving up on kind of making their quantum computers better. So barium allows us to kind of continue along in making the hardware itself better and postponing to some degree the day that we have to go to error correction. And at the same time, it means we can focus on getting more physical qubits.
Then we don't have any QC made of barium yet, right?
We have quantum computers which are using barium, yes.
Okay. When will we start to see IonQ's technology scale up by connecting quantum processor together through photonic interconnects? Could you explain this technology further?
Yes, I can answer that question. So, if you think about how we make the most powerful classical computers today, we think about these gigantic supercomputers or data centers. And there, instead of making a computer chip the size of a football field, what we do is we build a very large number of these computers, fully functional computers, and we collect hundreds of thousands of them and then connect them through the network so we can actually gain the computational power that way. And that's sometimes you call parallel computing, and that's how we actually scale the power of classical computers. I think we have a very similar architectural approach to scaling IonQ's computers into the future. And this is the notion of photonic interconnects. So what happens is, in order unlike classical computers, if you want to really harness the power of two quantum computers to do a bigger calculation, you have to connect them through a quantum channel, meaning your quantum problem has to be larger problem should be distributed over 2 computer chips or 3 computer QPUs and 4 QPUs and so on. And what's really needed is the ability to kind of transfer entanglement between these nodes. And that is a quantum communication channel. And that technology of doing a fully quantum communication between different nodes of the computer is a very, very exciting opportunity. It turns out that my colleague and co-founder Chris Monroe has demonstrated the very first protocols of distributing quantum entanglement between different QPUs almost 15 years ago in 2007. So, there on the trapped ion side, the protocols are known and they have been demonstrated. And what's more interesting is over the last 15 years, the rate at which we're generating this entanglement. You can think of it as the speed by which you can do quantum communication between QPUs have really improved by about a factor of about 100,000 over the course of the last 15 years. So, this is kind of starting to be a pretty mature technology in terms of its scientific basis and the technological demonstration. So, I think the the principles of how to do it is extremely well known. Unlike in other qubit technologies, this is a pretty kind of mature scientific protocol. And what we're working on is to engineer that so that it can be integrated into our QPUs, so that we will be able to connect them together and distribute the real computation across. And that technology development and integration process is a relatively long development process. So we're actually making some great strides in pulling that technology into IonQ's technology base. But it will take a few years before you will see quantum computers, IonQ quantum computers that are connected through a photonic interconnects as a product.
Okay, I see. Our next area of conversation is commercialization. Can you guys talk us through some of the projects you're working on right now?
Yep, I can take that one. So they kind of fit into a couple of different areas. The first one, machine learning. As we talked about, we thought machine learning would be kind of the first area that starts to fall to quantum. And so we've been working with a number of companies like Hyundai on machine learning projects. And this one, a general object recognition for self-driving cars. Things like GE, risk analysis, being able to identify risk. Fidelity, very similar kind of project, also machine learning. And Goldman Sachs, as an example, another machine learning algorithm. So machine learning is certainly a hot area where we're seeing lots of work on right now at the company. The next one would be chemistry. So we just announced, as an example, with Dow, and also we've been working with Hyundai in battery chemistry as well. So battery, chemistry in general is something where we think quantum will have a huge impact. A new announcement we just made is that we're working on natural language processing or strong AI. And so this is the area where you build a smart computer. And there's some suggestion that maybe kind of human intelligence might actually come from a quantum process. So we're just doing the first little investments in that to see if we can kind of make progress in that area. And then the last one is, and it's a new area for us, is logistics. And so the Airbus announcement in aircraft loading is an example of that work. And so we expect to kind of expand into that. There's an infinite kind of set of things you can work on. We hear people that have ideas, in many different areas. It seems infinite. But at the company, you have to kind of decide what are the areas that we want to be good at. So, and sadly, we don't have enough resources to be good at everything. So we've kind of focused on these areas as the areas where we want to kind of be experts in.
And also, we as investors are very interested in your system sale business model. Could you guys update us on that as well?
Absolutely. We've always said that we have 4 ways of going to market. The easiest way to interact with us, where it's very limited friction, low cost, and you can just surf up. If you have $10 on an AWS credit line, you can program an IonQ, so you can go through the public cloud. If you want to be more assured of when your job is running, you can go through our private cloud. Additionally, if you know or you think that quantum might be helpful to your business, but you don't know how quantum works, you can sign up with us, and we have a team of application engineers who will help you by taking your domain expertise in the business that you're in and couple that with our expertise in quantum algorithm development. And since we started our commercialization phase, we've said that we anticipate that organizations will want to buy systems outright. We didn't know quite when that would happen, but it seemed like it would happen because it has in all other areas of computing. What we're seeing now is that there is a lot more interest in buying systems outright a lot earlier than we had anticipated. Some of these reasons stem from academia, where if you're developing computer scientist, you want to have unfettered access to your own quantum computer. Some of it stems from security industries, where you just need to have complete access and ensure that nobody else does to your hardware. And then we also anticipate that in private industry, you will see applications where timing is so important that you can't afford to not have first priority access. Some examples of that would be if you're developing a pharmaceutical molecule and you want to model that, some of these algorithms can run for months before you get to an answer. And some of them run in conjunction with classical compute, and there's a lot of messaging going back and forth. Now, if you go through a private cloud or you're in line with others, the queuing system could actually cause the time it takes to execute your program by months, if not years. And so if you're trying to bring a new drug to market, these drugs often bring, if it's a blockbuster drug, can bring in more than $1 billion per year. So just speeding up development by 1 month is incredibly valuable to these companies. The same goes to if you're pricing derivatives in the financial markets, and you're trying to do that at market open, you want to be really sure that it happens at market open. And while we can't forecast which one of these is going to happen sooner, we're just seeing a lot more requests for what it would take to purchase a system outright. And we anticipate that this will actually happen inside of 12 to 24 months for us.
Okay. And moving on to the last topic, I would like to ask about your future organizational plans. Can you guys talk us through your major goals and landmarks for the rest of the year and for the next year?
I'm sure I'll take that one. So if you've probably seen a couple of slides that look at our both financial objectives and our technical ones. So I'll do the technical ones first. Just before we went public, we showed what our roadmap was for several years. So our goal for this year was 25 algorithmic qubits. And so we just announced 23. So we're not quite there yet, but that's kind of the focus for the company, is to get to 25. There's also on the technical roadmap, it's obviously working on barium and photonic interconnects and error correction, numerous other things. So I would expect that, this year and next year, you'll hear about some of the progress that we're making on that front. In 23 on the technical roadmap, it's now going from 25 to 29 algorithmic qubits. And so again, just constantly, pushing the computational power of the quantum computers. On the business front, if you look at our original estimates, we originally said that last year we would do 5 million in bookings or recognized revenue, and we did actually 16.7 in new bookings. This year it was about doing 15, and so you're seeing now that in our latest midpoint guidance was we're doing 25 in new bookings. So we're running kind of ahead of our plan in terms of bookings, and doing quite well on recognized revenue as well. So the financial results are working better than we originally had projected. And that obviously, as we continue to do that, means that we'll be running ahead of our original projections. And as Thomas mentioned, one of the things we had not planned kind of so early in the cycle was people wanting to buy whole systems. And so those are great places to generate, a lot of revenue fairly quickly. So we think, between now and the end of 23, you should start to hear about a system sale or two. So that will be exciting for the company as well.
And one of the newer announcements was expanding operations in Europe, Israel, and Seattle. And we actually found that out before the public announcement, which was very exciting for us.
Okay.
We were wondering, what does this mean going forward for IonQ?
Well, it's there's really two different things going on here. So the first part is we're looking to open an office in Seattle for manufacturing, for producing quantum computers, that more of them, to kind of take the Henry Ford effect and be able to build an assembly line, if you will, for quantum computers. And that group in Seattle is going to be focused on a different aspect of the hardware. They're going to be focused on how to produce a product. And it's funny, in College Park, what they are working on is how to build a bigger quantum computer. But they don't really, in College Park, their focus is, for instance, not how to make it easily serviceable in the field. But in Seattle, those are the kinds of things they're going to be working on. So Seattle's focus will be how to make it so that it really is a product where today it's kind of more bespoke. And then they'll be working on being able to build products that can be serviced in the field, working on reducing down the both size and the cost to build those systems. And that's a very different goal than College Park, which is worried about, how do I hit those AQ numbers, and how do I get photonic interconnects work, and those kinds of things. And then if you look at Europe and Israel, is that we see a great deal of interest internationally, and so there's a hotbed of quantum today. Obviously, Australia, Japan, South Korea, Singapore. There's a whole range of countries that have a strong interest in quantum and a growing interest. And so we're starting to see us expand into other locales so that we can start to be set up so we can service customers, and our sales team, can call on customers. So this is just the beginning of kind of international expansion, and us being able to kind of go after a much larger world market. I would expect over the next couple of years that you'll hear other announcements as we continue to grow.
Okay, that's pretty exciting. And can you speak about why you are choosing to build your production engineering team in Seattle, Washington, rather than College Park? And how do you think about that office in relative to the major cloud providers? And how does rack mount play a role here? I think Thomas can.
Absolutely. So as Peter said, what we're trying to do is to create two hubs. One hub that's really focused on generating the best quantum computers possible, and another hub that brings them to market. These are really two different functions, where one is very focused on being on the leading edge, and the other one is trying to productize this and make it repetitive so that we can stamp these out and deliver it to many more customers. At the same time, Seattle is, of course, home to both Amazon as well as Microsoft, and it gives us access to two of our major partners, as well as a lot of engineering talent. And what we will see is that we want our College Park or Maryland office to focus on bringing faster machines, greater capacity. What we want Seattle to do is bring machines that are immediately useful and accessible to customers. So we expect that we will see miniaturization to come out of Seattle and more qubits to come out of Maryland.
And about the rack mount, could you elaborate on that as well?
Yes, so that's what I meant by saying miniaturization. It is having it focused on fitting the customer's needs where the customers are, whereas we want Maryland to focus on the performance, just more bigger computers that can tackle more and more complex problems.
Okay. To the last question, what do you think the applications of IonQ system will be in 2023 and in 2025 and eventually in 2030? I mean, 2030.
Yep. I can take that one. So I think in 2023, you'll see kind of a lot of progress in both machine learning, some early chemistry applications, and first applications in logistics. So so those are certainly, as we've already started in that, but we'll see a lot more kind of progress in that front. By 2025, well, 2025 and 30, it's certainly starting to get more speculative. So this is probably opinion more than anything else. 2025, you'll start to see chemistry applications, which now are much larger molecules. And as you grow the size of the molecules that you can do, their commercial interest starts to get larger and larger. By 2030, I think we really start to have systems that can take on very interesting, molecules in chemistry, especially for pharma, and but also probably for material science. I would hope also by 2030 that we're, if it's true that quantum can help in strong AI, by roughly that time frame, we're starting to see a lot of progress in that. I enjoy, there's a Microsoft video for 2040, and which I enjoy. It's about the Xbox.
Oh,
And so it's an Xbox Microsoft video that shows what the Xbox will look like in 2040. So it's still, it's an Xbox, so it's still small, but it's powered by a quantum system. So maybe, that Microsoft put together that video, maybe the future Xbox, future gamers, will actually be on a quantum system. I think it was their, kind of pitch for the Xbox will be the hub of the metaverse in the future. So we look forward to, who knows if those things will come to be, but it's certainly, it's quantum is inspiring people's imagination.
Okay, that's very exciting to hear. All right, so I think our time is almost up. Before we conclude this call, do you have anything to say to the IonQ investors or to the Korean long-term investors?
Yes, maybe I'll speak just because I was born and raised in Korea. I think this quantum computing is a very, very exciting opportunity for the future. Now it is growing. It is an early stage, but we are convinced that if we can actually execute on our plans, we can actually make a big difference in many industry sectors. So we're actually kind of making a highly focused and extremely hardworking team to bring that to reality. And I think it will require a lot of effort from our partners, our investors, and our customers to really find real world use cases for that. So what we can promise is we're going to do our best and continue to innovate and stay at the bleeding edge, listen to our customers' needs so that we continue to build useful machines that will deliver real value. I would like to see much better communication. If the investors have questions, want us to actually look in different directions, have any feedback on how we're doing, we'd love to hear, continue to communicate on that, and we'll make an effort to share the exciting progress we're making with the investor community as well. And thank you for your support.
All right. Well, thank you all for your time. I wish the best luck to you and to IonQ as well.
Well, Sean, just thank you from all of us at IonQ, and also to everyone that watched and listened to the video. Sean, the next time you're in College Park, maybe we do a video tour through the IonQ headquarters. You can actually see some of these. So
yes, I'm actually planning to get there by next May with another YouTuber in Korea.
Awesome.
So
okay.
I'll be meeting you pretty soon.
Sounds good. Sooner than I didn't know that, so that's great. We'll look forward to host you in College Park.
Okay, thank you. Okay, so this concludes our fireside chat with IonQ. Thank you everyone for staying with me, and I hope to see you again very soon. Goodbye.
All right, thank you.
Thank you, Sean.
Thank you.
자, 이번 영상은 2023년 5월 말인데요. 제가 아이온큐 본사에 전인구 대표님이랑 같이 가서 임원진들과 인터뷰, Q&A를 가졌던 영상입니다. 직접 아이온큐 메릴랜드 대학교 안에 있는 본사에 갔었던 영상입니다.
아이온큐에 도착했습니다.
네, 드디어 왔네요. 진짜 고생 끝에 왔습니다.
아니 진짜 잠을 못 자더라고요.
네.
아, 속도 안 좋다고 그러고 스트레스 받더라고요.
네, 둘 다 고생이 많았죠.
예. 아무튼 여기 좀 장면을 좀 보여드리도록 할게요. 여러분들 입장에서 입구가 어떤 느낌인지 한번 보여드리겠습니다. 지금 이렇게 들어갔어요. 그래서 이렇게 위에 있는 곳을 설명해 주실래요? 메릴랜드 유니버시티?
네, 여기가 이제
네.
메릴랜드 대학교에서 스피노프를 했기 때문에 그 대학에 있는 부속 건물을 지금 캠퍼스로 쓰고 있는 거고.
아, 그럼 이게 대학교네요, 여기가?
그렇죠. 이 안에가
어.
전체 다 대학교고, 이제 Q랩이 양자연구소.
아.
그리고 이 아이온큐랑 메릴랜드가 같이 하고 있는데 그 건물이 이제 아이온큐 본사로 쓰고 있는 거죠.
아.
그 주소는 이제
예.
저렇게 돼 있습니다.
예. 뭐 대학교니까 와서 지나가 볼 수 있을 거예요. 자, 그리고 한번 들어가 보도록 하겠습니다, 그럼.
그리고 건물 자체는 1층짜리로 이렇게 돼 있는 것 같아요.
예.
크진 않은 것 같고.
아니, 보통 시가총액이 조가 넘잖아요, 우리나라
네네.
돈으로. 그래서 저는 건물을 되게 의리의리하게 지었을 것 같다 생각했는데 그냥 연구소 이렇게 대학.
저 진짜 연구소에서 시작한 기업이죠.
네. 직원들은 몇 명 정도 되나요?
어제 저녁에
네.
공식 대답을 들었던 게 200명이 넘었다.
200명이
네,
넘었다.
앞으로도 계속 확장할 계획이다라고 했습니다.
아, 이게 대학교 아니에요? 왜냐면 차 대수가 200대가 아닌 것 같아서.
네네. 여기도 있고 이제 시애틀에 공장을 짓고 있으니까
그 합쳐서.
그쪽에도 직원이 꽤 나가 있어요.
아, 그럼 여기 연구소고 이제 공장이 또 따로
그렇죠.
있는 거예요?
여기는 이제 연구소 역할.
아, 그럼 우리는 연구소에 이제 방문을 하는 겁니다.
저거 이렇게
이렇게
또 로고가 박혀 있는.
예, 아이온큐라고 되어 있고 저희는 오늘 아까 저 출입 보안을 하고 잠깐 밖에 나와서 다시 또 그 장면을 다시 또 찍고 있는 겁니다. 출입 보안이 좀 빡세더라고요.
네. 기밀 유지 뭐
기밀
이런 것도
유지.
써야 되고.
예, 그러니까 이 기밀이 유출될까봐 되게 염려를 많이
네,
하더라고요.
가진 게 기술밖에 없다라고 어제 또 얘기를
뺏기면
했죠.
큰일 난다.
네.
네, 알겠습니다. 여기서 이제 저희가 허가받은 영상만 찍어야 돼서 여기서 잠깐 끝내도록 하겠습니다. 자, 그러면은 자, 들어가 보도록 하겠습니다. 자, 벨 눌러주세요. 네.
네, 저희 이제 아이온큐 임원분들과 Q&A 시간을 가지려고 합니다. 이제 중간에 계신 분이 이제 피터 제프맨 사장님, 그리고 오른쪽에 계신 분이 토마스 크레이머 CFO시고, 이제 이쪽에 계신 분이 조던 셰프리오, 이제 IR 담당자이자 파이낸셜 플래닝 부사장이시고, 이제 여기 다 아시는 김정선 교수님 CTO시자 공동 설립자시고요. 크리스 먼로 교수님은 이제 오늘 다른 일정이 있으셔서 못 오셨다고 합니다. 그래서 오늘 한 40-50분 정도 사전 질문지로 Q&A 세션을 가지도록 하겠습니다. The first question that we have is, will IonQ's QPU networking prototype, which contains the photonic interconnect, would be released to public on this year? If not, when can we expect that to happen?
Yes, so we currently do not have any public timeline for release. These are definitely we're working on these new technologies that will get us to scaling.
Because I'm pretty sure I saw the timeline somewhere on the news, but it wasn't official.
Yes, we're actively working on it
Ah,
right
okay.
now. So very
Okay.
actively working on that particular piece.
And the second question we have is, recently ChatGPT is getting a lot of attentions. So can quantum computer be utilized in this AI field? If yes, how and when do I think that to happen?
Peter, that's your
Yeah, that's fine. So we think so. Of course, you never know until you actually do it.
Yes.
But that's an area we're also investigating right now. We just came out with a paper, our first kind of effort. We started on working on NLP and AGI
Yes.
about a year ago. So a little bit before the chat GPT kind of craziness. But there's lots of reason. We already knew that that ML was going to be strong on quantum. And of course, if you look at what it is OpenAI has done, it's using large models, large language models. And we think that those will work fairly well on quantum computing. There might be other approaches also besides generative AI to solve this problem. Maybe quantum is actually more natively like the way human brain works. So maybe there's some other solutions to solve that problem.
And I think one of the things, even Sam Altman, he came out and said these ChatGPT type models are extremely resource intensive. Right? It's a huge model, need a lot of data to train. And I think what I read, that he indicated that the next generation of ML will have to become more efficient in order to yield more power. So there's a lot of kind of open questions about how both AI and ML will evolve. And I do believe that there's a lot of role that quantum technology can play.
The next question is the partnership with Hyundai a long-term thing? What is the partnership's ultimate goal for IonQ?
Well, that's a great question. I think Hyundai is a great partner. I think it's a great partner because we understand the opportunity and we understand the risk. So in that sense, I think our partnership has worked out very well. We've been working with them for over a year now. Our collaborations are still very strong. So I think that's going to continue. Of course, Hyundai's interest is whether quantum computing can eventually kind of help their main line of business. And our interest is if we can help them identify that, and then when that happens, we're going to be to help them deploy that. So in that sense, I think our interests are aligned. Exactly how that's going to pan out, I think it depends on how productive we are.
A lot of people actually ask this. So how is it possible to jump from 2024's 35 AQ to 2025's 64 AQ just in any year?
So part of it is we work on multiple generations of hardware at the same time. So it's not like we're starting at the beginning in just 1 year going to make that. The 64 AQ system has been, we've been working on that kind of now for several years. There's multiple machines, each one of them on its own parallel path, pursuing different aspects of that system, which then will all come together in that one system. So it's not just 1 year, it's actually multiple years to build that system.
Well, I understand that in 2025, IonQ will deploy the error correction 16:1.
Yep.
So they will contain more than 1,000 physical qubits, which means you guys will have multiple QPUs.
Well, so this is when you have a roadmap, right? It doesn't mean that I know exactly what to do 5 years from now. It's actually both a goal, and then from that we actually work backwards. What are the technologies we need to start investing today? What are the problems and questions we have to ask and solve today, so that we can actually hit those kind of milestones in the future? So we've actually started out, as Peter mentioned, multiple elements that are needed. Some of them are kind of interconnects so that we can go to multi-modules. Certainly, we have to be ready for increasing the number of qubits dramatically. We focus on error correction. We actually focus on getting better gates. All of these things are elements that we've been working together. And then, as these different fronts evolve, we have a better view of exactly how to actually achieve AQ 64 2 years from now.
And sometimes we work on multiple things that compete with each other because we're not sure exactly which one will win out. So we're working on, if you look on error correction on one side is one way to the answer. The other way would be better gates. So we're pursuing both paths. And so it's at the end we will choose the best technologies that actually seem to work. So we're often working on solving the same problem with multiple solutions, so that we're kind of de-risking our roadmap going forward.
So how is the current IonQ's QC operation speed compared to the current supercomputers?
Yeah, so the real interesting question is, as the AQs grow, as the quantum computer become more and more powerful, we can actually start to do things that classical computers just cannot do. Right? At that point, the speed for small tasks, yes, we have a very, very powerful computer, but the real value of quantum computer is to be able to do things that classical computers will take ages to complete, right? So I think it's really the scale at which super quantum computers actually outperform classical computers increases very rapidly. So, for example, if we get to AQ64, we can actually do things that classical computers, even the best supercomputers, will never be able to do, right? So that's kind of the lens by which we have to look at it. And that's why we believe that the first and foremost, we should get to higher AQs so that we can actually outperform any classical computer.
But even in classical computing, you know, you don't see people today competing on kind of clock speeds today. That if you look at the architecture of your laptop, there's a lot of different factors that actually turn out to be the performance of that laptop. We do acknowledge that we want to get our gate speeds to be faster, but we don't think that that's the only answer to this problem.
The current speed is not where we should be focused on.
It is one component. It's
an important component.
It's an important component. It's just not the only one. So, and especially in these early days, you know, what most people care about is not how quickly you can get to the answer, but can I get the answer?
Okay.
And so, as we get to much larger quantum computers, the gate speed will start to have a larger impact, but it has a smaller impact today.
And it's like when we put the man on the moon, nobody did an expose on fuel efficiency. But fuel efficiency was important because you have to carry all that fuel to get it up there. But there's so many parts of a rocket, and you just want to say, well, can you put the person on the moon or not? And can you solve very complex problems or not? That's the first one. And then how long did it take you to get there? Right.
I'd be willing to wait 2 years to get a cure to cancer.
Right.
It's one of the reasons we've moved to barium,
right.
was to improve gate speeds.
So barium QC, well, I'm not sure if I should ask this question. I expect it to be announced pretty soon, so will there be any hints on that?
Well, again, we have not
okay.
decided on the timeline to announce on our barium systems, but we're certainly working on
okay.
multiple fronts.
Okay.
Yeah.
So how long will it take IonQ's QPU to become as small as the classical computer CPU? So original plan, I think, was 2023 to chip size. So what's the current status of this QPU miniaturization?
I actually showed you
Yeah.
the QPU. It is the same size. And if you look at an Intel CPU, it's actually a little bigger. The size of the overall computer now needs to shrink. So now what our focus is to take the entire computer and start to shrink it to go to rack-mounted, smaller footprints.
And you know, eventually the volume and adoption and industry manufacturing, all of that is going to drive that part of it accelerated very quickly.
If you looked at the lasers that were originally used in Blu-ray players, they were large.
Right.
But it wasn't until we started to put them into commercial electronics that they got smaller and cheaper. So it was the volume, the Blu-ray volume, that allowed that to happen. So we just need to sell as many quantum computers as Blu-ray players, and we'll be able to shrink it down as well. So
That's true for classical computers too, right? The mainframes, they sell very few, it's very large. Whereas iPhones, we sell tens of billions a year, and then they become very small. They shrink down. So there's a direct correlation between volume and size.
So you guys expect quantum computer to be a size of smartphone someday when the market grows? Someday,
No,
right?
Probably not next year.
Right.
Microsoft produced a video for the Xbox.
Yeah, I
It was the
actually saw that.
2040,
Yeah.
you know, video, and it showed a little Xbox, and it was supposed to have a QPU. in
Yes,
it,
right.
Like all these technologies, they're all going to shrink.
Yeah, I mean, even these guys, if we go back, you know, to the 70s and 80s, and say, yeah, you're gonna have this like amazing device that is more powerful than, you know, this amazing, you know, the biggest mainframes. Everybody will be carrying into their pockets. I don't think too many people saw that coming.
So when you think about the first computers, they were big. And they're big because you took parts that were used elsewhere and you put them together and you made a computer. And those parts were just big elsewhere. That's what we're doing. We're taking standard parts. They're standard lasers, and they're big because in an industrial environment, you don't necessarily care about size. But once you start caring, then it starts happening with just more applications and more usage.
All right, we'll move on to the financial question. So, is there any update on the financial roadmap that implies IonQ will turn to profitability in terms of net income in 2025? Since IonQ will be selling the quantum computers from 2024, which will generate huge revenue, as I believe. What do you think, Thomas?
Because things are always changing, it's impossible to say. Like Amazon was going to be profitable after 3 years because then that could ship enough books. Like nobody even buys books on Amazon anymore, right? And so what we are doing is we're setting up a way for us to reach our current roadmap, which we fully believe that we can. But it's possible that we also start developing other things that will change that roadmap and will also change how we finance it. But nothing has changed in our financial outlook. We're very comfortable with where we are. We are the best capitalized quantum computing hardware manufacturing company in the world by a long stretch. And that is an amazing power for us, which we can use to develop more technology, or we can also find partners to help us do that.
If we're getting to the point where we're selling lots and lots and lots of quantum computers, we'll have to stand up factories. That will drive profitability down for some period. So it's just really difficult to kind of predict that future. What we can say is we have sufficient funds now to kind of get to AQ64 and kind of get to the promised land of finding the first applications that have quantum advantage.
I guess people wanted to know that the financial roadmap was established 2 or 3 years ago, and now you guys are talking about QC sales. So people wants to know if the revenue will be happening a lot faster than the previous outlook.
Well, so far it's been already happening a lot faster than we originally predicted. So we kind of expect that to continue.
So what is the total estimated number of employees that will be working in the manufacturing facility in Poseo?
I think it will be a function. These manufacturing is a function of volume, right? If we have a lot of orders, then we'll be making more. If we don't have orders, so it's a bit of a
chicken and egg.
it's a bit of a variable there. We need some infrastructure to do that, but exactly how we ramp up depends on kind of our business growth. So I don't think we have an accurate number. I think the 40 to 60 is kind of what it takes to build the infrastructure.
Okay. People wants to know what is the product that will be produced in Basel first. Will it be Aria or Forte or new generation of QC? Will that be answerable?
It'll be a new generation of QC.
Oh, not Aria or Forte?
No.
Okay, that's interesting. And people wanted to know, could you be a little bit more specific on the numbers of the 9 figures that we talked about from occurring from selling the QC, because the number range is really wide.
Is you asking the question, how much are they? Is that?
Yes.
We don't publish prices on it,
Okay.
but you should think expensive.
Again, I think we speculated that if the demand pick up quickly, we get to nine figure bookings sooner than we expected.
Over a series of years.
Yeah.
And we are well on our path to do that. As we've seen, there's a lot of interest in purchasing full systems. Usually you can think of a quantum computers as selling in the multiple of tens of millions of dollars.
Okay, I guess people...
Each one's quite significant financially.
At this stage of computing, of quantum computing, we're not just making iPhones and they're all the same, they're standardized and have one price.
Right.
Every single computer is slightly different from the next, and we tailor them to the individual needs of the customer. And that means that we also like to have the opportunity to price them slightly differently so that we can give the customer what they want.
He wants to know about the IonQ's cash. Will that be more focused on used on the production or on the development?
The answer to that is Yes.
to both.
We have to do both. Both
Ah.
are very, very important. Like
Mm-hmm.
we need to spend a lot of money on development because we need to continue to produce new generation of PC. We're not where we want to be. At the same time, we also want to produce computers for our customers to use and buy.
And the two complement each other nicely
Right.
because the production side is looking at making it more stable and smaller. And then one of the interesting things about photonic systems is as you shrink them, they become better. And so, so we have two different teams. They have different goals,
Right.
but at the end, it turns out both teams are actually working on producing better quantum computers. And I can imagine in the future that the production side of the house is working on producing manufacturable, easy to produce, and some of those technologies come back to the engineering side. And so we have kind of transfer of technology between the two teams going back and forth.
I guess he wants to know whether the cash. Do you guys have enough cash to
We
until
do.
the profitability?
Yeah, no, we have more than enough cash to kind of
Yes.
get to where we need to get to. That point.
Yeah, if we need more cash to produce more computers for customers, that's a good thing.
Yeah.
Right.
Even if you have to wait to receive the cash because the customer said I will pay on delivery, you can finance that. And so those are good problems. I take those problems and need it.
Yeah. We have sufficient cash to get to profitability.
All right. And the last question is for Peter. What is your management philosophy? People wants to know that.
Ooh, geez, that's a good question.
Tough question, right?
Back in the 90s when Bill Gates and Microsoft was kind of the company, and they asked Bill Gates what was his management philosophy. He gave an answer which I really liked. He said, I hire people to do work for me, and I trust them to do it. And I don't like micromanaging them. And if I find myself micromanaging them, then I know that's a sign I need to find a new leader.
Right.
And so I use basically the same philosophy. I try very much to hire the best people I possibly can. I don't like micromanaging people. That seems to me if I'm there, then I've done something wrong and I've hired the wrong person. So I try to give kind of our senior leadership team the room to be able to do what they need to do without a lot of management. And so far we've been very successful of hiring kind of some of the best. And my goal at the end is, I guess maybe Bill might have said it in a different way, his goal was not to do lots of management, but to hire a bunch of good people who actually do it for him. So I guess I'm the same way.
자, 다음은 2024년 6월 말에 퀀텀 코리아, 이제 한국에서 열리는 양자 컨퍼런스에 왔었던 아이온큐 임원진들과 가졌던 인터뷰입니다. CFO였던 토마스 크레머 CFO와 이 당시 IR 담당자였던 조던 셰피로 상무와 인터뷰를 했고요. 조던 셰피로 상무는 지금 양자 네트워킹 부서 전무 책임자로 갔고 CFO는 은퇴를 했죠. 네, 여러분 안녕하세요. 오늘 저희가 또 이렇게 아이온큐 귀빈분들 오셔가지고 인터뷰를 하도록 하겠습니다. 여기 계신 분은 이제 CFO 토마스 크레머이시고 이쪽은 이제 IR 담당이시죠. 이제 파이낸셜 플래닝 담당하고 계시는 조던 셰피로 상무님입니다.
Hi, thank you for having us. Hello, thank you for having us.
Okay, so we have a whole list of questions. So I'll start off by the first one. Will IonQ be able to demonstrate photonic interconnect by the end of this year, like Peter mentioned on Q1 earnings call?
So yes, the goal is to complete those milestones for photonic interconnects that we announced on the Q1 call. And so we've completed that first milestone, which we're excited to be able to share.
From Dr. Butler, he told us that this might be implemented into the actual product maybe sometime after Tempo. So can we get like an estimate of when it will be applied?
That's right. We haven't announced exactly which architecture, and in part that's because we're still designing architectures for future computers. But we know that Tempo won't require photonic interconnects to hit its AQ levels.
And then for error correction, how about error correction?
So tempo, we also believe we don't need error correction. When we had our analyst day last September, one of the exciting announcements there was that we didn't think we would need error correction to get to AQ64 using tempo. We thought that we can do it with error mitigation. And so that's the same concept. We believe that we will get to tempo without photonic interconnects and without needing error correction to hit our AQ performance level.
But tempo will contain multi-core technology with additional error mitigation techniques.
That's right. That's the plan. But the idea is for tempo to, come out with a new set of techniques in multi-core.
It's important to also understand why are we talking about photonic interconnects when we're saying it's not going into our next generation computer. That's because we want to expose the underlying technology to make people understand that while this sounds different, difficult, maybe strange, these are very well understood scientific concepts, and we are just implementing the steps needed to implement that technology. And we want to give people an insight into how that is done along the way. And when it comes to error mitigation, for instance, there are many ways of doing error mitigation. And what we have found is that there are ways to implement error mitigation that's less taxing on the computation. And when we can implement this is better for time to solution. And these are all things that we're working on, and that is fun to share when we get to talk to people like you and others.
Please elaborate on the comments made by Peter about taking loads from NVIDIA. Is hybrid quantum processing being tested, or are there any plans to deploy this for AI at scale?
So we don't believe that Peter intended it to sound like NVIDIA is going to ship us jobs that require us to process them. That what we do know about machine learning is that it is so intensive on computers that it will not be economical to get them done on NVIDIA cards when what you need is so intensive and you will need so many cards for such a long time. It's estimated that most large language models today need an average of 3 months of an entire data center's worth of computation. And when you can run things on a quantum computer that requires fewer iterations, fewer input variables, and in addition often have a more prescriptive output, that's when people will select from other computational methods onto a quantum computer.
So it might take some time for people to realize that.
We absolutely do not think that NVIDIA will be out of business. And in fact, we welcome the opportunity to coexist with NVIDIA.
Please update us on the Dell partnership and how Salesforce, as Peter previously stated, will help us sell quantum computers.
Yeah, so we have a partnership with Dell, and we are very excited about having the ability to work through Dell. The reality is that the quantum space is still in its infancy, and so we're not able to get the full use of all the thousands and thousands of Dell salespeople, but they are getting trained, they are getting inculcated with the information about quantum, and so they will be there when the market is ready to take a third-party salesperson to go and buy quantum from. Right now, we are being introduced through them.
So one of the reasons why Bill joined IonQ's board of director also goes with it.
Yeah, it's very helpful to have someone who has managed Dell's Salesforce in terms of helping to usher that partnership forward.
Right now, the most immediate impact from Bill joining our board is because he knows how this works. It's not that he can necessarily go and take our quantum computer and throw it into the hands of customers, but what he can do is he can help us market ourselves towards compute buyers. And he already has had many conferences with our head of sales, Prima Almedin, and it's fantastically useful to have somebody on board who can do that for us.
Does IonQ have enough cash until turning to profitability, and when do you expect to reach BP?
So while we haven't given any current forecast beyond the end of this year, one of the good things about quantum computer is that they're so expensive. Now, on the one hand, it's not good that not everybody can buy one right now. But on the other hand, while we are in this phase of our existence, it's good that each quantum computer sells for so much money that it helps pay for the time it takes for us to get up to scale. And so we believe that our cash reserves are very helpful to us. And by the act of selling computers, that is actually adding to the cash balance. It's not like we're just burning down our cash balance.
So many people think the IonQ's cash run rate is between 2 to 3 years. So people are worried if IonQ could really, generate a lot of revenue or not. So can you elaborate on those parts too?
That's just as Thomas was saying, where we haven't put out a specific break-even point
Right.
as guidance into the market beyond this year. But also to what Thomas was saying, the fact that we have cash inflows at some point starts to offset the outflows as well.
Regarding the $500 million shelf offering, what kind of companies are being considered as IonQ's M&A candidate?
We've never made any specific announcements about specific companies that we're targeting, but we've always said that we would look to acquire companies opportunistically if they can accelerate IonQ's technology roadmap. And so in the case of the Entangled Networks acquisition that we announced last year, that was a great example where we found a team that was well aligned to what it was that we were doing technically, and they've gone on to become leaders in the company on the technology front.
The webinar that got canceled, it's rescheduled for now, but is there a reason why it was canceled?
I am absolutely sure there was a reason. I don't necessarily know, but I imagine that it was scheduling. And the fact of it is that we haven't given many webinars. Typically, tech companies, they have one with regularity and it just comes up. And there was a lot of importance given to this webinar, mostly by outsiders. And so we were focused on other things at the time that was rescheduled. It is scheduled to happen on Friday,
Korea time. Thursday US time.
Yes.
Yeah.
While we think it's an exciting webinar, we don't think it's one that changes the fundamental reason for why quantum is good, or why we've always said that we're winning the space race, today's space race, which is quantum, but we will absolutely give some more insight into how we're doing it. And we look forward to hoping that all of you listen in. But we also look forward to giving more of these so that they become more of a regular occurrence and so that people can use it as a way to continually learn about IonQ.
That's right. A big company will run webinars all the time, will run events all the time, and I think there's a lot of focus on IonQ given our stage today, and like Thomas said, given that we haven't done a ton of webinars. But eventually you want these to become very routine things, and they're just as much to update the community about what it is we're doing as they are about attracting customers to IonQ and continuing to sell our products.
Recently, Q Control published that by using their software on IBM's 127 qubits QPU, they were able to outperform of optimization problems than the results of Continuum or D-Wave, which was shocking for us. Is IonQ working on software or algorithm side, just as Q Control is doing, or are there any partnerships regarding?
So IonQ is working on software, and we've always said that we're a full stack company.
Right.
And the paper that you're referring to, I haven't personally gone through, so I can't comment on that paper. But I would say we are frequently using software techniques, and we explain to the market when we do. So for example, when we use new software techniques to improve our latest algorithmic qubit performance benchmark, we spoke to the market a little bit more about what those were and how we use them. And so we're going to continue using software and hardware in tandem, being that best quantum system company that we can be.
So for IonQ, what is the proportion between the hardware person and software person.
It's a good question.
That?
I don't know if I know off the top of my head, but it's fair to say we have a lot of hardware people and we have a lot of software people.
So it seems IonQ have hired a lot of marketing and sales people, including CRO Rima, which seems to cost a lot to IonQ. But when do you guys expect to see results?
So we are already seeing those results. And by having a sales force that's trained and also the marketing headcount that is trained on bringing on deals and nurturing leads, bringing them into prospects, is what allows us to give a high expected bookings number for the year, and indeed also allowed us to raise it because we now have data points that allows us to see when probabilities change. And it was maybe easy to do that when we just went public in 2021. Now there are so many prospects and leads going on that we need a dedicated staff to follow them. And as a CFO, I agree, sales and marketing is expensive, but it's more expensive not to have them.
So it's like investing.
It's investing, but and I've worked in technology all my life. The hardest thing to do is actually sales and marketing, because now you're trying to convince somebody outside of your organization about something that you live and breathe and something that you really believe in, but the other people have to spend money on it. Whereas if you are developing something, be it software or hardware, you have a goal. But if it's on sales, it's not an amount of people. It is enough people to try to do what you do, but you're still trying, and there's another person who makes the decision. So it's very normal to have a very big sales and marketing org, which we do not.
But it's true that IonQ have recently hired a lot of sales and marketing people recently, right?
Yes, but remember that when we went public, we didn't have any.
Right.
Right. And so we've spoken on earnings calls about growing that team because we saw the growing demand on the customer side, and we thought it was appropriate to start building the sales and marketing organizations. But I don't think anything in the past, few months or 6 months, call it, has been outside the norm in terms of our rate of hiring those individuals.
Many people concerned that the IP contract with Duke and Maryland ends on 2026 July. So is IonQ planning to renew the contract? If not, what are the plans?
So the patent capture agreement that we have with Duke is up for renewal in 2026. It has 2 renewals that are granted if we agree on the price, and we have already executed one of those renewals, and we plan to negotiate the second one closer to 2026. It's open to be renewed at that time.
Okay.
And I think that neither one of us would like to negotiate it prior to when we should be negotiating it.
Is IonQ collaborating with ARLIS at the University of Maryland? I think the purpose of that question is $50 million contract coming from where ARLIS got funded from Department of Defense.
Got it. So while IonQ has many collaborations with UMD, we don't have a current direct relationship with ARLIS. Now, do we think that there could be one in the future? Of course, and we would welcome such a partnership. But the numbers that Peter mentioned on the earnings call were not especially targeted at ARLIS.
Or at any specific contract.
Organization. It is an amalgamation of all the leads and opportunities that we have in our funnel.
So it's not like a single contract, it's more of cumulative of
That's right.
any contract. What operational differences will Peter have in the chairman of the board of directors and CEO role versus just being the CEO?
That's a very interesting question. In the US for technology companies, I believe something like 70% of companies, the CEO also has a chairman role.
Okay.
Now, for governance reasons, you don't want any one person to control a public corporation too tightly. So when you have that situation of having a CEO and the chairman being the same person, then you also have to appoint a lead independent director. And that should be somebody else on the board so that you can balance the interests between insiders and outsiders. And so I don't actually know that Peter will have a very much different role, both in the board and the company, but functionally, he will be the person who calls the board to order. In the US, most board work don't actually happen on the board itself. Most of the board work happens in committee. So you have three very important committees. There's the audit committee that deals with all things accounting related and SEC filing related. There is the compensation committee that governs how people be paid, both employees and board of directors. And then there's a governance committee, which works on finding the right members of the board. It also helps with finding executive members in the company. And on various other duties, like they're involved in ESB filings, etc. So, but all the interesting stuff happens in the committee, and then when the committee has done the work, it comes up to the board, and if things require a full board vote, it goes to vote. But otherwise, the board couldn't function. So we don't anticipate the board or the company functioning very much differently with Peter as the chairman.
We saw that IonQ is building a quantum data center and new office in, I don't know how to pronounce this, Arlesheim?
Right outside of Basel,
Yeah,
Switzerland. Yeah.
What is the purpose of that?
So that's in relation to the work that we're doing with Quantum Basel, which, if you remember from last year, we sold 2 systems, 50% of each system, of a Forte Enterprise and also of a Tempo. So Quantum Basel invested in not just our current generation, but the next generation of hardware. And so we're building that data center, an office to host those systems, and that will be our first data center out in the European region.
So is it like half owned by Quantum Basel and half owned by IonQ?
So we manage the data center, and Quantum Basel will have access to half of the time on each computer. Think of it as system access. It so happens that the systems are local.
So the purpose of that is to generate revenue from European region?
Quantum Basel themselves is a customer of ours, right? So the purpose is to have our data center out there to be another great space for us to build systems. It's convenient to have an office on European time for many reasons, for customer interactions, for prospect interactions as well. And so we're lucky to have a great space to work in, and we're already working to assemble our first Forte Enterprise system there. It will be delivered from Seattle to Quantum Basel. We're assembling components, I should say, in the Basel location today.
I don't think you guys can answer this question, but is there a plan to have a branch in Asia region sometime in the future?
We haven't announced anything of that nature, but what we'll say is anything's possible, and we've enjoyed our time being here.
Okay.
Yeah, but also it depends on where we see opportunities, and we want to be close to the customers. And so if the opportunity set is rich enough and well enough developed, then we will have many offices. But we also need to take one step at a time, and we are supremely happy with the data center that we're building in Europe that will be to a very, very high standard, that will allow us to have a failover capacity from the US. It also will enable us to do load balancing so that we are able to give the capacity to customers at the right time.
We were informed that Quantinuum's recent results with 56 qubits, which was shocking to us, and also Q-era computing from Harvard and MIT spin-off recently selling its quantum computer to Japan, which the amount was around $41 million. So what do you think about those results, and how IonQ will, compete with those kind of results?
So the two are different. And on the one hand, you have a technological achievement from Continuum, which we see as a stepwise change in their performance and is below what we have said our target is. And so we welcome the fact that Continuum continues to develop. However, we don't think that this is anything out of the ordinary. And the important thing about qubits is that you need to be able to use them. So we have long been talking about our arithmetic qubits, or AQ, and that is a very important concept because it's about time to solution. It's not just about how many qubits do you have, because that's not meaningful if it's physical qubits. And when it comes to the architecture that Continuum is utilizing, it is a racetrack where in order to compute on qubits, they need to move them together and then move them back to the racetrack. So you move them together to do the entanglement and compute, and then you move them back. And ions or qubits are very sensitive to the environment, so you need to cool it down so it doesn't get overexcited. This act of shuttling and cooling takes up most of the time that Continuum's H2 computer spends. So if you look at the tables that they have laid out in their white paper, you can see that roughly 98% of their computer time is not spent computing, it's spent moving and cooling down the qubits. We think that the time to solution is much longer than it needs to be, and as a result, you dramatically reduce the capacity of that computer.
And so in summary, like Thomas said, we congratulate Honeywell on, or Continuum we should say, on their choice of qubit, because we believe this is just edifying evidence that trapped ions are the best approach. But we also think that the IonQ architecture is superior and will continue to scale better in the long term.
So we should look for other perspectives, not just focusing on qubit counts.
That's right.
What are the things and efforts that IonQ is doing that the competitors, IBM, Continuum, Cura Computing, etc., are not doing?
That is a long list. But if we take a step back to Cura's $40 million sale to Japan, very little is known about that sale. And we don't believe that it does anything to what we're doing. Very little is known of the actual performance of Cura's computer.
We don't know exactly what has been sold to AST because it's not our company, so we don't know what's in the contracts. But what is one thing that we're doing that's different than other quantum companies? We are starting production, for example, because we have confidence in selling our systems. We just announced on the last earnings call that we're developing 5 Fortune enterprise systems and are in various stages of discussions on selling those systems as well. And we think that not just having more systems, but the process of moving towards production and manufacturing will make us a better company, will make our product offering more serviceable, will make it more manageable. And so that entire process takes a lot of time and effort and thinking, and we're very glad that our team has started working on it.
I figured out that IonQ is the only company focusing on making the hardware smaller. I asked the person on Cura Computing that they are not focusing on that yet. They want to achieve the quantum supremacy first.
Right, and form factor matters. The first thing that we're focused on with our Forte enterprise systems is making sure that our systems can go into a customer's data center, so they don't need to make radical adjustments to be able to host IonQ systems. And so we're going to increasingly get towards a plug-and-play approach for providing products to customers.
That's right. That's why we refer to rack-mountable computers, because that's how, if you operate a data center, that's how you're used to thinking about it. And what we've always said is that we want quantum computers to be both cheaper and smaller, because we don't believe that this is a certain type of development where you have one computer per country or per region. We want there to be quantum computers everywhere. And to do that, you need to make something that is useful to the customer.
Right.
It's not just a scientific proof point. It needs to be something that goes into your fleet of compute that you use for your organization.
So the main location where QPUs will be located might be the data centers.
So most organizations today of size, who are the first one that will adopt the use of quantum computers, have data centers. That's where they put all their servers. Now these are designed in certain ways, and one of the main consideration is that all the computers have the same dimensions, so they can fit into a rack.
Right.
And therefore we think that it should be a goal for anybody that delivers compute, that you can fit into that form factor, because otherwise your customer won't just have to buy a computer, they have to build a data center. And for most players out there, that is the case.
Why do you guys think IonQ is able to gather top talents in the quantum and engineering fields? Why are they joining IonQ even though they have to reduce their pay? Because they're joining basically a smaller company.
It's a great question, Sean. I would say that people who are working on quantum computing recognize the potential that IonQ has and the momentum that we have, and that we're a great place to work and to do their best work. And that brings them to IonQ. They know they're going to be working with colleagues who are top of the industry. They know they're going to be working on real cutting-edge systems. And that is a very exciting prospect for people who believe in the vision of quantum computing. And so we're very lucky to call these people colleagues, and people are willing to roll up their sleeves and work hard hours and maybe sacrifice an opportunity elsewhere to come to IonQ.
Right.
And that's a great sign. We're lucky to all be united by that mission here at the company.
What do you guys think is the IonQ's biggest risk and weakness?
That's a tough one. For any company, there is the risk that you can't get talent. And that is the one that when I joined, when Jordan joined, we weren't clear. Because when you look at our management team, there was only Peter there before us.
Right.
And we were going public and we're building a company with very diverse needs. So how can we get past that? Well, the answer is very solid and steady recruiting. And today we have an all-star team of management who come from other companies with deep experience and background. It's not a startup that you're just there because you were there at the beginning. We have people who've done it before. And so that is a challenge that we feel that we've mitigated, but it's always a challenge. You can't ever just say back and, okay, I'm done recruiting now. But attracting and retaining the best talent is always your highest challenge in any company. And when it comes to that, I think other challenges are always like, well, is the market developing fast enough? Can we meet our technological milestones? And I think we have a team that's driven, and that enables us to do it. But if, when I joined, I would predict that we would deliver 35 AQ 1 year early, I wouldn't believe it. Like, even when we did it, I wasn't sure if I could believe it. And then we ran many tests and said, yeah, we actually did it. And then a month later, we did an additional qubit. When it comes to sales, it's like, sales are hard. As I said earlier, it's the hardest thing in most companies because there are outside factors. However, when there is no clear map, you have to trust your analysis. And the analysis says that quantum computing is the next step in computing writ large. Now, if you believe that, then you need to bring forward quantum computing. If you bring forward quantum computing, here are the steps you need to do. You need to make a computer of this size, and then you make it this much larger. You need to go to market. You need to build out a go-to-market function with sales and with marketing. You need to file things with the SEC. There are all these things which, if you sit down and write a list and just think about it, you can be so afraid that you can't do anything. And one person can't do it. I can't do it, Jordan can't do it, Peter can't do it, which is why you hire a team and you delegate responsibilities. And you know what? Once you build up a professional department, the head of that department can't do it either. And so they hire their team, and so on and so forth. And that's how you build great organizations. There's a lot of hard work, there's a lot of fun, and there's a lot of trust. And that's how I think that, yeah, we have massive challenges everywhere. But we also have great colleagues, and that's what allows me to sleep at night.
There's a lot of unknown in building a company in a nascent industry. That's the nature of it. Some people could choose to view that as a risk. We view it as a challenge, an opportunity. And that's why we have this incredible team around us working on that challenge and motivated by it and excited to push boundaries together.
So the biggest risk might be not getting talented people anymore, in summary?
I think it would be, the biggest risk is always in attracting and retaining talent,
Okay.
but also becoming complacent. If you ever think that you've won and now you can coast, it's done for. Only the paranoid survive. And I should also say that one of the things that is great is to have such a vibrant field of people who follow the company. There's way more I have seen who interact with us on a daily basis that are following us than we were aware of. Like, we've worked for other companies, and those companies done great things, but it hasn't always been as much of almost an integration with the community. And that is great to see. That's actually why we're here in Korea today.
Yeah, we're very grateful for that engagement and for the great questions that you've compiled as well, Sean.
All right, so this concludes our interview. Thank you for your time, Thomas and Jordan. Please have a safe trip back to America.
Our pleasure.
Thank you, Sean. And
Thank
thank you
you.
to you.
Thank you.
Thanks for joining.
자, 이번 영상은 2024년 10월 달에 제가 이제 구독자분들 한 7, 8분 정도 모시고 아이온큐의 시애틀 양자 컴퓨터 제조 공장에 직접 방문해서 거기에서 이제 아이온큐 임원진들과 만나서 했던 작년 10월 달 인터뷰입니다.
Hi, my name is Thomas Kramer. I'm the Chief Financial Officer at IonQ. I've worked most of my adult life in technology, and the other part of my adult life I've spent in universities, and I'm very happy to welcome you here.
Hello, I'm Dean Kastman. I run all of our engineering and technology here at IonQ, and so I'm responsible for all of the hardware and software development across our systems, so it's kind of our full stack software from cloud all the way down to our firmware. And on the hardware side, it's kind of like our ions all the way out to our enclosures. And so before IonQ, I worked at Blue Origin where I ran all research and development. And so I'm very happy to welcome you all here today.
Good morning. My name is Margaret Arakawa. I'm the Chief Marketing Officer for IonQ. I obviously work on Quantum Korea and meeting a lot of you in Korea, as well as customer engagement. Prior to IonQ, I worked at several startups. I've been in technology for 30 years, and I spent 20 years at Microsoft working on classical computing. So I'm super excited about quantum and welcoming you here.
Morning, everyone. My name is Jordan Shapiro. I'm the Vice President of Financial Planning and Analysis and Head of Investor Relations and Corporate Development here at IonQ. I've been at IonQ for about 4 years, and prior to joining IonQ, I was an investor in the company at a firm called NEA. Nice to meet you.
All right, thank you for having us. I'll get right into the questions. The first one we have is, when do you expect IonQ systems to create real value that leads to significant revenue? And what kind of use cases do you foresee?
Great. So, well, I will start with, we are already generating significant revenue.
Right.
And I think what is amazing to me is I also started 4 years ago, and when I started, we had zero revenue, zero sales. And now our guidance for this year is 75 to 95 million, which means that we're close to 100 million in sales, which is reckoned to be a milestone for technology companies. And so from that perspective, we're doing really well. However, what we're also looking at, which I think you're looking at, is the market for quantum computing is reckoned to be so large that the 100 million is nothing. And that is actually the beauty of it. That's why we're here. And we see that we will continue to grow. We will give more guidance on next year's bookings and revenue come the Q4 call, which typically happens in February.
So what kind of use cases do you guys foresee?
So right now, we've been looking very aggressively at different use cases across the last 24 months. Right, trying to understand where we expect the hardware capability line to cross kind of the application line, right? And so in those, some of the top ones we've talked about before include kind of chemistry applications, right? Some of those are optimizations. And so optimization shows up in a tremendous amount of areas, whether it's logistics, whether it is even job scheduling. We've had examples in the past with like Airbus and the DESI problems. Those are all examples of optimization problems. We've talked about kind of the kite algorithms and other kind of extensions to the classical kind of QAOA type of solution techniques. And so optimization is going to continue to be kind of a very rich type of opportunity. There's also some of the machine learning and object recognition, those kind of pieces, right? There's novel encoding techniques. So between the chemistry pieces, the optimization pieces, those are the big two. And then there's a whole number of additional smaller items.
I think there's three benefits from quantum that are massively different or significant enough that that's why people are investing in quantum. People want to be safe and secure. They want to be healthy, and they want to be efficient. Everything he said is about those things. We don't typically talk a lot about security, but as you know, there is a point in time when quantum might be able to break all of encryption. And for all of us who have bank accounts, we want our money to be safe, and we want personally to be safe. From a healthcare perspective, the reason why we invest is because drug discovery and curing cancer, those are on the docket for what quantum can do. So every individual wants to be healthy and live longer and efficient. Why do we optimize anything? Why do we have to optimize, flight gate assignments so that we're not running around airports and Airbus can save money and, sustain and not use as much fuel? So when you think about the vast benefits, are we going to be safer? Are we going to be healthier? Are we going to be more efficient? Those three things quantum can do at a massive scale that, classical has not been able to do yet.
And the next question, will the quantum applications be released very sporadically, or will there be clear growth in frequency with several apps per year after the first one is launched?
So we have spoken about the fact that on our upcoming earnings call, we'll share more about some of our plans for quantum applications. We haven't necessarily released a cadence of when those will come out, but we imagine as quantum compute enters the market more, yes, you'll see an increase of the number of applications. Those might come directly from IonQ, but they might also come from someone using us in the cloud or one of our customers. And so we expect, yes, the application space will grow, but we haven't produced any specific projections as to how quickly it will grow and when.
But at market maturity, just think about the App Store. A few years ago, we all actually never heard of an App Store.
Right.
And the first time it was introduced, it had some games and calculators and not much. And today, there is everything on the App Store, and there's always new ones coming in. That same thing will happen for quantum. We will not be directing the flow of applications in the mature state of this industry. We will all just benefit from it because everybody, all developers, or obviously not all, but there will be so many developers that if you try to control it, you can't, nor should you. It's that benefit we want.
And the next question is, what is IonQ's vision for its business models? I recall Peter mentioning that the Seattle facility will produce quantum computers in a Henry Ford style. Will selling quantum computers be the IonQ's primary business, or do you foresee other emerging revenue streams that could become significant?
Absolutely. And you can actually, you will see the floor later on, and you will appreciate what goes into creating a quantum computer. The main intention for us to build this facility was so that we could build replicable computers. So that they're not just so, like if you build your own car, only you can drive it. But if you buy one from a factory, you have a manual, every mechanic can fix it. And that was the main reason for us to have a completely separate facility, so that we would no longer be reliant on the people who develop the computers to also manufacture it, because you can't service things like that at scale. Because of the cost of quantum computers, of course that will be the main part of our revenue for some period of time. But if we look at how computing has worked, we should expect that at more mature levels of the industry, a lot of traffic will go through hyperscalers, because everybody doesn't need a full quantum computer. And we should also expect that a lot of revenue comes from software, because when we think of computers and quantum computers to be great to hopefully one day contribute to curing cancer, it is not the machine that all of a sudden wakes up and blinky lights comes on and it creates chemical combinations. It is the application of the machine. That's all in software, and in soft software, people. And so we will have the ability to join this, and we are working on actually making applications. We expect that the software market for quantum will be larger than hardware at some point in time. And we hope to be part of that.
It is very analogous to the classical, right? There are hardware providers that still exist in the world that do classical. There's software, like Microsoft level software, which is an OS, like what makes this computer work. But there's applications that sit on top of that. There's services that we sell. And the last announcement we had with Air Force Research Lab, that was about networking, right? It was about our expansion into another area where now these quantum computers have to be networked. They have to talk to the current computers that are out there. So those are all the businesses that we have recently, and all the way since when we first went public, talked about where our revenue streams would come from.
Talking of quantum networking, I have a question related to that. So IonQ has been securing quantum networking related contracts from AFRL and from ARLIS. Is the quantum networking business a new venture, and how large is this business expected to grow compared to IonQ's existing quantum hardware sales?
So technically, the networking piece is just an extension of the original thinking that Chris and Jung Sang had, right? And so our scaling strategy has always been kind of single core operation, high performance, single cores, long chains, moving to multi-cores. That multi-cores kind of gets beyond the limit of what you can start to achieve in a single chain. That's you start to get to shuttling and multi-core work. But then you need to move chip to chip, right? And that's where our photonic interconnects come in. That all relies on generating a photon, right? And so the technology associated with frequency conversion of a single photon, being able to do switching of single photons, is all in line with what you need to do to scale to multiple QPUs. And so for us, the logical leg of being able to use the ARLIS contracts, use the Air Force contracts, is an opportunity for us to kind of extend our technical roadmap aligned with the interests of kind of the blind quantum computing and the secure communication aspects, and as well as the heterogeneous kind of work and the kind of conversion to telecom to support the research agendas of the Air Force. And so that's why those two, customers in particular, are extremely, excited to work with us, and we're excited to work with them, because for IonQ, this is an opportunity for me to kind of accelerate our technical roadmap through these collaborations. It's super exciting.
We think networking is a massive market. It's going to be on the same scale as quantum computing. We think same order of magnitude. And if you've been listening to our earnings calls, we've been talking about networking for about the last year or so. And so what these deals represent, the $54.5 million with AFRL, the $5.7 million we announced with Arliss, these are examples of that networking thesis coming to fruition and working for us. But what's important, as Dean mentioned, is that for IonQ, networking is just an extension of our compute architecture. Technically, there's a lot of synergy between those two areas, and that gives IonQ a great advantage in going after these customers, expanding into that market.
What's exciting about it for us is there's already an internet, right? And the internet relies on fiber optics. For us to scale in quantum, we have to use what already exists in the existing telco infrastructure, and that's how we're architecting. So how we're going to build and be part of that TAM is we're building so that our computers work with existing fiber optics. His team is working as part of the FRL contract on exactly that. How do we make sure that quantum computers can work on the trillions of dollars of fiber that's already existing? That's super exciting for us.
And about the technology side, will photonic interconnect technology be demonstrated by the end of this year, as IonQ mentioned early this year?
So you're going to see downstairs. So the systems, we have systems both in our College Park facility as well as here that are working on photonic interconnects. Those systems have different capabilities. And so the work that we've been doing is continuing to move along that roadmap. Now, we've published a couple milestones that we've already hit. We're making good progress. We already have working systems. And so as we scale the photonic interconnect technology and go from kind of the lab kind of demonstrations and capabilities into improved, photon capture, improved, Bell state analyzer operation, higher entanglement rates, right? These transition from these demonstrations into more just vanilla engineering, right? We have to go through the optical designs. We have to go through the other risk reduction activities. We're looking at performance and trying to understand where the cliffs and knees are. And so I would say that keep watching for more milestones to just be hit. But it's exciting technology. You're going to see some of it working downstairs today.
Well, we have 4 milestones for photonic interconnects, but which one do you think is the hardest?
The hardest, the way the current milestones are defined, the first 3 are logical kind of progressions in kind of the early demonstrations. Then 4 is the very last, right? Kind of the last, if you will, demonstration. You can imagine that between 3 and 4, internally, there's a huge number of additional checkboxes to check.
Right.
And so, because the 4th one involves full networked, switched, single photon switching over a large multi-core system. The 3rd, however, is basically just connecting 2 QPUs.
Right.
So I expect that, you can kind of look for, we will be talking more and more about photonic interconnects over time. And we're going to kind of open the aperture of what is between milestone 3 and milestone 4 from a technical perspective, because when you start to peel back the covers, you can start to see the buildup of the capability, the different kind of interconnect topologies that exist, the entanglement generation rates, and kind of some of the science and the engineering that's kind of going in behind the scenes.
It's fair to say probably, Dean, that the first 3 milestones are demonstrating this incredible capability, which is to tie multiple quantum computers together, multiple QPUs together. And then that 4th milestone is all about scaling that up so that you can go from 2 systems to 3 or 4 to 10, right? And start to build hubs. So that's a difference between demonstrating the technology in production and then scaling it in production.
Then when do you expect error correction and photonic interconnect technologies be implemented on IonQ's commercial systems?
Well, we've already explained that for our AQ64 systems and for Tempo, we will not need photonic interconnects to be performant to be able to achieve those kind of both the fidelities, the number of qubits, and the overall performance.
Right.
And so we do expect, though, in that Tempo time frame to be able to start rolling in other kind of capabilities that you need to do more advanced, I would say, quantum error correction demonstrations. So we're going to have mid-circuit measurement, reset, those kind of things that will allow full use of like the partial error correction techniques like the Clifford noise reduction that we just talked about. So that's going to be part of the capabilities that we have in our tempo time frame. Now, the systems beyond tempo are going to be the ones where we continue to invest and continue to realize some of those kind of partial error correction, partial error mitigation techniques. You're going to be able to run those systems in kind of a logical mode in which you can exploit this is at the software layer, being able to exploit logical qubits, right? But those are going to happen in the system or the generations after tempo, where you're going to see that technology get to a point where it's mature enough that it just becomes just part of the architectures.
We saw that Dr. Chris Monroe's lab at Duke has received federal funding from the National Science Foundation's National Quantum Virtual Laboratory to build a 256-qubit system by 2026. Should investors view this work as part of IonQ's roadmap and its implementation of photonic interconnects? Is it related to IonQ?
So the beauty of our relationships with Duke and with the current research that's going on with both Jung Sang as well as Chris is our licensing agreements that we have with the technology that comes out of the labs, right? And so that will continue over time. So as new technologies developed, as they're investigating and doing kind of novel and unique things, we have the licensing rights to that technology. Thomas can kind of speak to the explicit details. I just am the beneficiary of that learning. And so as they work that program and as they learn and as their unique things, IonQ in our licensing agreement allows us to be able to kind of work with Chris and Jung Sang to be able to figure out what IonQ needs to pull in, and we have that option.
But what we don't mean to say is that we don't direct research at Duke. We'd love to, but they are an academic institution that do brilliant research that we benefit from, often because they are able to look very far into the future and say, this is a technology that we need to do some research on. A lot of them fail, and we get the benefit from the ones that work. And as such, I wouldn't look at what Duke does as an extension of IonQ, although we have many fruitful cooperations with them when we work on some projects together, like we did when we did error correction for the first time on the first company to show that on a working quantum computer.
When you go downstairs when you're doing the tour, you'll see we have a patent book, and you'll see exactly. It needs to be updated, but you'll see that we have U.S. patents, we have global patents, and we share many of those patents with Duke and with the University of Maryland. So it's a visible representation of how proud we are about the collaboration, and you'll see it in the patents that were granted, as well as what we have pending.
Right, I just visited the Duke Quantum Center 2 weeks ago, right? And so, like, Chris and Jung Sang are doing some amazing work there, and so it's always great to see, like, just the collaboration, to be honest.
And Chris continues to advise us, as does Jung Sang, and has been a part of our calls, because he is, and will always be, a great co-founder with the bleeding edge knowledge.
I was just with Chris last week.
Right, that's great. And then one of the biggest concerns we as investors have is that when quantum computers become powerful enough, the government might intervene and prevent IonQ from selling as many quantum computers as it wishes. What are your thoughts on this potential government intervention? And do you have any plans to address such unexpected challenges?
So if you look at the US and how we have developed as a country and how many technologies really have come out of the US, how many technologies have come out of other countries and been adopted here in the US and extended, it's not in the government's interest to restrict the development of new technology. What we have seen for certain types of technology is that there are limits put on which areas you're allowed to sell them, and typically, like very high-end technology and defense technologies, you are not allowed to sell to Russia or China.
we don't really see them as being the largest markets for quantum computing, not in the near to medium term. In the future, nobody knows. But I don't see that as a problem. If you look at all the other industries in the US that actually have restrictions, these are giant industries. And so we think that any restrictions that the US would put would just be to protect this industry from bad national actors. Now, we can disagree on who's a bad national actor, but I don't think that there's any malintent, and the government cannot develop quantum computers. And so if they restrict that development, they just hurt themselves. So we're not worried about that.
The other thing to think about is, as Thomas said, all quantum also uses classical, right, when we do our work. And I worked on classical.
Right.
And the largest markets in the world for classical, where there are large dollars already invested, as well as the biggest checkbooks, are the US, Japan, UK, Germany, France. South Korea, because of the government's promise to put in money into the country, rocket South Korea up higher than what it had previously invested in high performance or compute. Those are very large markets, the largest ones in the world, and those are not on the list of bad actors. Those are the lists of where we as a global, team are going to go invest. And so I think the marketplace for our quantum computers is massive.
So that was the last question. So lastly, is there anything you would like to say to the viewers?
Thank you. No, seriously, thank you for all the support that we see and for how detailed you follow our development. Because normally we get questions from people who have not read all the detail and don't understand quantum.
Right.
And so to be able to have an engaging conversation with questions that actually stretches what we can say and what we even know, that's a benefit to us.
And just like you're all learning about quantum computing and about IonQ, so is the rest of the world waking up to the industry. So it's great to be able to host you today and to be able to share so that you can go spread the knowledge about what it is we're doing here and what a quantum computer looks like, which most people in the world haven't seen yet. That's a big pleasure for us to be able to have you all here and to have such an engaged investor community.
Speaking of which, how many people here have ever held a quantum computer in their hand? I think, Dean, you should do the...
We have multiple generations of our trap that we use for our systems. The systems that we have in Forte Enterprise utilize what we call our EGT trap, our evaporated glass on metal trap. So it has a glass substrate, and we deposit metal, and finally we deposit gold on top of that to support and kind of reduce charging and kind of the overall environment. This is our generation of trap beyond that. This is a multi-layered glass trap. And so it's still built right now on a glass substrate, but it uses lithography techniques to be able to do buildup of multiple layers. And so what we can do is generate routing, higher density, we can support vias and other things in the chip itself. And basically that additional routing and additional kind of density allows us to put more qubits, more ions on the system. And so the other thing is just from a manufacturing perspective, we can now leverage a lot of the semiconductor techniques. So we work with some custom fab houses to be able to work this. And so this is the systems these are the chips that will be going into our Tempo systems. If you're ever out in College Park, this is the current set of chips that are in all of our barium development platforms. And so it's exciting. We'll pass it around and you can take a look at it.
Today, as you go through and ask questions of us and you go to our factory tour, what Dean's team works on and what we all work on is making sure our performance benchmarks are world-class, and they are. We have to make sure our scale is world-class. The roadmap can scale, the ion chain, all of that. And then another part that we really focus on here that's quite different from other companies is we have the only factory in the United States that builds quantum computers in order to scale them, because we've already shipped a computer to Basel. So think about that as a part of our DNA that's very different. right? We want to get to enterprise grade. We're building computers that you see here that are being shipped into different countries, and we did it first, and we're incredibly excited because that's where you're going to see multiple scalable computers being built here, shipped to, so they go into their data centers. Most of the other companies in quantum don't do that. Not yet. You know what's great about manufacturing? You got to get on that curve early. Whoever starts on any manufacturing, you start early in order to learn, and you develop, and you're on a different learning curve, right?
I have some question on the photonic interconnect, especially when you scale it. As you scale it, your challenges will scale together, right? So coupling two local, what you call it, quantum processor together is different than connecting 10 or even beyond, right? I can just, with my very limited knowledge, I can think of when you couple your local qubit to the photon, you have some, how do you control in synchronized manner? Also, as you remote qubit will probably decohere faster than the local, and then you have so many things. How do you synchronize and control sort of those when you scale? Can you name a few challenges in that scaling? And then also comment a few approaches and strategies you're taking in that.
So right now, the synchronization is definitely an issue, right? And so you have to be able to have very clear time synchronization between the systems. So when you go on the tour, you'll see the hardware that we use for time synchronization downstairs. And so that's part of it. Now, the overall topology of the chips in terms of the physical layout of the individual trap, as well as where you do light collection, that represents R&D that we're actively doing right now to ask ourselves, how many interconnect zones are there on a single chip? Is there different topologies that you can create, mesh networks, star networks, whatever type of other networks to be able to connect systems? Because at the end of the day, if I do my job right, I'm shrinking the system size down, and I'm also creating higher performance, more robustness, better scalability, and we're being able to network these together so that a single machine will actually have multiple QPUs in it. And so the interconnects will be used both for intra-machine as well as inter-machine communication. And so as the distance for inter-machine communication grows, the barium wavelengths will no longer work. That's where you need to start to get to some kind of frequency conversion to get to telecom or longer wavelengths. And so within the confines of a single machine, you don't need to worry about that. You can still use kind of the standard techniques that we have now. And so the part of what we have to do is figure out the time tracking of those photons. So being able to think about how you get two photons to the same spot in the same time, know which system generated them, which ion generated them, track all of that. That's the hardware and software we're building now to be able to kind of invest in all of that. It's all the kind of building block technologies that we generally don't kind of do deep dives on in our investor calls or on our blogs, but that is the development work that we're actively doing as we speak and that we already have behind us in part as we move forward.
Are you leveraging some kind of AI technology in such a challenging process?
This is classical, like high performance control. So, yeah.
We've got time for about 2 more questions.
I'm AI and cloud engineer. I'm very interested in AI agent system nowadays. So I'm studying about the AI agent application who study some on the difficult topics such as quantum. So it is inspired by Sakana AI, the Japanese one. So my question is, do you use the kinds of AI technology to study and to develop your products?
So we have a roadmap that includes the use of more advanced, I would say, decision-making techniques. So most complex systems have a hierarchy of decision kind of logic, whether you're doing things that are inside of a single chip, right? Analog control. Go up to where you're looking at FPGA, things that are operating on FPGAs and system on a chips. Things that go above that in terms of the logic. And then you get to some of these more supervisory type of pieces that are looking at that. So right now, I don't want to speak to specifically the kinds of techniques that we're using, but the intention is to have a software stack as well as a richness of, I would say, ability to use the best technique to get the right answer. So I'll leave it at that. AI is part of that mix. Machine learning is part of that mix. Classical techniques are all part of that mix.
Can I just add to, as we said, we have hardware, we have software, we have the algorithms, we have services. A really big area that IonQ is investing in is in the algorithm part. How do we look at how quantum can be helped by AI? So we have a very large applications algorithm team. Actually, Dr. Masako Yamada will actually be speaking at the Quantum Plus AI conference, which is going on later this month. And she is one of our premier employees that has been working on high-performance computing as well as now quantum. And she's going to talk about how does IonQ look at AI's impact on impact as well as interconnection with quantum. And we'll also be having a webinar that will talk about some of the different algorithms that we're working on and how does quantum help this supercomputer, using AI. We have incredible work going on. We're excited to talk about, in particular, a lot of the applications that we're working on.
So you can think of it that there's a certain aspect of quantum helping AI. I'm also interested in designing, as a designer systems, how AI can help quantum. Right?
I just have a simple question. Do you have any relationship or collaboration with Zapata, which is, co-founded by my professor, Alan Astrophysics? I just want to know how do you have some kind of relationship or some collaboration task between Zapata, which is quantum software company?
So we maintain relationships with many of the quantum computing startups and other companies in the space. That's something that we always like to make sure that we're in collaboration and in connection with them, because we really view it as a full industry that's growing at the same time. Zapata we published work with many years ago, but we don't currently have an ongoing relationship with them. Yes, that's all the time we have. So thank you everyone for joining us for the Q&A, and we will wrap up and then proceed to the lab tour.
All right, thank you.
Thank you all.
자, 이번 영상은 1, 2월 달에 아이온큐 CEO가 바뀐다라고 해가지고 제가 요청을 해가지고 아이온큐 전 CEO이자 지금 은퇴를 하신 피터 제프맨 사장님과 지금 현 CEO이자 이사회 의장이 된 니콜로 데마 씨와 인터뷰를 했던 부분입니다. 어떻게 보면은 이 리더십이 전환되는 가장 혼란스러웠던 시기에 가졌던 인터뷰였는데 한번 보시면 좋을 것 같아요. 네, 여러분 안녕하세요. 가을바람입니다. 오늘은 저희 아이온큐의 가장 높은 경영진에 계시는 피터 제프맨 의장님 그리고 니콜로 데마 씨 사장님을 모시고 최근에 굉장히 큰 변화들이 있었는데 주주들이 가장 궁금해하시는 질문들을 가지고 인터뷰를 한번 가져보도록 하겠습니다. Hello, Peter and Nicolo. Thank you for having us today.
Hey, Sean. Honor and pleasure to be here.
I'm pretty sure all of the viewers know who you are, but could you guys briefly introduce yourself?
Nicola, why don't you go first? So I'm Nicola De Masi. I was the original SPAC sponsor of IonQ's IPO in 2020. I was on the board for 5 years, chairman of the Nom/Gov committee, and for the last 5 weeks, I've been the president and CEO.
And Peter Chapman, for the last 5 years, the president and CEO. And Nicola was my partner when we first started thinking about taking the company public. So we've been working together for quite a long time. And now more recently, the exec chair of IonQ.
All right, so we have quite a list here. So I'll start off with the first question. So everyone is wondering why was there a CEO change? So investors would appreciate a more detailed explanation.
So, one aspect of being a CEO of a public company, and especially one that's growing so quickly, is there seems to be unlimited demands on your time. And the reality is you probably could do 5 people for the president and CEO role and still keep them all busy. So it was clear that we needed to be able to scale out. And so by making this change, it gives us a lot more bandwidth at the top to be able to work on deals and those kinds of things. It also gives the company, to be honest, a good path for succession at some point. I'm no longer a spring chicken, as they say. So, and Niccolo is got many more years in him than I do. So, so I think it's good just in terms of succession planning. But as we said at the earnings call, it isn't something where I'm going away, which is, one of the reasons I'm here today, is just to reassure, investors that it's not that I'm working any less than I was before. It's just I'm giving Niccolo some of the work to be able to do, and the two of us are now kind of tag teaming it. He gets to do all the work I don't want to do. So.
No, all I would add to that is, Sean, as you know, when we IPO'd, we raised money to build the world's first and best quantum computer. When we IPO'd, we were the only machine that was on the Google, Amazon, and Microsoft public clouds. And I'm proud and surprised in some ways to say that 4.5 years later, we're still the only machine that's on all three clouds. So that says something about our robustness. But as Peter said, look, things always look sudden externally because in public companies in the US, nothing's done until contracts are signed. And so until Peter decided he wanted to do this, and until I had a contract, there was nothing to talk about. You can't talk about management succession until you do something. So it's always abrupt, if you will, from the outside. The only difference is whether or not people are changing roles and someone's leaving, which is not the case here, or they're announcing something that will happen in 6 months. So Peter and I could have said, we're going to make this change in 6 months or the end of the year, but we did it at the end of last year, which was just reported in February, this year. And because we've worked together so much, we have such a good relationship, and we've made all the major strategic decisions together, really nothing has changed. The strategy is identical to what it was 33 days ago. I will point out that the bandwidth constraint Peter has had has only been exacerbated by buying, and aggressively expanding into the quantum networking space. So we bought Cubatech in San Diego 6 months ago, and from SK Telecom, of course, we're closing a deal that we announced a month ago in Geneva and Seoul. And so the total addressable market here has doubled. And Peter and I are both fairly aggressive entrepreneurs, or public company leaders. And so we don't want to miss a beat in our ability to expand both of these growth vectors, right? And as we keep expanding the company, we absolutely are going to have our work cut out for us and be as busy as ever. We keep growing headcount, we keep growing the size of the leadership team, and of course we need to figure out how to get 1 + 1 = 3 when it comes to things like ID Quantique, Cubatech, and our ability to sell, be the only company in the world actually, only public company in the world that does quantum computing and quantum networking in the same company. No one else has that. Doesn't matter who you are. Toshiba in Japan has a little bit of networking, and there are other quantum computing companies, but we're the only publicly traded company that does both, and I would argue is the leader in both.
We saw the CEO change, and you guys have raised a lot of money through ATM program recently. So how does IonQ plan to utilize the $700 million that you guys are holding after recent $370 million capital raise? That's one of the main questions we have.
We raised this money to support the networking business primarily, right? So the IPO, we raised $645 million, and that was to build our computing business out. Networking, we've made 2 acquisitions, and we've raised another $360 to support that. And we intend to aggressively grow the 600 customers we have in networking around the world, from Samsung to SK Telecom to Singtel to EPB in Tennessee. We intend to aggressively grow our geographic footprint, and we intend to aggressively grow the application team and footprint there, because we're just at the start of building our ecosystem, the IonQ ecosystem. And the IonQ ecosystem will be both computing and networking, and a tiny bit of quantum sensing that we've acquired with ID Quantique in Geneva and Seoul. And we want people to use our machines, pay to be on our machines, and the same with our really quite large portfolio of networking products. We're the only public company in the world that has computing and networking in the same business. And the only company in the world that has 930 patents supporting both sides of the business, about 500 in computing and 400 in networking. And that's really quite an impressive moat if you think about that, globally filed.
Peter mentioned on your last earnings call that DARPA would announce phase 1 benchmarking initiative, which was expanded to $300 million. So is IonQ likely to get any portion of that money?
Let me give you the background on the program first. So there's 3 phases to the DARPA contract. The first one is an initial $1 million, which, to be honest, probably is the amount of money required to fill out the paperwork to go for the other phases. Then there's a this is to the best of my knowledge, there's a $15 million phase 2 contract, and then there's a $300 million phase 3 contract. And so, these are available. It's not just one company, but many companies that can do this. The DARPA gave 2 contracts last year, the year before. One was to Microsoft and one was to PsiQuantum. That was a very unusual award. It was the program was the kind of what are crazy ideas in quantum that we could fund program. And so in that sense, the crazy ideas was a topological qubit inside quantum's qubit. So it's a funny thing to get that contract because it meant you really were out there. Those 2 have been selected for the $1 million in this next thing because they are already in the program before from last year. The program's changing now from kind of crazy ideas in quantum now to how do we get to scale in quantum. The next round of companies are about to be announced shortly, and they'll all be announced at the same time. And I would expect just common sense to apply that a wide range of companies will be selected in the first phase. And then as we go through the various phases, fewer and fewer companies will make it to the final $300 million grants per company. I expect that DARPA will be making those announcements in the next I believe in the next couple of weeks.
So IonQ applied to that program?
Yes, we did.
Oh, okay.
We did apply. Yeah, yeah. We applied, and obviously they'll be making the announcement as to who has been selected in that.
In January, Peter, you mentioned that IonQ aims to have sales approaching $1 billion and profitability by 2030. So was this a broad long-term estimate, or is it more kind of a detailed projection behind this statement?
Well, what I would say, it probably a little bit of both, right? In the sense, when you make such a statement, you obviously want to have some idea of facts behind it before you do it. Part of it was the fact that we knew that the applications work we were doing with ANSYS and AstraZeneca was looking quite strong. We made announcements at GTC about those things, and that was on Forte. And so, we never expected, to be honest, to be able to show such strong results on Forte. We really thought that would be on Tempo. So now, you have to do, probably 100 to maybe 1,000 times better to disrupt a market. So you're going to need a Tempo system to be able to do that. So the projection was kind of based on the fact that not really on IonQ hardware sales per se, but on the fact that now applications were going to start to show up, which was going to drive usage towards our machines. And so, and that we've talked about this many times in the past. One of the big changes in the last 18 months was really looking for applications that can take advantage of these early quantum computers. And so the fact that we now had such strong signals, that gave us confidence that said, hey, there's these large, like the ANSYS market is a $10 billion market, that this is something that we can now start taking workloads off and bringing to IonQ. And then you sit down and say, okay, well, what percentage of that market do you think you can capture? And obviously having a strong partner like ANSYS kind of enables you to get into those markets with a relatively low risk. And so the same thing in the pharmaceutical industry. So that's really where that kind of analysis came from, is kind of saying, okay, well, how many systems and what compute time, what do we think we can charge for that if suddenly everyone in in the Ansys customers now want to run on an IonQ quantum computer.
When does IonQ plan to launch AQ64 Tempo? Last year, I think you mentioned it will be launched around this April or June?
Actually, probably this fall would be my
Fall.
my guess is the current time plan for Tempo. The first one will come out of engineering at that time, and then next year is really the time where they start shipping. Hopefully, larger numbers of units is the expectation for next year.
So by engineering, you mean starting to build the machine on fall?
The machine is being worked on and developed right now.
Right.
So it's that at the end of the fall is that we'd have a working machine.
Okay.
So you'll see announcements saying, "Hey, the first Tempo system is now up and running," but it's an engineering unit. It's not It wasn't intended to be shipped to a customer just yet.
Okay.
Yeah, I mean, we commissioned the first Forte systems, obviously, in Basel and AFRL, not that long ago. So remember, there's about a year lag between things working in a lab and things actually getting shipped to a customer, set up and operating. There's a lot of logistics and actually engineering work that happens to manufacture one of these systems, even once you've built one. But doing it at scale and repeatedly is, of course, its own exercise. Sean, I would just add to the prior question that we have about $200 million in bookings cumulatively from IPO, and the projection about 2030 is we said that by 2030 there would be approaching $1 billion of sales.
Right.
That we haven't been precise on whether or not we're talking about cumulative sales from the IPO to 2030 or or an amount in 2030 itself. And of course, sales for us is defined as bookings, revenue, research projects, and other cash payments that we receive from customers. So we'll get more precise on guidance in due course, but we haven't given official guidance or official projections yet.
Okay. And for Nicolo, I think you mentioned on the last earnings call that IonQ would not use AQ anymore as performance metric. So what kind of new criteria will replace it in the company's roadmap? And is there a reasoning behind this change?
Yeah, so I'll take a crack at this and Peter will add on. Quantum computers are a complicated new beast, I would say. And as a physicist myself originally, the joke that professors of quantum mechanics always make is, if you think you understand quantum mechanics, you haven't spent enough time with it.
Right.
And Einstein himself said he didn't believe in spooky action at a distance, and most people think Einstein was pretty smart. So the reality is, if you look at our quantum computers and what they can do, our customers get really great results in the pharmaceutical space with AstraZeneca, in the fault and anomaly detection space with General Dynamics, in the computational engineering space with General Dynamics, Airbus, we do cargo loading optimization for. And by the way, Sean, have you seen our investor deck ever? Do you see the deck that we present at Morgan Stanley and
yeah, I did.
And that kind of thing? Okay, you've seen the slides because we can obviously show you some of those. We have a whole slide on our applications, and we're very customer centric at IonQ. We're very focused on commercialization.
Right.
We're very focused on building this ecosystem of computing and networking. And I would say that what we have learned is that, first of all, algorithmic qubits it's difficult to calculate after AQ64 because its classical analog is difficult to explain and it's difficult to prove using classical computers because it's such a large and powerful machine. Secondly, you're finding that different types of metrics matter for different types of applications. So, image processing is not the same as molecule simulation. It's not the same as worrying about logistics optimization or someday cryptography and code making and code breaking. And so what we said in the earnings call is that we need to bring out a new set of metrics, but they're likely to be application and customer specific. One of the challenges in this industry is that we were the first to commercialize, the first to go public. We have twice as much GAAP revenue in 2024 as the rest of all the public companies in the computing space combined.
Right.
So obviously we have the leading technical roadmap, we have the leading customer engagement, and people are paying us for our stuff. We're not giving it away as some companies have to do. And that means we do useful things. Now, as Peter said, we announced at GTC, Peter announced with, Jensen Huang of NVIDIA just a week or two ago, that we were getting a 12% speed up, with Ansys if they ran certain algorithms on our machine before they ran it on a classical computer. Now, Peter's correct, 12% is not 112% or 1,012%, but at the rate that we're improving our machine power, I think people are going to be surprised in the next year with what happens, right? Because Tempo is 2 to the power 28 more powerful than Forte, and so it's 240 million times more powerful. So if we're getting 12%, results today, imagine what that 12% will become, in approximately a year. And so honestly, we like GAAP revenue, Sean, because it shows that you're doing something for a customer, right? And owning more of the value chain between what a computer can do and what the business result is part of the strategy for Peter and I, right? We want to control, obviously, the upside and drive as much quantum computing ecosystem creation as possible, as quickly as possible, because in the history of the technology markets, the companies that succeed long-term are the ones that build the best, deepest, and broadest customer ecosystem.
I'll just add a little to pile on a little bit on AQ. Originally, there was a number of algorithms that the QEDC had specified. You'll notice that we dropped one of the original algorithms, even in the specification for AQ. And the reason behind that is that the compiler could optimize it out that you didn't need a quantum computer to run it. One of the things that's happened also in this time frame is the compilers are getting better. And so the AQ numbers are really starting to be more of a benchmark on the compilers than they are on the hardware. And so that's a problem because, we want the benchmarks to be driving the hardware. We want the compilers to get better as well. The other thing that's happened in the computer industry just classically is when you have a benchmark, it drives a behavior for your company to be able to produce hardware that does a better benchmark. But to Nicolo's point, what we really want is to build hardware that solves a customer problem, not necessarily win in a benchmark. And so, one of the things we saw out back is like, hey, we can do, higher numbers of AQ. And it's like, well, it doesn't necessarily represent the hardware. And B, are those things still representing the needs that we see in the applications? And the answer was no. And so it was like, okay, well, let's come up with something then that's more customer focused. That was when we came up with AQ and the QEDC, was the quantum industry put together those things. That was the best guess at that time that they were going to represent kind of the needs of users. But we now actually have customers like Ansys, and we really know now what it is that they want. And so it's not too surprising that the benchmarks before that we created, aren't meeting what we're seeing in terms of the current market, because we just know a lot more, both about where the quantum computers are and obviously where the customers are.
So the new metric will be revealed soon?
Yeah, we will. We will come out with it's a hotly debated topic at the moment behind the scenes as to what is something that fairly represents the hardware, right? It's and it's a hotly debated thing even within the larger contest. Is it people are saying it should be logical qubits, right? There's quite a bit in there, so more to come.
Can you provide an update on photonic interconnects and your progress there? Because the last update we had was on the second of 4 steps, which I think was around last October.
Yeah, I mean, look, let me stand back for a second and let's talk about quantum networking and photonic interconnects. So, we are in the quantum networking space because we started down this path organically anyway. Before we bought Cubatech and IDQ, we've been working on this photonic interconnect, and effectively entangled communication is the path forward for IonQ, and it's a path that we've been working on, on and off for quite some time. The important thing I think for the market to be aware of is that AFRL has purchased 2 systems from us that are quantum networked together. So obviously we're making, once again, good progress with customers. One of the things, Sean, that we are careful to do at IonQ is to represent accurately that we are in the business of quantum computing and the business of quantum networking. It does surprise me sometimes when you look at a startup company's investor presentation, and instead of having 40 slides like we do, where one of them is on our technical roadmap and 39 of them are on customers and applications and our ecosystem, all they have is 20 slides on their technical roadmap. And that's because it's all they're doing. All they're doing is a lab experiment. It's as if NVIDIA or Broadcom just said, we do stuff in the lab. We don't sell chips. You can't use them. We don't have a marketing department. We don't have a customer success department. We don't have a sales department. All we do is we try and design chips, and we hope someday that they'll work. And so we're pretty conservative about what we talk about on a go-forward basis, and we like to show what we're doing through our customers as much as possible, right? So there are other companies that make announcements about quantum random number generators. Well, we've been shipping our quantum random number generator through IDQ in the Samsung Galaxy Quantum 5, for quite some time. We haven't shown in the lab. We've actually shipped it through customers, right? Same with quantum networking. We've actually shown this to AFRL. It's one of our biggest contracts to date, and obviously it was awarded to us because we operate at room temperature. We have a miniaturization path, but also because we can do this, right? And so, look, in general, there's always engineering challenges when you're at the cutting edge of science. Right. But we've been worrying about the cutting edge of science because of, Professor Jung-Sung Kim and Professor Chris Monroe. We've been worrying about it for 30 years. And so I was talking to Chris Monroe earlier today, and he was making the point to me that most of the announcements that you hear from startup companies are things that he did in 2001. Sometimes 2010, but often 2001, right? And that includes Microsoft and some of the neutral atom stuff. There's a lot of companies trying to make one gate work and talking about a roadmap in 2029. So what I like to say, Sean, is, I have, IonQ, we have more PowerPoint qubits than anybody. But unlike everybody else who only has PowerPoint qubits, we have real ones, and we sell real machines, and we sell real quantum networks, and you can see our machines in Seattle and College Park, and I think you visited us, right? So our stuff works. It's enterprise grade. We announced, we have a steady announcement trajectory of technical achievements. We tend to space them out when there's not earnings calls and things like that. But like with everything at IonQ, we're not concerned about our technical roadmap because we're generating revenue off of our machines. And so we're obviously hitting those milestones, even if we don't spend all of our time talking about them.
But you guys expect to apply photonic interconnects on the quantum computer maybe on the next year's product?
Oh, no. In the system that we're finishing up developing right now for AFRL, that will have the next phase of photonic interconnects on it.
For 2 machines that are, quantum entangled, which is effectively what a photonic interconnect is.
Right.
And we've commissioned the first of those machines. So we're doing this for, like I said, we're doing this for customers, not in the lab.
But that technology will be applied to your quantum computers as well.
Oh, the two systems, and there's a little bit of confusion about this as well. If you look at a lot of the announcements last year, with AFRL, is we talk to them in the context sometimes of quantum networking.
Right.
However, it's quantum networking between quantum computers. So, for instance, the AFRL system that we're working on right now is 2 quantum computers that we're building, but we didn't announce that as selling 2 quantum computers. We announced it as quantum networking. And so, but the quantum networking required 2 quantum computers to be able to network them. So we're just finishing up the 2 systems. They're on the manufacturing floor here in Seattle. That is for AFRL that will do the 3rd phase of the the photonic interconnects. And so in that sense, you know, sometimes people are confused. They sit down and say, well, oh, hey, you guys seem to be focusing a lot on quantum networking. How about the computing side? How is that going? Well, no, it's going quite well. We built, in this one example, we built 2 quantum computers for AFRL so they could network them. So it's a quantum computing and quantum networking, even though we announced it last year as a quantum networking sale.
Right.
It was to network 2 quantum computers together.
Right. And talking about IonQ's core businesses, regarding the quantum hardware sales, IonQ initially planned to manufacture 5 Forte enterprise systems. So 1 is deployed at Quantum Basel, and 2 were reportedly under construction as of 2024 Q2 earnings report. But there has been no recent updates on quantum hardware deployments. So any progress there?
Well, just we just talked about the fact that there's 2 more quantum computers sitting on the assembly line right now in Seattle, which is for the quantum networking side. Right, so
that's
they're not Forte systems, just to be clear. They're systems, but they are quantum computing platforms for the Air Force to be able to do quantum networking. So, we have one of the systems about to come online, and we'll probably keep it ourselves because we've run out of bandwidth to be able to meet customer demand. Or for across all systems, we're largely just don't have any extra time for customers, so we need to be able to bring them online. Obviously, in the next couple of months, you'll hear more about more customers on Forte as well.
So the 2 machines that you mentioned are getting constructed on Q2 was those 2 for AFRL?
There's 2 for AFRL and also 2 which is Forte systems which are being manufactured. And one of the Forte systems, my guess is that we will probably keep and put into our own data center simply because we just don't have enough available compute time for customers.
Remember, we sell systems, we sell partial systems, we sell cloud access. And so there are some countries that don't buy a whole system, they buy access or a portion of one.
So there's 2 Forte systems being manufactured in Seattle, but you guys haven't announced who's gonna buy it?
Yeah, we haven't announced those deals yet.
Okay. And for the quantum hardware applications, I saw from the IonQ's very early investor presentations back in 2020 that you guys suggested plans to integrate quantum computers to next generation fighter jets through certain aerospace and defense partners, which I think is AFRL. Is this still a valid future business model, or what do you guys think about it?
So I think there's a number of, since I'm the one who said that, I'll talk about it. There's clearly a market if you could get the quantum computers down to the point where you could put them onto a plane.
Right.
And but we have been busily working on shrinking those things over the years. It's clearly not there yet. The other side, which is the quantum networking side, is one of the things that we announced is we'd want a contract to do quantum networking to drones.
Right.
Now that's clearly not putting a quantum computer onto a little drone, but it is to be able to do a quantum network to be able to control the drone. And so, and if you look also, we won a contract to do ruggedized hardware for the military, so that it could be kind of taken not just, there's academic, applications, then there's commercial, and then military requires the next level. You have to be able to drop the thing in the mud and still have it work, right? And so we've gotten several contracts now to do that for the quantum networking side. It's still work in progress to get it onto a quantum computer on a plane. But I do think that on the quantum networking side, not only can you get it likely onto drones, but onto satellites, and the form factor does fit, starts to fit into those kinds of areas. Quantum computing at the moment is still too big. It needs to be smaller to be able to get it, into space or onto a plane.
But to be clear, our systems are the size, as you know, of a large commercial refrigerator. It's not a football field.
Right.
We don't need our own nuclear power plant. And, if anyone has an opportunity to miniaturize, it's going to be us, because we run at a relatively warm temperature compared to everyone else who runs at, 0.1 Kelvin, right? So we have a real shot at it.
So for quantum hardware, the last time I visited Seattle, Thomas gave us a hint that maybe quantum computers can be loaded on aircraft carrier or on a big ship sometime.
That it definitely could be. So yeah, a big ship would not be a problem. Certainly not. I don't think you'd need an aircraft carrier, but a destroyer or something like that, it definitely could. I think there's also a huge market for that in subs as well, especially for quantum.
Anything that has its own nuclear power plant can take our quantum computer. That's a fair line, whether it's a sub, an aircraft carrier, frigate, whatever,
Right, exactly. Just remember too, with IDQ, we pick up, an office in Korea, and I believe roughly 20 employees. So, it's a good start.
So you guys have a plan to expand to Korea? Maybe a new branch?
Yeah, very much so. Korea at the moment has one of the most sophisticated quantum networks in the world, which was built by SK Telecom and IDQ. So, it has a strong head start compared to the rest of the world when it comes to quantum networking.
Talking about quantum networking, my other guess towards quantum networking business of IonQ was that the ultimate vision for this business might be IonQ aiming to secure large-scale contracts, such as national-level quantum networking projects with U.S. defense agencies.
Yeah, very much so, especially even more so in the quantum networking space. You're starting now to see kind of the first demonstrations of quantum secured networks using public, private key distribution. And so even all the way to satellites. So China just did a demonstration in satellites, and the EU is about to do a demonstration. They've got a pilot project. So one could see that in the future that, basically the internet is being secured by quantum networking technology. All of that would be, a massive business, because you basically need to protect the existing, telco infrastructure of the internet to make sure that it's all protected by, quantum networking.
And there has been discussions about relocating IonQ's HQ to Texas when you guys attended some kind of conference in Texas, and potentially establishing a large-scale quantum networking there. Is this a real possibility to you guys?
Well, we do like barbecue, but I'll let Nicolo. We like Korean barbecue too.
Yeah, that's true. Or equal opportunity barbecue enjoyers.
Right.
We're not moving our headquarters out of College Park. We are obviously in the process of hopefully establishing a quantum center using the bill that the chairman Giovanni Capriglione has put through the Capitol in Austin. So he just started that 2 weeks ago at South by Southwest. That's probably what you're referring to. It is a bill to fund using some of Texas's $24 billion surplus for last year a leadership position in quantum computing, we should obviously, be an anchor tenant of that vision, given that it was something we've been working on a long time, and B, I live here a lot of the time. And so I think it's safe to say that, we are growing as a company. We expect to have significant on-the-ground presence in one way or the other, in one function or the other, in quite a number of cities now, right? From Seoul to Austin to Maryland to Seattle to Geneva, Switzerland to Chattanooga, Tennessee. We're doing more, and I think it's safe to say also that, we expect to grow our footprint in partnership with state governments who want to lead at this, because they recognize that we can create jobs, we can create economic growth. And they recognize that, I call quantum computing the largest shift in the compute space since it got started. Like since Shockley and his first transistor 80 years ago, we are moving away from bits to qubits. And the example I always like to give, Sean, about how significant this is from an energy perspective. If you look at your brain, the human brain, it runs on 5 milliamps. So it's very likely a quantum computer. Simulating the human brain with silicon takes a football field of GPUs, a small nuclear power plant, and a small river of water to cool it. And it's very expensive, right? And by the way, ChatGPT-4 still can't do everything you can do, right? And so, the benefits of quantum computing are not just that we can solve problems that cannot be solved in silicon, but it's that we'll be able to solve problems that can be solved in silicon for a fraction of the space and a fraction of the energy, which is going to matter for the environment, it's going to matter for cost, and it's going to imagine for states that are currently telling data center companies if they want another data center, it's not the real estate they're worried about, it's the energy and the cooling water.
And for Nicolo, how does the IonQ's new CEO, Nicolo, do you plan to lead IonQ, and what aspects do you intend to prioritize?
Yeah, no, that's a good question to maybe wrap up on, as they say. So look, we have an executive chairman, so Peter and I agree all the strategic priorities, and like in Korea, the chairman matters a lot, Sean. So, so Peter's opinion matters a lot. But what we've agreed is that we're going to prioritize the GAAP revenue guidance that we have delivered, the earnings call last month or 5 weeks ago. So getting to 75 million of revenue at the low end, 85 at the middle, 95 at the top, that's a priority. Obviously making, progress on AQ64 in the lab so we can then start shipping machines is the second priority. And if I were to add another one, obviously, on the networking side, we want to continue to demonstrate our global leadership. So, we believe that we're the networking leader. We're going to show that, obviously, technically, as well as through continued customer engagements. And we intend to grow our networking business through every customer and every vector and every segment that we can, right? So, end of the day, a lot of this goes back to the talent and the team, Sean. And so Peter and I spent a lot of time on hiring because if you have the best talent, you can do all of these other priorities.
And this is the officially last question. So you guys are aware that Korean investors own 31% of overall IonQ stock. Are you guys worried about it, or is there any message you guys want to share with us?
I would say that the company has had a very long history with Korea. Obviously one of our co-founders is from there. Samsung led our co-led our Series B, right? And so if you look over the years, just all the things we've done, now the latest one coming up with SK Telecom to be able to put together a partnership with them. So it's been a I think if we were to go through, there's probably been 15 different things we've done, more so than I think almost any other country we have done anything with, right? And so, so it's I think we've had a good, strong partnership with not obviously, the investors, but also with the government and with many of the local companies. And we're really excited by the fact that we have our first, division there and kind of boots on the ground. And so, So, we hope to continue to expand and invest in the country as we go forward. So,
yeah, I would say, we appreciate the support, Sean, and everyone that you help us keep in touch with. We really appreciate that all the Korean shareholders work hard to understand the sector, because it's not that easy to understand what's going on in the quantum computing space or quantum networking. So we appreciate the deep commitment to research information, and we appreciate your help and obviously, communicating with us across time zones, at time. But I'd reiterate what Peter said. We've been in Korea from the start. We intend to be in Korea, perpetually with an ever bigger presence. And we think that the Korean shareholder base that we love and appreciate is obviously long-term thinkers. And this is a long-term game, even though we make progress every day. We're just getting started here on the exponential growth curve that is IonQ.
I mean, I talked to Peter 2 years ago that I wanted to build something what Warren Buffett built with his shareholders. So it's quite a big change in Korea because Korean people really like to do day trading. So to spread long-term investing in Korea, it's a big challenge, but it's going pretty well because, as I already told Peter, I wrote a book about quantum investing in Korea. It became a bestseller and people understand what the long-term investing is. So we'll stay as a strong supporter of IonQ, and we do hope to see great results from you guys in the future as well.
Thank you so much, Sean. I agree with the Warren Buffett approach. He always said you only get so many bullets.
Right.
Each investment's like a bullet, and you only so many silver bullets. So we're grateful that we're one of your silver bullets.
Right, so
and we hope to be your best silver bullet over time.
It is the best bullet. So this concludes our interview today. Thank you for your time, Peter and Nicolo. 자, 이번 영상은 마지막 인터뷰 영상인데 2025년 6월 말에 아이온큐가 퀀텀 코리아에 왔을 때 제가 최고 마케팅 책임자였던 마가렛 아라카와 상무와 가졌던 인터뷰입니다. 가장 최근 인터뷰고 한 5개월 전 인터뷰니까 한번 보시면 좋을 것 같습니다. 네, 여러분 안녕하세요. 가을바람입니다. 오늘은 아이온큐의 마가렛 아라카와 최고 마케팅 책임자 모시고 오늘 퀀텀 코리아 2025에 이렇게 또 아이온큐 분들이 많이 와주셨어요. 그래서 이 안에 미팅룸에서 사전에 조율했던 질문들을 가지고 인터뷰를 나눠보도록 하겠습니다. Hello, Margaret.
Hello, how are you?
I'm good. How are you?
Very good, thank you.
Are you having a fun time here in Korea?
Yes, I love it. I've been loving it. The food, the people, the technology, the buildings, everything. It's great.
We'll start with the first technical question. It's kind of very long, but I'll try to make it short. So we know how to scale out our technology to at least 10,000 qubits on a chip. The size of a thumbnail, probably 100,000 doesn't look too scary. This is actually mentioned by Chris Bellis, CEO of Oxford Ionics. So does that mean future IonQ's quantum computer will not need photonic interconnects when you guys reach to 2029, when you plan to have 200,000 physical qubits and 8,000 logical qubits on a single chip?
Our strategy hasn't changed at all. We still will depend on photonic interconnects for scaling, whether or not, because we are still in the process of closing the acquisition for Oxford Ionics. But as you know, we have stated that photonic interconnects is fundamentally part of our scaling strategy. So IonQ previously, as we get to larger and larger number of qubits, we still had every intention of having 2 interconnected systems to then double or to get from 100, 200, 2,000, 100,000. So that has not changed at all. And with the combination with Oxford Ionics, we hope to even scale even higher.
Then we would love to know at what point will IonQ will implement photonic interconnects to the actual quantum hardware that will be commercially available.
So we've already, for us, anything commercially available is we sell a unit that has that technology to a customer. So the 3 contracts that we have signed with the Air Force Research Lab, those all actually depended on photonic interconnects. And so we are actually currently on track to deliver what we have committed to as part of those contracts.
So that's more of a customized products for AFI, right? Not standardized like Tempo or future quantum computers.
Well, that's where it's really great for the company to be able to deliver for the Air Force Research Lab what they need for photonic interconnects. But we also have the same scientists working on that for additional commercial opportunities.
So we could expect to see that technology implemented maybe within 2 years?
Well, we are already implementing, like I said, in the Air Force Research Lab work. And so you should expect that we're going to consistently develop that and develop it for all of the systems that we're going to produce going forward.
So no specific timeline yet?
Well, for right now, as we had noted before, we are firmly committed and on track to deliver AQ64, as well as up to 100 qubits on tempo, and we're on track for that. So the scaling and the need for getting to the 2,000, the 10,000, the 100,000, and 200,000, it's also part of our roadmap.
But on the blog, I saw that 10,000 to 20,000 will require interconnection. So maybe we could expect that's when we could actually see.
We're not committing to not using photonic interconnects earlier, right? Because like I said, the contracts we signed with AFRL, the Air Force Research Lab, that was in the end of 2024. So we have had a significant runway of working on it. So as soon as we continue to get more and more scale out of that technology, we will start implementing it. So I wouldn't say before or after, because it is firmly part of
The second technical question is, in the recent technical update webinar, IonQ announced plans to build 2 million physical qubits and 80,000 logical qubits with an error rate of 10 to the minus 12 power by 2013. So at that level, how commercially viable would the system be in practical terms? What kind of commercialization use cases are you anticipating at that stage?
So unlike a lot of other companies, we currently are working on applications on our current generation of computers. So the Forte Enterprise 36 qubit computer, customers are getting commercial value from it because we're working on it with them now. So imagine that we're at 36 qubits now, we're getting to 64, and then we're going to get all the way to 2 million. The use cases, some of the use cases will be the same, but the complexity of the problem will get large. We'll be able to handle more complex problems. So for example, we're working with AstraZeneca, AWS, NVIDIA on drug discovery, on helping to accelerate that process. Imagine at 36 qubits, which is what they ran it on, and they saw a 20x improvement versus previous instantiations. So then you look at that, have a much larger computer. Imagine the exponential capabilities of the complexity of the problem and the number of applications we can use, the number of drugs. Imagine that we can get to.
So we've been visiting QEra, IBM, and then IoT booth. So IBM, they plan to show commercial advantage this year. They're planning to make it this year, and I saw IonQ's long-term roadmap, the detailed one. And it mentioned that broad quantum advantage may be on 2030. So should the investors expect to see a very big value created by quantum computer maybe around 2030?
So I think investors now and customers, partners, employees, shareholders, I think we're seeing commercially advantaged use cases now. So IBM, IonQ, we are all working on current use cases that a customer finds value today. And then, as you talked with the IBM folks and you saw their roadmap, we introduced a very ambitious, very exciting roadmap. And our roadmap goes to 2 million qubits physical and 80,000 logical. And right now, as far as I know, it is the most ambitious, largest number of physical qubits, logical qubits with the highest fidelity, lowest error rate. And we are currently working with applications, and we believe we can make the hardware for the most complex problems. So we have been talking about narrow quantum advantage and broad quantum advantage. Kind of like NVIDIA. In the old days, NVIDIA cared about 2 killer apps, video games and computer-aided design, right? there was no AI in the mix. It was just these killer apps. You think about Microsoft, where I worked for 20 years. Their killer apps were productivity, Office, video games. Everyone loves video games. Video games use a lot and tax computers and make us better. But then Microsoft looked, after they built a foundation with those killer apps, then they expanded to all applications, and then they can expand from on-premise, hybrid, and cloud computing. NVIDIA, 2 killer apps in order to build the foundation, and then you get to AI, which covers all verticals, which covers, so think of it in that way. You always get great advantage in the beginning if you know what use cases to look at, and then you'll continue to get bigger and you'll be able to scale and broad quantum advantage as the years progress.
So it would be better if we see the bigger picture instead of too narrowly focusing on the details.
Well, I did bet my career and life on Microsoft early on. I bet my life on the internet would be big in 1994, before the computers were secure or fast. But it got me on to the train of understanding networking, compute power and all that. So I don't know anybody in the world that wouldn't have wanted to bet on Microsoft when the only 2 killer apps they had were Flight Simulator and Office. Because they were very robust businesses, right? Microsoft was still a player in the space. And then look what they built that into. Same as NVIDIA. Everyone should have bet on NVIDIA when it was just CAD and video games. In fact, anybody who'd bet on NVIDIA 10 years ago would have been prescient. And NVIDIA was still a very good company with robust revenues, right? And that's what we are.
Third one is, recently it seems that the photonic interconnect roadmap is experiencing some delays. At the same time, IonQ has expanded into quantum networking business. What revenue proportion does IonQ expect to come from these 2 areas? Which one do you anticipate will reach profitability fast and demonstrate faster revenue growth?
So we don't currently break out our revenues by division.
Right.
But again, like I said before, we are on track on our photonic interconnect roadmap. We know that we have a customer that we have worked closely with that is eagerly awaiting the outcome, so we feel very good about that. As far as which of the businesses, we're a full stack business. We do quantum hardware. A part of that hardware, we have quantum software and all the hybrid and OS services, do applications, and we do networking. All of that is what we believe will help us grow to become a profitable company.
So it'll be a true full stack quantum solution company.
Absolutely. In fact, actually, I was trying to think of an analogy. Okay, I'm going to try this, okay? Especially since I worked at some of these companies. So imagine you are HP and you're building out computers, but you need a BIOS and you need a chipset. So along comes Intel, which I interned at. So Intel has a semiconductor, they have chips, but they also have a BIOS. So then you have a hardware and some layer of software. Then Microsoft layers on an operating system that's the traffic hub of all of the applications that sit on top of it. That is the full stack that currently still exists, right? And then when you add in a layer like GPUs or the CPUs, it ignites the application layer above, right? The use case is now ML and AI. Imagine that happened, but there was no Cisco. If there was no Microsoft who did web servers or Cisco who built routers and switches, there would be no internet, right? So we are trying to build both the quantum computing stack, hardware, software, apps, and we know, because we've all lived in the day of computing and the internet, we need to help build the quantum internet. Because the quantum internet will scale power, but it'll scale communications, and as you know, it'll scale security as well. So that's our job. Our job is to work on all those parts and help bring it up together.
In a previous interview with Peter Chapman and Niccolo De Masi, it was mentioned that IonQ's new quantum computer, Tempo, was expected to launch around July. I mentioned Peter told me that like 2 months ago. And is it still scheduled for release in the fall, or will this schedule be delayed due to application of new technologies through collaborations with the recently acquired companies?
We are on track to deliver Tempo, a Tempo-grade computer that we will test and be using internally, exactly as we said. So that's on track. So, and again, The acquisitions of, Oxford Ionics hasn't closed yet, but we have still, our entire company is focused on delivering AQ64 and a Tempo class computer that's capable of up to 100 qubits.
So should we expect it within fall or within the end of this year?
We will actually hit our targets for Tempo this year. That's what we are on track for as far as our benchmarking and getting to that place. So that's where we're at.
Okay. Will Tempo feature 64 algorithmic qubits as outlined in the previous roadmap, or will it follow the new roadmap where the AQ concept has been phased out and instead featuring 64 physical qubits? If it's the later, how many logical qubits will that translate to?
So on the webinar that we talked about, as well as what we have published, we have not gone away from our commitment to deliver AQ64, hitting that, because as you know, AQ64 was a benchmark that looked at all the 600 classes of applications and use cases that it can be used with. We are on track for hitting that AQ64. And Tempo is the next generation hardware that we actually said that we are now able to deliver from 64 up to and over 100 qubits. So it'll be dependent upon what customers that we work with and what they need. But again, what's great, which is fantastic, is we see customers right now getting value from Forte Enterprise. If you go outside and you go to the AWS booth, the world's largest cloud provider, right on the wall that's next to us, as you can see, it says, here are the quantum computers that we work with, and IonQ is the first quantum computer listed. And they're very excited, and we announced that we have this, we've always had a strong partnership, but they were incredibly excited that they have access to a fleet of quantum computers because they see demand for quantum computers using IonQ. So if we know there's demand for the current computers, that's fantastic. And AWS has given us that indication. So has AstraZeneca, so has ANSYS, so has AIST in Japan. So we've had so many customers that are eager today to use 36 qubits because they see value today. They're running the benchmark testing. They know what they did previous. They have a control, and they use just a 36 qubit computer or 24 qubits of that, and they see they can get 12% improvement or 20x performance. So they're excited to start now, because if they can get that improvement now, they have to refine their algorithms. They have to train more people. They need to be deeply embedded now as the computers get even more powerful.
So in the recent blog, you guys mentioned that Tempo will have 100 qubits, but that could be determined on what customers want. So
right.
That could be changed.
Like for example, when we landed our deal with Quantum Basel, we were very excited, and we announced at the time that we'd be shipping to them a Forte Enterprise with 35 qubits.
Right.
And we hit 35 qubits as a benchmark before we shipped Forte Enterprise to them. Forte Enterprise in Basel, Switzerland is currently enjoying 36 qubits because the hardware is capable of getting there. We were able to fine-tune both hardware and software to hit 36 qubits. So in an example like that, a customer like Quantum Basel is not saying, no, I don't want the extra qubit, because extra qubits are exponential power, right? So they were happy that we were able to actually over-deliver from what the contract was originally talking about.
So on the new roadmap, the Tempo doesn't show any logical qubit side.
Right.
So that's not officially...
We haven't announced the logical qubit side, but as you probably know, if you look at all of the quantum computer companies in the industry, most companies aren't announcing logical qubits, but we have on the long-term roadmap, and as we develop and land Tempo as a commercial quantum computer, just like we had the 4 generations before, we will start announcing that as well.
It's really hard for us investors to compare whose quantum computer is better, because you guys do not have a standard.
Well, that's an interesting question. We used AQ because Dr. Jung-Sang Kim was very focused on the actual use of the computer. We were not a toy company. We are not just a research institute or academics. We were trying to build useful, commercially viable quantum computers. And he thought of AQ as the best way to reflect how is this computer useful, right? Because like a Formula One car can't drive on any road, it's not road legal, right? Nobody except a Formula One driver can use it. So how do you get extreme power but also usefulness? That's what AQ is about. Extreme power, useful in ML, useful in these categories. But so the reason we announced, because we have been planning this for a while, our incredibly ambitious roadmap is you can see the industry is looking at these three things now. They're looking at physical qubits, they're logical qubits, and the thing that matters is fidelity, right? If you don't have that fidelity, that's the question to ask everyone. Because if you have 2 million physical qubits and you apply, quantum error correction so that you can actually get them to logical, useful qubits, they have to have high fidelity. If you have high any qubit but low fidelity, you do not have a useful quantum computer. And if you have, as we announced, the level of fidelity that we have, that we're going to achieve, or we hope to achieve, and Oxford Ionics is already achieving world-class, groundbreaking fidelity numbers, right? So once you have those three things, then you have power, you have incredible scale, and then you have usability. That's how I would think of those three things, and that's how you should look to judge us and the rest of the quantum community. The last thing I would say though is, and ask who is using your quantum computer, and can I use your quantum computer? That's why we're on all three clouds. Then we have a lot of feedback from hundreds of thousands of quantum developers on AWS, Microsoft, Google. So we get a lot of insight and input. And then we work directly we signed an MOU with KISTI, directly working with KISTI, some of the best scientists in the world. We signed a deal with AIST, one of the most preeminent research institutes in Japan. We work with Oak Ridge National Research Lab. So we have the academic research community, and then AstraZeneca, a real commercial company that their highest levels of profitability or highest levels of cost are all related to drug discovery. So then you go, great, you're working with AstraZeneca. ANSYS is not that well known and potentially in Korea, but it's one of the largest computer-aided engineering companies in the world. And what they have, which we really want, they know every company, any large company working on hard problems using HPC. All the people who are using HPC and they don't get the answer they want, we're giving them another tool for them to address the problem. That's why this partnership with ANSYS is just fantastic.
So can we understand that the reason why you guys moved from AQ, the logical qubits, physical qubits fidelity, is to have a more fair comparison with other companies, since you guys launched the very aggressive roadmap?
We see that the industry and customers want to know these numbers.
Right.
The really nice thing is internally, like I literally talked to a customer, I can't say who they are, but they had actually used both IBM and IonQ for their use case. And they said to us, and this is the current qubit count we have. So even if you use, an IBM quantum computer that has a higher qubit count than ours at 36, they said the outcomes were better on IonQ. And again, it's why, because we have higher, better 2-qubit gate fidelities, superconducting word, all-to-all connectivity, like those kind of things, coherence, very long coherence time. When you have that comparison and you need to get an answer, the researcher or the commercial company or the academic goes, okay, I found great use and commercial viability in this platform. So that's why we get so many early signals of how useful our quantum computers are now. So that's why narrow. It doesn't address every use case in the world, neither did Microsoft or NVIDIA, but key use cases that are meaningful, that get progress and that get revenue, right?
The next question, after acquiring 7 companies, what is IonQ ultimately aiming to achieve through this strategy? Additionally, what are your key financial goals or targets as you look ahead to 2030?
I think, as you had heard, Peter Chapman, our former CEO, who is now our executive term, had said that we are very much focused on getting to profitability and getting to $1 billion. So those are still our North Star of what we're hoping to achieve. I think from a acquisition perspective, every acquisition we do is a strategic acquisition, well thought out, in order to actually land the roadmap, land the not just landing the roadmap, but landing the use case and the applications that will be used on those. You know, we're hoping to build the world's most powerful quantum computers, and then we don't stop there. The next part of the sentence is to solve the world's most complex problems, because that's what the world needs.
And then once all recent acquisitions are completed, IonQ's headcount is expected to grow to around 900 to 1,000. So that's our expectation. And integrating the technologies, cultures, and talents from multiple organizations is never easy. How is the company managing this integration to create meaningful synergies?
What's very exciting is if you think of the leadership team of IonQ, we have a lot of people who are professional managers who have been at companies that know exactly how to integrate. Rima, who came from Cisco and from NVIDIA and started also in Solaris. I came from Microsoft, and I actually had to do several acquisitions where I helped with due diligence, and then I actually had to integrate the companies into my. I used to run security for Microsoft, so I integrated 2 security teams into my group. And then you think of Thomas's background, at whether or not it's Oracle or Siemens. You think of Nicolo's background, his ability to understand how to bring disparate parts together and make synergies happen. You look at Ariel, our SVP of product, ex-Google, ex-Cisco. So when you think about all these people, we are professional business people, incredible fans of the technology. I hope you think we're good at our function, but we also understand how to build teams and how to grow, you know, putting together teams from different areas. I've been incredibly excited. I got to visit and talk to the Oxford Ionics folks, Dr. Chris Balance, Dr. Tom Hardy. They're incredible. Met all of their senior leadership team, incredibly enthusiastic. We're in the same space of trapped ions. I've seen the physicists, you know, talk to each other. A lot of them grew up together. They studied together. So you have that. I've been closely talking to the Capella space people, you know, and then that's an acquisition that we're looking to close. And they're unbelievably excited about this combination, because they said they always knew that for the satellite and space business, they want to grow the QKD business. That's a huge part of what they were looking to do anyway. So when they see that we have ID Quantique's expertise, we have Qubitex expertise, we have Capella's expertise, and then we have Oxford Ionics and LightSync, you put that together, it means we're building incredible hardware. We have incredible folks on the software team, because, you know, we've been growing that software team. We have world-class application folks. So then you have quantum computing and hardware and software and apps, and then you have networking. And so I like to say we care about the full stack as well as networking to actually extend and expand and scale. So you will look at IonQ as we can help on the ground, in the air, and in space. And I'll explain the air thing because no one understands that. I was like, air, why air? But I use air because right now, if you think of the quantum internet, as we build out the quantum internet, we are not laying new fiber. The existing fiber optics that currently build the internet right now, we need to use that. So some of our contracts with the Air Force Research Lab, one of the contracts is literally about down converting quantum to work with existing fiber. Another part of that contract is working with on ground to the air, unmanned aerial vehicles like drones. So we're working on the ground, right? Qubitex, EPB network, and then we are now, you know, working on in air from on the ground to air. And the incredible addition of Capella means we are now going to focus on how do we get quantum in space. How do you get that incredibly secure connection as well as the global visibility around the world? I wanted to tell you, I was doing an interview yesterday, and somebody asked me, why is South Korea a great place to invest in? And what's helpful for as a growth, why do we invest here? And I said, I think South Korea has incredible resilience and grit and a work ethic that is astronomically great in the world. And then you have the most incredible scientists and talent. The number of university students that came up to me to talk to me has been delightful. The number of this year versus last year, all universities coming in. And then the other thing I was thinking of, because you have like companies like Samsung. You know, Samsung was an early investor in IonQ.
Oh, right.
And you have LG, who, you know, we talked to and is incredible. They have this beautiful booth there. And you have, you know, Hyundai, who we've talked to and worked with over and over. These are innovators, they're pioneers, and they're creative, and they're bold. All of the reason why South Korea has invested heavily in quantum and why I believe South Korea will remain one of the biggest leaders in quantum, those aspects are like us. And those are the things we want to combine with and work with companies and countries, because that reflects our goals.
Are there any other ongoing discussions to acquire additional companies, or are you guys open to acquire more companies?
We have no announcements at this time to make, but we are always looking to continue to grow our company and hit the goals that we see.
There was a rumor that IonQ got some suggestions from bigger companies to sell the companies to them. Can you comment on any of those aspects?
I think there are lots of rumors like that, but none of them are justified or things that we talk about. Because, again, as you can see, we raised money. We're very well capitalized. We also are able to acquire and grow our roadmap and accelerate it. That's our plan. That's the plan we're working on, right?
From our perspective, IonQ might have two options: to become a big tech by yourself, or integrating with other companies to have a bigger synergy.
Right.
So I mean, you guys could, you know, like consider between those two options in the future.
Right, and I think, you know, those are all business decisions that, you know, companies make. But again, back to what we're focused on, we're focusing on growing IonQ. That's why you've seen that we've done the acquisitions we've done. We have an ambitious roadmap. We're partnering. The two biggest companies that have been so incredibly great partners for us, and we learn from and we work with, are AWS. You know, they renewed a multi-million-dollar contract. They're very excited when we're on Amazon, you know, AWS bracket. We just announced the partnership on the application we launched at ISC. And so, like, when you have NVIDIA, who, I have to show you this photo. Maybe I'll show it to you. I haven't actually posted this photo yet, so you get to see it, and then I better actually post it, because now I'm showing it to you. But look at this photo.
Oh, you took a photo with Jensen.
Yeah.
Where was this?
This was actually at GTC in Paris.
Paris?
Yeah.
That's
so,
like 2 weeks ago?
Yeah. So I think I only show that because it was just funny, because he, at the GTC Paris, he got up on stage and talked about the different platforms. He clearly, explicitly said on stage, the different platforms. Every year I go to GTC and I say, what are the next platforms that we're trying to help create? And he said quantum. He said the fifth is quantum. And he also said on main stage, he says, I see quantum at an inflection point. So all of that's been fantastic. We work closely with their team. We work really hard on making sure that we know how to leverage CUDA-Q and be able to create hybrid services. And that's unique, because not a lot of other quantum companies are doing that. And why do we want to do that? Because NVIDIA is an incredible partner, AWS is, AstraZeneca. If you put three mega respected companies that are great at their space, and we provide quantum expertise, then we get great outcomes, right? The best and the brightest in the world working on the same problem. That's how we want to grow and how we want to play.
I remember that Jensen he mentioned that every supercomputer will have quantum in the future. So do you think that's the mega trend where quantum will be in the near future, working together with the supercomputers?
100%, because right now we need supercomputers, right? There's no quantum solution that doesn't have a pairing with a HPC or a supercomputer. And it's a symbiotic relationship, right? You know, like, for example, a supercomputer or an HPC computer will be looking at an AI problem. and they look at an AI problem, like the problem is ChatGPT. They're like, okay, we're now at ChatGPT 4, or we're at trillions, of parameters, and ChatGPT gets bigger and bigger and bigger. So the compute power that's needed to process ChatGPT 4 versus 1 is astronomically different, right? When you're going from millions to trillions, and you have all of this great power in the supercomputers using, NVIDIA's GPUs, so you get all of this power. But one of the problems with having that hungry, LLM is what? Energy. It costs a lot of money to run all of that. So one thing we're working on with lots of different partners is, since quantum is very good at things like, pattern detection. So, LLMs and ChatGPT, those are about like pattern detection, right? Patterning, looking at a lot of words, figuring out this massive database of parameters. How can I come up with an answer? Quantum is very good at that as well. So you put those powers together, and let's say you run a huge LLM on a HPC. You take one level or one layer of that large language model problem. It's usually linear algebra. You pull that part out, and you have this still running, right? Classical compute. You give that workload to a quantum computer because it's symbiotic, because quantum will solve this particular LLM linear algebra problem differently than this full stack. And then you work together. Quantum will get input from classical and back and forth. But we're hoping that quantum will reduce the energy load of LLMs and data centers using AI. And we hope to use quantum to help accelerate. Jensen says this. He often says it's quantum enabled, quantum accelerated, and that's what we both believe. So.
Do you have any plans to raise more capital in the next 12 to 18 months through equity, debt, or other instruments?
We haven't announced any type of plan for that.
Okay. And then recently, insider stock sale plans amounting to nearly 4% of the total shares outstanding have been disclosed by Rule 10b-5-1, and a significant portion of those sales is already underway. Could you comment on this part?
So, as you know, 10b-5-1 plans are plans that are instituted way in advance for insiders to be able to trade with no insider information. That's the reason they exist. And for a lot of people at the company, we have a lot of insider information. And it's only fair that they do not take any advantage, and that's why they put those plans in, right? So, I mean, we're highly ethical. I love this company. We always try to do the right thing, and in that case, that allows, insiders to sell. Those plans were made, months and years in advance. And then any particular trade that somebody has, we don't comment on someone else's personal financial portfolio.
But we were worried about the amount of sales that were coming. It was like 10,000.
Right.
So
again, if you imagine that the roadmap that we just announced, a lot of the parts of that roadmap we have known for a long time, but also some of those parts, or the fact that we are able to actually close, you never know if you're going to close an acquisition. We're incredibly happy we closed the IDQ as the majority shareholder. We're incredibly happy we closed Cubitech. We're incredibly happy we closed LightSync. So you don't know if you're going to close. So anybody that is betting on IonQ, you bet on the company with your life, and you bet on it way in advance before you know the outcome, right? And that's all those are. So I wouldn't look at that as any indication from internally. I mean, look how excited I am. I'm very excited.
Yeah, I asked this to Timothy or Nicole, that you guys receive a lot of stocks as a compensation, a part of your salary, right? So do you expect the stock price will go up in the long term? I bet you guys are, but how confident do you feel that?
I think we're all betting with our life.
Right.
That IonQ will continue to be successful. That's our goal. When anyone says, hey, how much do you believe in IonQ? I say, well, I work 20 hours a day.
That's a good answer.
Right?
Yeah. And what are your thoughts and opinions on the looming threat of post-quantum cryptography and quantum attacks in the near future?
Well, I think we focus on being the white hat hacker. We focus on building and delivering quantum to enable good things and to prevent bad things. So like I said, I worked on security at Microsoft for 3 years. I'm fairly deep on security, and as you know, post-quantum cryptography indicates that there are algorithms that you're creating now to prevent when, not if, when quantum computers are so powerful they can break RSA 2048. And we actually as IonQ, as part of our acquisition of ID Quantique, as well as what we've been working on internally, we are focused on quantum key distribution. It's a part of the portfolio of what we sell. And quantum key distribution is 100% part of the security landscape, right? Of how do you actually continue to have very highly impenetrable, secure communications. And then post-quantum cryptography, we are 100% working on making sure that we have internally and externally, we partner with the good guys to make sure that we want our quantum computers to be used for the good of mankind. Even Apple, right? Apple, who is a consumer product, right? Their iPhone, they implemented, a different level of security on iMessage, right? They actually had a blog post about post-quantum cryptography. They said, it will be coming and we will be ready. WhatsApp and Signal also had that as well. But when you think about a consumer company saying that, and us as a quantum company, we need people to be aware, and then we all need to work together to actually create the algorithms that offset what a quantum computer can do. Quantum computers will both be able to break encryption and stop it from happening. That you need that power on both sides. Because right now, right, it'll take, even just for 256, or any level of encryption that exists now, for classical computing to break encryption of 256, it'll take hundreds of millions of years. One day, and it's very soon, when we have a quantum computer with that large number of qubits and logical qubits, the space, computational space expands dramatically, right? And it is believed that one day, when we have those computers, quantum computers will be able to break that level of encryption in hours or days.
I recently figured out that Chris Monroe has returned to IonQ as Chief Scientific Advisor. So I'm curious to understand the context and implication of his return.
Well, what's really exciting is that we're still maintaining close ties with our founders. And Chris Monroe has actually he's in the same space as us, trapped ions. And he, at his lab, has been hitting world records, trading it off with Oxford Ionics and hitting them. But he has also been very instrumental in giving us guidance and continuing to give us guidance in the trapped ion space. So given he was doing it for us and he's in close partnership with Niccolo, we decided that we should make it more official because he is giving us scientific advice. So it was really exciting.
What we thought was that since photonic interconnect is a really hard technology to implement commercially, we thought Chris should step in and help more directly IonQ. And then you guys have to integrate the Oxford Ionics technology as well, right? So that's where Chris has to step in. So
he isn't taking an operational role because we are in charge of the operations of the photonic interconnect scaling that we're getting from the Lightsync acquisition. It was closed. Dr. Mihir Bhaskar now works at IonQ, and being able to go from no memory to memory enabled and being able to get that kind of 50x scaling capability. 50x scaling because of the technology they have that enables better entanglement for photonic interconnects. That capability is embedded in IonQ already because Dr. Mihir Bhaskar works at IonQ. He's a fundamental member of the engineering team. We already had photonic interconnect expertise through our Entangled Networks acquisition. Remember that one? So we have that deeply embedded in our company already. So that operational work, some of the best and brightest minds in the industry on photonic interconnects, we have them. And then the Oxford Ionics work is, because that scales up once you have 2 chips. If you can get more qubits, in the chip using, off-the-shelf, semiconductor, if you could do that, that's the best of both worlds that we're working on. Because the one fundamental that we know in trapped ions is we have a layer of, like I said, better coherence, we have better fidelity, Like that in all-to-all connectivity, that with more qubits on chips and the ability to scale them and network them, that's our goal. Chris has been incredibly advising. He still mentors and advises the physicists, but the operational work, the integration, and building upon what I just said, that's solely in the hands of the engineers and the integration folks and all the rest of it.
So Chris is working part-time for IonQ, so he'll receive RSU, PSU, all this.
I can't comment on how he's being paid.
So we remember that Jung-Seng, when he left, he was the chief scientific advisor, right? A few years ago. So does that mean their role changed?
I think there will always be chief advisors and scientific advisors to IonQ. They co-founded the company. They made the breakthroughs in the trapped ion space, as you know, Chris did 30 years ago, right? Being able to showcase how trapped ions is ahead of all the other modalities. And, as I said, Jung-Sang had always had a vision of usefulness. He was very focused on AQ because he wanted to make sure that the computers were useful to end customers. So that had always been great, our great heritage. With Peter Chapman that came in Niccolo, they're looking at how do you expand commercially and get even larger and bigger with more customers, more partners, with bigger and more ambitious plans across this entity of quantum computing, because quantum computing has grown since they started the company. And so now we're all rising to the level and excitement of the momentum that we're generating.
But aren't you worried about the sales if U.S. government intervenes and they make export controls like they did on the semiconductors to China, Russia, or other countries?
We don't, for both export controls and tariffs, we get this question a lot. And I think the really great thing is we are a U.S. company. A lot of the deals, as you've noticed, were shipped in the U.S. The last deal that we talked about and we announced, the EPB, is the first utility company that has both a quantum network and a quantum computer. That's a quantum computer, a Forte Enterprise, that will be shipped to Chattanooga, Tennessee. So we have a lot of traction and a lot of great relationships, customers, partners, as well as academic institutions in the United States. So that's always fundamentally been a really great part. And again, we have existing U.S. Air Force contracts that we're working with. We have, we work with ORNL as an entity in the U.S. With that said, we have Switzerland with IDQ as well as Quantum Basel. With that said, through our ID Quantique, majority shareholders of ID Quantique, we actually have a presence via their entity in South Korea. So that's great. We have, we're working closely with researching companies in Japan. So we do look at key countries and key opportunities where it makes the most sense.
More friendly.
Yeah, but if you think about it, obviously the U.S. wants to win versus China. China keeps saying they've hit quantum advantage, but it's hard to believe it because there's no integrity of IP and there's no integrity of you have to say the truth, right? In press there. So the U.S. and our allies, the UK. Oxford Ionics is in the UK. Our allies here in South Korea, our allies in Japan. We need to win as entities against that threat because China invests a lot of money. But so there's that, and then the second part is the biggest compute countries in the world. Because I worked on compute, I worked on servers, I worked on operating systems. They haven't changed. So remember, if we think I want to have a quantum computer in every data center or a quantum chip coinciding with a supercomputer, like how Jensen talks about it. If I want that, then where would be my target audience? It would be where do people use compute? Besides China, the biggest compute markets are the US, the UK, Japan, Germany. They haven't changed. And then in South Korea, what you really have that's great is you have the users that need quantum. Right? Hyundai worked with us early on because they understood that they have to make, they have to look at their battery composition to make better batteries for autonomous vehicles. They need to look at object recognition for autonomous vehicles. They need to look at, we published a paper with them recently on looking at the microstructures of steel. Because imagine like everything that's built in the world that's made of steel, ships, cars, airplanes. You want to make sure that you increase the stability and hardness of it so that they're safer. In England, they have banks. In England, they have, England is actually one of the top 3 tech industries in the world. It's not that they have all of the companies that are all started there, even though Oxford Ionics has started there. They have a huge tech industry. Why? Because imagine ARM. ARM is in England. Their top 5 customers are American. So if you know that you have this symbiotic relationship of working with different countries that already use computers, they already need HPC, that's when you think, oh, that's why we want to work in those countries, right?
I mean, as an investor's perspective, I hope IonQ follows Palantir's path. That's what we are expecting.
Right.
So I hope it gets bigger and better than Palantir.
We have incredibly big ambitions, but we're very confident. We have the right people, we have the right technology, and the right partnerships.
So that concludes our interview. So thank you for your time, Margaret. So we hope to see you next year as well.
Absolutely. Thank you very much.
이번 영상은 제가 최근에 9월 중순에 뉴욕에 직접 초대받아서 뉴욕 증권거래소에서 아이온큐가 기관 투자자들한테 투자자 설명회 할 때 참여한 후에 이제 서양에서 저의 역할을 하고 있는 서양의 가을바람인 데스몬드, 이분이 이제 트위터 X에서 활동 중이시고 저랑도 이제 가끔 인터뷰도 하고 얘기도 하고 하는데 직접 만나서 거기서 애널리스트 데이 때 들었던 거를 같이 나눈 영상입니다. 그래서 직접 아이온큐 인터뷰는 아닌데 뭐 저만큼 아이온큐를 깊게 보고 오래 봐왔던 또 아이온큐 집중 투자자인 데스몬드님과 제가 아이온큐 애널리스트 데이, 어떻게 보면 가장 최근이잖아요. 9월 달에 어떻게 봤는지 그 뷰 한번 같이 보시도록 하겠습니다. 네, 여러분 안녕하세요. 오늘은 드디어 우리의 형제 데스몬드 형님을 드디어 만났습니다. 그래서 갑자기 저도 모르고 있었는데 그 뉴욕 익스체인지에서 뉴욕 증권거래소에서 들어가서 이제 앉으려고 했는데 오시더라고요. 어떻게 왔냐라고 했더니 초대를 또 받았대요. 며칠 전에 받아서 급하게 오느라 연락을 못했다고 했는데 오늘 또 이렇게 애널리스트 데이에서 무슨 얘기를 했는지 함께 나눠보도록 하겠습니다. Hi, Desmond.
Hi, Sean.
Would you say hi to the
Hello, 안녕하세요. Hello, IonQ family. It's great to be speaking with you. It's great to finally meet Sean in person. When I saw it was like we've known each other for years because we have known each other for years. But just to be in person, it's just meant a lot. And we have an instant connection. And it's just he's a. I will tell you, for anyone who hasn't met him in person, he's even better in person than he is on YouTube. So he's just so it's just been a great day. I've had a really fun day.
I'll do a little translation. 여러분들 너무 반갑습니다. 제가 데스몬드이고 이제 가을바람이랑 여러 번 줌으로 인터뷰를 했는데 실제로 만났는데 이제 뭐 처음 보는 게 전혀 어색하지 않았고 저를 실물로 보니까 훨씬 나았다고 하네요. So, what did you think about today's analyst day?
It was like two or three sporting events all in one. It was like the Super Bowl, the World Cup, the Olympics all together. There was so much information. Yeah, it was just awesome. It was awesome.
오늘 마치 제가 애널리스트 데이 어땠냐고 여쭤보니까 여러 개의 스포츠 경기를 한 번에 본 것처럼 너무 멋있었고 너무 많은 정보들이 있었다. So what part did you like particular?
I just thought all the presentations were really honest. It was the most like Nicola De Masi and when everyone was speaking, it was like I told you, I was like they're really showing the real numbers. They did just say we're faster or we're better. There's actually numbers being revealed with it. So I thought that was really something new. Like they were very concrete, and so I like that. It wasn't just we're going to do great things. There was really concrete numbers next to it. So I like that a lot.
제가 어떤 점이 마음에 들었냐라고 여쭤보니까 이제 기존에는 조금 애매하게 뭐 더 좋아진다 이랬는데 이번 프레젠테이션 때는 뭔가 이 구체적인 숫자들을 던져주면서 이만큼 나아졌다, 이만큼 개선됐다 이런 부분들이 훨씬 좋았다 이렇게 좀 얘기를 해주시네요.
Because even as a supporter, you know, you believe in the team and you believe in what they're doing, but it's so much more real when they have like concrete facts. When they're like, here's an example, this is what we've done, here's an example, and so I thought that was really important. Another thing that I noticed was, I'll let you again.
그래서 그런 우리가 아무리 아이온큐를 좋게 생각해도 좀 애매모호하게 뭐 그냥 좋다 이렇게 얘기하는 부분들이 좀 있었는데 이번에 이제 프레젠테이션 슬라이드를 나중에 보시면 아시겠지만 뭐 경쟁사들에 비해 몇 배 정도 나아졌다 이런 구체적인 숫자들을 보여줬던 게 이제 이 회사를 신뢰할 수 있는 좋은 계기가 됐다.
Another thing I noticed was that they weren't afraid to call out their competitors.
Right.
For years, it was
change.
always like we're working on our thing, and they never mentioned they weren't as
aggressive,
competent, right? And this time, right on the slide, I remember I touched you, and I was like, look at the right side of the slide. It's like we're better than Inflection, we're better than IBM, we're better than PsiQuantum, we're better than Quantinium. We're like naming them, you know. And I thought, wow, that's, to me, that shows a lot of confidence that your execution is doing really well. So that I noticed that right away.
그래서 특별히 또 눈에 띄었던 점이 뭐 경쟁사들보다 얼마 정도 좋았다라고 하는데 애매하게 그냥 경쟁사라고 하는 게 아니라 뭐 IBM, 컨티니엄, 사이퀀텀, 인플렉션 같은 구체적인 경쟁사들을 언급해서 이렇게 공격적으로 노골적으로 우리가 더 낫다라고 했던 게 처음이어서 놀랐고 그만큼 자신감이 있구나라고 생각을 했다라고 합니다.
I also noticed one of all the acquisitions, the one that was least highlighted or ever talked about was ID Quantique. This time, ID Quantique had a big role, and the CEO was there talking about it. And they also mentioned SK Telecom and how they want to integrate quantum all the way through into the digital backbone of South Korea. So I think ID Quantique and South Korea is going to be a major story in this next chapter. I think that there's a reason why those two stories were right next to each other. I think that's going to be important for IonQ going forward.
그리고 또 중요했던 점이 이제 여러 인수했던 회사들 중에 가장 소외됐던 게 이제 ID 퀀티크인데 그 회사를 이번에 굉장히 많이 언급을 했습니다. 그리고 SKT까지 언급을 했기 때문에 이제 앞으로 아이온큐가 이런 한국 경제의 디지털 백본까지 이제 깊숙이까지 관여해서 뭔가 이 한국 쪽에서 많은 걸 하겠구나라는 걸 추측할 수 있었고 실제로 아이디 퀀티크의 CEO까지도 이 자리에 올 만큼 굉장히 강조되는 부분이었다. 그 부분이 놀랐다라고 하시네요.
And another thing that I felt right away, and I told you in the room, was the talent density.
Right.
I mean, they had these individuals on stage, and each of them were very, very senior people.
Big figures.
Big figures. And what I told you was what I think is significant is that when these big figures come to a small company like IonQ, there's something very serious there. Because a lot of times young companies or start companies, they'll get young people to come and drop everything. But when you have someone who's in a senior career position, they have kids, they have education to pay, they have a house payment, they have all these commitments in life that they're not going to leave a secure position for something that isn't real. So to have so many of these people in very, very late career, senior career positions moving over, it's because they believe that there's something significant happening there.
I mean, Nicola was the youngest there, right?
He was the youngest by far.
But he was so
far.
good at managing those people
in
front of the audience.
Yeah, and I think that might be his best skill. Right, Sean? Because a lot of times when you bring it's managing egos.
Right.
You know, all these people have they're brilliant people, so everyone is very, very smart, very talented. How do you manage all those egos? And I think that might be his greatest skill, is being able to handle that. Yeah.
그리고 그 이벤트 중에 이제 파이어사이드 챗이라고 해가지고 이제 주요 임원들을 모시고 이제 CEO가 질문을 하면은 그 임원들이 대답하는 뭐 대중들이 궁금해할 법한 거를 이제 얘기해주는 그런 자리가 있었는데. 니콜로 데마시 CEO가 40대 초반으로 가장 어리고 거기에 나왔던 사람이 릭 뮬러,
Marco Pistoia,
Robert Cadillo, and
yes.
who was the last one?
The first one that was next to him.
Rotler?
Yeah, Martin Rotler.
Rotler,
yes.
그 사람들이 이제 나이가 뭐 최소 50대고 뭐 국장급, 뭐 마이크로소프트에서 he was like a team leader.
He's the head of apps.
Oh,
so
applications.
Martin Redler he handles all of the applications, and then Marco Pistoia is he's going to be doing industry relations, but he came from JP Morgan and really quantum finance. So these are all very senior people.
이 사람들이 최소한 30년 정도의 경력을 가진 어마어마한 베테랑들인데. 그런 사람들을 이제 니콜로 데마시가 굉장히 본인이 어림에도 불구하고 그 사람들을 잘 매니징하고 뭐 질의응답을 이끌어내고 이런 것들을 보면서 우리가 이 사장이 이런 사람들을 데려오는 것뿐만 아니라 잘 관리하는 게 굉장히 뛰어난 역량이구나라는 걸 알았고 젊은 사람들을 데리고 오는 게 아무래도 편하잖아요. 자기가 이제 매니징하기. 이렇게 나이가 있고 거물급들이 들어온다는 거 그거는 이제 분명히 우리가 보지 못하는 뭔가가 있기 때문이다. 아이언큐한테 분명히 좋은 사인이다라고 얘기를 해주셨습니다.
I thought what else was really interesting was Inder Singh.
Inder Singh, right.
He was so confident and so comfortable and at ease. You could tell this is someone who's been at the highest levels.
Yeah, he was so relaxed.
He was so relaxed, right? Because he's like I've been the head at he was in a Cisco, that big company. He was a big lead there. ARM, which is a big semiconductor company, he was a big top lead there. There was just such a comfort and an ease. That's confidence, and that's a different. It's a different energy, isn't it? Rather than people who are it feels like people who are building something new and just starting versus folks who are like very confident and know how to, they know how to make the next move. They're not guessing. Yeah. So I thought that was telling too.
그래서 우리 앞자리에 이제 인더싱 CFO이자 CEO이자 아이온큐 어떻게 보면 2인자인데 그분이 앉아 계셨어요. 근데 그분이 발표를 마지막에 했는데 굉장히 편안하게 발표를 하시더라고요. 그래서 그 자신감이 굉장히 좋았고 또 만약에 이런 일을 처음 해보거나 경험이 없으면 굉장히 떨고 긴장하고 그런 모습이 나왔을 텐데 되게 이제 총중들을 이렇게 압도라기보다는 이렇게 잘 데려가면서 본인이 할 말을 되게 잘 하더라고요. 그래서 아이온큐에 또 다른 굉장히 뛰어난 인재가 왔구나 이런 것들을 알 수 있어서 굉장히 좋았습니다.
And the main takeaway I have about this my experience with everyone today was there is no chance, I can say this now on video, there is no chance IonQ is trying to get acquired. There is no, these are not people who are positioning themselves to get acquired. These are people who are like, we're going to be the top company in the world. That's the mentality and that's the energy. Like Chris Balance, we talked to Chris Balance from Oxford Ionics. He was not going to merge with IonQ if IonQ was just going to sell itself to a bigger company. His goal is to be the best, right? And so I just the sensibility, the mentality is to execute at the highest level and to win. This is a team that wants to win, not do just enough so someone wants to acquire. It's not about acquisition for them, and that was very telling in my conversations with folks.
그리고 이번에 이 얻었던 가장 큰 교훈 중에 하나가 이 행사를 봄으로써 아이온큐가 인수합병될 생각이 별로 없는 것 같다라고 생각을 하셨는데 그 이유는 이번에 온 거물급들이 이제 단순히 이 회사가 다른 데 인수된다면 그걸 만약에 조금이라도 알았다면 그 사람들이 오지 않았을 거다. 그 사람들이 이제 최고였고 또 아이온큐에 온 이유는 또 양자 분야에서 최고가 되기 위함이다. 그래서 일례로 드신 분이 이제 옥스퍼드 이오닉스의 크리스 발라스 CEO가 오셨는데 그분 같은 경우도 이제 자기 분야에서 이온 트랩의 충실도에서 1등이었는데 이 회사랑 와서 뭐 대충 인수되고 끝난다? 그럴 사람이 아니다. 그래서 본인이 봤을 때는 이번 행사를 통해 아이온큐가 인수합병을 뭐 큰데 시키고 그냥 엑시트한다? 이건 아니다라고 생각한다라고 합니다.
I don't know what the correct expression would be in a Hangul model, but it's a competitive fighting spirit. Like these are competitive people. They're very smart. You meet them and they're like, they just seem like very smart engineers and scientists and thoughtful because they are. Right. But right beneath the surface there is a competitive fight. Like these are people who want to win, and so that the acquisition is just not. That's not who these people are. That's not who this group is. They're assembling people who want to win, who are competitive. I think that's important.
그리고 오늘 그 나왔던 그런 핵심 임원들의 공통적인 모습이 겉으로는 되게 유하고 되게 막 그냥 똑똑해 보이고 이러는데 실제로는 파이팅이 넘친다는 거죠. 속으로 이제 우리는 쟤네랑 경쟁 붙어서 이길 거야. 이런 것들을 좀 많이 느꼈다고 합니다. Then I want to talk about the other side, negative things. So what I thought was they laid good foundation, but they didn't share with us any technological actual advancement or reducing their negative profit. Or I don't know how to put it, but what do you think about in that terms?
I'm not concerned about the spend because you know they. As soon as they got that $1.6 billion in pro forma cash, as soon as they raised that money, that was a signal to all of us that they were going to be in hyper growth mode. Meaning they got all this cash. Then they hired David Chung. He's the new VP. Yeah, we met him. He's the new VP of Business Development. He specifically, I mean, he's sick. That signal is there's going to be inorganic growth. So inorganic growth meaning we're going to be acquiring. We're going to be there are more pieces here, and also with Inder Singh, you know, what was the first thing he said? He was like, "Yes, the tech is great. Yes, the people are great, but how well capitalized are you? I want to know about the money." So I think I would say that. Yes, they have the cash, but also I think they're very well capitalized and in a great position. Otherwise, there's no way he would have accepted that position. So, you know, I think for the stage that they're in, which is scaling, they want to scale. That's what separates them from all the other quantum companies is you have to be able to scale. Once you can start manufacturing and producing and that's what makes them a whole different type of company. And then they get rated, the stock will get re-rated. Right? Because right now, IonQ kind of moves like everybody else does, right? Because everyone thinks quantum is all the same. By scaling and making these investments, that's how people go, well, these other four are like this, but IonQ special. And so it gets a different stock rating.
So David hinted that there will be more mergers in the future?
He didn't hint that. What I'm saying is him being hired hints that. That whole job, the title is VP of Business Development. So basically what basically what that job is, it's looking around for acquisitions. Like what companies could, so that's what that role is basically. Because remember, that's what Jordan Shapiro used to do. Jordan Shapiro, before he went to be president and general manager of networking, he was really a part of that identifying entangled networks, Cubitech, and doing all that kind of work. That's what David's role is going to be, is, you know, really looking for that type of, so, and you know, with the technological gates, I think it's always with them, Sean, it's a question of timing. Like, they might be there, but it depends on what announcements they want to make when, because IonQ doesn't like doing one-off announcements. They like doing two things together. So they're going to probably want to make it a technology announcement with a customer deal, like something like. I just noticed that they never do one. They like to have two things together. So yeah, I mean, I think all of us would have loved to have like you said, a big announcement, a big reveal. But that's what we're always kind of anticipating. But for me, they really gave the what stuck out to me was the tone. They're speaking differently. We've been listening to them for years, and it just sounds like a very different company. It's much more competitive and much more aggressive. You know, and so it seems a lot more confident to me.
제가 여쭤본 게 이제 좋은 얘기들은 이제 거기까지 잘 들었고, 이제 부정적인 얘기를 좀 해보면은 기술적인 진전이나 뭐 매출 면에서 큰 뉴스가 나온 게 없지 않냐 라고 말씀을 드렸더니, 이제 아이온큐가 경쟁사들이랑 똑같이 주가가 움직이는 게 아직은 외부에서 봤을 때 다 비슷하다라고 보는데, 아이온큐가 이제 그런 거물급들이 들어오고 이제 필요한 회사들을 인수하면서 이제 달라질 준비를 하고 있다는 거죠. 특히 데이빗 청이라는 이제 DMI 그룹의 상무급이죠. 이제 해리유가 있었고, 니콜로가 있었고, 데이빗 청이라는 사람이 이제 상무급이었는데 그 사람이 아이온큐에 사업개발 전무로 왔어요. 그래서 실제로 저도 만나고 얘기를 해봤는데 한국계더라고요. 그래서 교포라서 한국말을 못했는데 그분이 이제 하는 일이 결국에는 M&A를 하는 거고 필요한 기술이 있으면 가져오는 거다. 그래서 아이온큐가 지금 한 17억 불 정도 확보를 했어요. 그래서 인더싱이 뭐 다른 회사들도 좋고 뭐 이길 수도 있고 하지만 제일 중요한 건 뭐냐면 아이온큐는 빵빵한 현금을 가지고 있다. 이걸 강조했는데 그걸로 결국에 또 필요한 회사들을 살 수 있기 때문에 이제 확장성 이제 본격적으로 기술적으로 보여주고 매출 내는 거 이거 준비가 됐다는 거죠. 그래서 그건 시간이 지나면 나올 거고 또 아이온큐 같은 경우는 여러 뉴스를 한 번에 내는 걸 좋아하기 때문에 기술적인 진전이나 큰 계약들, 고객 수주 같은 거를 뭐 지금 당장은 안 나온 게 좀 아쉽긴 하지만 또 모아서 조만간 내지 않을까 이런 생각을 가지고 있다라고 합니다.
So here's a technology announcement. It wasn't an official technology announcement, but it kind of was a technology announcement. It was seeing Chris Monroe on stage.
Oh, right.
Remember, like he had left, and then he was kind of saying negative,
he just
disappeared, and then kind of making sort of negative comment. Now he's on stage as a scientific, smiling, making very positive IonQ statements. You could tell, like, he's excited. He clearly, the people that have all the world records against him. Remember, he had the world record, and then Mahir took a world record, and then Chris took the world record. They were competing, and now they're on his team. And you could just tell he's like a coach that feels like really excited. And again, I think that him being on that stage also speaks to something special about Nicolo. Because I think Nicolo figured out how to repair that relationship, right? He did something happened there that repaired that relationship where he went from I'm angry in a huff to now I'm back in the fold and on stage and so to me that is a big technology announcement that Chris Monroe is back on the team and excited and engaged. So that I think that is significant.
Did you know that when he appeared on the stage, the stock price soared?
Oh wow! Yeah.
So I think you're right.
Right, like there's just something there, right? Where you kind of go, oh wow! Like it was.
He abandoned IonQ, but he came back.
But he came back, right? Like so, it lets you know that I don't think it was a technical reason. I think it was a personality reason.
Maybe Peter Chapman or something.
I don't know. We don't know, but I kind of feel like there's a skill set that Nicolo has where
That's a good point.
But I think it's significant that the founder of the company who really has this technology, like the legacy for the company, is back in front and center and wants to be present on an analyst day, wants to be a part of it. So I think the results from that, we're going to see a lot of positive benefits from that technology wise.
그리고 또 한 가지 주목하셨던 게 크리스 몬로 박사님이 이제 아이온큐 공동 설립자였는데 한 2-3년 전에 떠나셨죠. 그래서 그때는 조금 이거 좀 뭔가 관계적인 문제가 있어서 떠난 것 같다라고 생각했는데 이번에 스테이지에 올라와서 웃으면서 아이온큐에 대해 굉장히 긍정적인 얘기들을 해주고 내려가셨습니다. 그래서 실제로 크리스 몬로 박사님이 스테이지 그 무대에 올라오자마자 주가가 튀었거든요. 그래서 아마 니콜로 데마시 CEO가 이런 사람 관리, 관계 관리 이런 걸 잘해서 아마 뭔가 아이온큐에 뭔가 힘들거나 감정적으로 상한 게 있었는데 그걸 잘 해결해서 돌아온 게 아닐까. 그래서 아이온큐한테 굉장히 좋은 일이었고 주가도 반응을 했고요. 또 크리스 먼로 박사와 크리스 발라스 이쪽 옥스퍼드 이오닉스랑 서로 이온 트랩의 최고봉이기 때문에 서로 경쟁하면서 1, 2등을 하던 데인데 제가 알기로는 크리스 먼로 박사님이 크리스 발라스 박사랑 일하고 싶어서 돌아왔다라고 알고 있거든요. 그래서 이런 환경들을 조성하고 인간적인 관계나 갈등을 풀어가는 게 지금 아이온큐 CEO인 니콜로 데마시가 잘하는 게 아닌가 이런 인사이트를 또 얻을 수 있었고 그런 것들로 인해서 주가가 오른 게 아닐까 좀 생각을 하는데 So why do you think IonQ's stock price soared today? It went up like 18%.
Yeah, always with IonQ, it's difficult to I think that here's what today really was, Sean. It was about that IonQ isn't a quantum hardware play.
Right.
It's a platform.
Right.
Once people understand that, it's a full stack. Full stack meaning hardware, software, compiler, and applications. So you have hardware, software, compiler, applications, right? It's all of that, which no one else has. That's when people start understanding that, I think it lifts. Here's another thing, I think probably why. They said the word intelligence, defense, cybersecurity a lot. So they said it over and over again. And when you say cybersecurity, people know how big a market that is. So if people think of quantum as, oh, well, we can just do cool experiments, things faster. Well, okay, like, I mean, it's interesting, but it's not like a must-have. They're reframing it to, this is about cybersecurity. Within 3 years, everyone's going to need to be protected from us. So when people hear that, they're like, oh, so this thing, it's coming. Like, nations and countries and banks and everyone's going to need this now. And so I think that was really what they were trying to tell people, is that the sense of urgency. And that's when they kept emphasizing the word cybersecurity. And I think that's what the market heard. Because when you think of cybersecurity, you think of CrowdStrike, Palo Alto Networks, right? Like right away there's a market where you know there's going to be demand there. Yeah.
제가 오늘 주가가 왜 18% 17% 올랐는지, 혹시 왜 그렇게 올랐는지 생각하시냐라고 여쭤봤더니, 아이온큐가 양자 풀스택이라는 걸 오늘 굉장히 강조했어요. 하드웨어, 소프트웨어, 또 어플리케이션까지 다 하고 있다는 걸 이제 뭐 다이어그램으로도 보여주고 설명도 하고, 그러면서 이제 양자 하드웨어만 하는 게 아니라 이 진짜 풀스택 회사다, 양자 인프라 회사다라는 걸 강조했는데, 그걸 이제 애널리스트들이 좀 이해하기 시작하면서 또 매수세가 많이 들어온 게 아닌가 그 생각을 또 했고, 아이온큐가 이제 국방, 첩보, 사이버 보안 얘기를 많이 했는데, 사이버 보안 하면은 뭐 팔로알토 네트워크스랑 크라우드스트라이크 같이 단기간에 급성장했던 이런 기업들이 있고, 그 사이버 보안 시장이 워낙에 큰데 무슨 얘기를 했냐면 Q-Day 얘기를 많이 했어요. 그래서 앞으로 뭐 미 전쟁부 Department of War 같은 경우는 3년 안에 이 양자 컴퓨터가 우리가 쓰고 있는 암호 체계를 깰 수도 있다라는 말을 정부 차원에서 했기 때문에, 그때까지 너희가 사이버 보안을 지키려면 우리 양자 보안, 양자 제품들이 너희가 필요해라고 했는데, 그게 이제 먹혀들기 시작했다는 거죠. 그래서 양자가 그냥 뭐 멋있는 과학 실험이나 장난감 요 정도 수준이 아니라 사이버 보안과 직결되고 이걸 할 수 있는 회사, 그 공격과 방어 모두 양자 인프라 갖춘 회사가 아이온큐밖에 없다라는 이 두 가지 포인트를 잘 설명했기 때문에 오늘 주가가 급등한 게 아닐까, 이렇게 좀 생각하고 있다라고 하십니다.
And Niccolo De Masi used very specific language that the market would hear. He said Five Eyes Alliance. He said, so right away, he was saying, this isn't just security for the United States, which is important, but what's going to be important are our allies too, right? Right after he said security for the United States, who did he say? South Korea, Australia, New Zealand, Canada, UK, right? Those alliances is going to be very important. And I thought the very last thing, you know why that IonQ thinks this is important? The very last person who spoke was Robert Cardillo.
Right. He talked a lot.
And his thing was, this is about a mission and it's about security, right? Like the gravity was about, so it's about cybersecurity, it's about defense, it's about protecting not our national but also economic security, because you want to be financial transactions. If RSA's cracked, means they're not secure. So I just thought that him giving him the final word, I think was a message to the market that governments are interested in this, security agencies are interested in this, and it's not just the United States, it's our allies too. So I think that's what people started to understand.
그리고 또 니콜로 데마시가 Five Eyes라는 말을 많이 했는데, 이게 뭐냐면 5대 동맹국을 얘기하거든요. 미국, 영국, the Five Eyes are
Five Eyes are Australia, New Zealand, Canada, United States, and UK.
So
it's a signals intelligence alliance, from back in the day.
뭐 첩보 동맹인데 이 얘기를 많이 했어요. 그래서 앞으로 이쪽으로도 매출이 많이 나올 거다라고 했고, 또 이 전체적인 행사 흐름을 보면 맞아요. 로버트 카딜로 이분이 얘기를 많이 했는데, 이분이 전 미국 국가정보국인가 거기 국장입니다. 그래서 대통령한테 뭐 100번인가 400번인가 일일 브리핑을 했을 정도로 굉장히 첩보 면에서 높은 사람인데 이 사람한테 많은 말을 하게 해가지고 이제 우리가 양자 컴퓨터를 하는 거는 단순히 우리만을 위해서가 아니라 미국의 국가적인 안보 이런 것들을 위해서 반드시 우리가 해야 되고 승리해야 된다 이런 얘기를 하면서 또 이 회사가 단순히 그냥 뭐 실험만 하는 회사가 아니고 진짜 국가 차원에서 꼭 필요한 회사고 그걸 해내고 앞으로 동맹국들과도 같이 하면서 매출 내겠다 이런 얘기를 해줬기 때문에 굉장히 중요했다는 거죠.
But what I think is also exciting for us IonQ investors is that what I hear IonQ saying is that we're developing the most powerful cyber warfare weapon, but we're also going to sell the solution.
And the defense.
Yeah, so because we're creating the most powerful weapon, we know how to protect against it.
Right,
so that means 2 revenue streams, right? You make money on this end, and then you make money on the defense of it. So I think that's and the other thing too here, Sean and everyone, is that when you talk about sovereign nations making these kinds of what are really an infrastructure level investments in their security, that's very sticky revenue, and it's recurring
and huge.
So it's they're large, but it's sticky and it's recurring. And as an investor, you love to hear sticky recurring revenue because that means it's not going to be something that South Korea isn't going to be like, we care about cybersecurity for this one time, and then we're not going to care about it anymore. Once a nation has a secure quantum network that's unhackable, they're going to want to continue keeping it. So you got to keep maintaining it, keep servicing it, right? So it's and again, I think those are things that investors hear and they respond to. But the other thing too, I've been giving all these examples. It could have been as simple as the Oxford Ionics deal came through.
Oh, right.
It could have been as simple as because that was the biggest risk to the company. Honestly, if your market cap is $10 billion and you put $1 billion towards one investment, that's just your all your chips are being bet on that. And basically they're signaling, right? They're like, this is the technology we need in order to really scale. Well, if the deal fell through, where's the company left with? So maybe there was just a sigh of relief that deal happened, that people are like, okay, the risk is gone, and now IonQ can go forward. So the Oxford Ionics deal probably had a lot I gave all this analysis, but now that we're talking it through, I think that had a big part of why the market, the sophisticated investors went, oh, okay, the risk is gone. They can move forward.
Right.
Yeah.
그리고 또 주가가 오른 이유에 대해서 이제 아이온큐가 뭐 양자적인 공격도 이제 양자 컴퓨터를 개발하면서 우리가 할 수 있고 그거에 대한 방어 솔루션도 양자 네트워킹, 뭐 QKD 이런 것들을 할 수 있다라고 했거든요. 그래서 공격과 방어를 다 가지고 있기 때문에 우리가 공격하면 뚫을 수 있는데 그거 너희 막을 솔루션 우리가 가지고 있다. 이 두 가지를 다 가져가는 게 굉장히 스마트하고 앞으로 큰 매출을 낼 수 있다는 거죠. 그리고 더 나아가서 이거를 이 솔루션을 가져갈 곳은 국가적인 차원입니다. 그래서 이런 국가들이 우리 그런 양자적인 보안과 인프라 필요해. 그러면 이제 국가들이 그 계약들을 수주하게 되면 아이온큐가 굉장히 끈적한 매출을 가져간다라고 했는데 한 번 일회성이 아니라 계속 발생하면서 그 규모가 어마어마하다는 거죠. 정부가 하기 때문에. 그래서 앞으로 그런 정부, 국가적인 차원에서의 매출이 나올 것 같다. 라고 얘기를 했고요. 또 표면적으로 오늘 주가가 급등했던 이유 중에 하나는 옥스퍼드 이오닉스 인수가 완료됐기 때문입니다. 이제 조건부로 뭐 영국 안에서 개발해야 되고 영국이 원하면 하드웨어 보여줘야 되고 이런 것들이 있긴 했지만 아이온큐가 $1 빌리언 컴퍼니인데 10억 불짜리인데 여기에 1빌리언을 넣었단 말이에요. 그러니까 거의 올인을 했다라고 보는 거죠. 이 옥스퍼드 이오닉스를 인수하기 위해서. 그리고 그 회사를 인수해야만 기술적 로드맵이 말이 되고 실현할 수 있는데 그 리스크가 해소가 됐기 때문에 이제 지켜보고 있던 투자자들이 들어오면서 주가가 많이 올랐을 수도 있다라고 얘기를 했습니다.
Yeah, and so I just think, and if you see the live stream that Sean was working on, there's a slide, and on the slide it's like, here's Quantinium, here's IonQ, and then Oxford Ionics is way over here. Like Oxford Ionics is way advanced more than everyone else, right? Yeah, and so the idea being that because Oxford Ionics is way over here, that gives IonQ a huge advantage. If the deal didn't go through, then all of a sudden they're back, they're back over here. So I think as soon as they announced today that Oxford Ionics is the deal's going to go through, everyone went, oh, so now this one that's way over here, exactly, yeah, this one that's way over here. Now that's IonQ. Now IonQ is way over here, and I think the market reacted to that.
그래서 그 크리스 발라스 CEO가 발표한 내용 중에 양자 컴퓨터가 좋아지려면 이 세로축은 큐비트 수, 가로축은 이제 성과, 오류율이 얼마나 낮은가 이걸 보여주는데 아이온큐가 딱 중간 정도에 있었고 큐비트 수도 적당히 많고 오류율도 적당히 좋다. 근데 옥스퍼드 이오닉스 같은 경우는 이쪽 오른쪽 밑에 있었습니다. 그래서 아직은 큐비트 수가 적지만 오류율이 낮다. 그래서 이 두 개가 합쳐지면 이제 이 위로 온다는 거죠. 큐비트 수도 많고 오류율도 적고. 그래서 아마 시장은 옥스퍼드 이오닉스 인수가 완료됐기 때문에 이제 아이온큐를 여기에 있다고 보는 게 아니라 여기 있다고 본다. 1등이 될 수 있는 가능성이 높아졌다고 봤다라고 합니다.
And so here's the thing is that the reason why Oxford Ionics, just for context for everyone, is so important is that trapped ions, their weakness is that they do everything well, but their weaknesses is that they're slow. So everyone else has a weakness. Their particular weakness is that compared to everyone else, other modalities, like superconducting and everything else, trapped ions is slow. Well, with Oxford Ionics, all of a sudden, their weakness is now their biggest strength. Now they're really fast. So now, all the way across the board, trapped ion is superior. Like, no other modality can say we have better coherence or better fidelity or better, like the other things you check that you would want. And so this is significant because it just makes IonQ fast, and that was its greatest weakness for trapped ions.
So by speed, you mean the actual operation speed?
Of the gates, yeah. It gives them faster gates.
You mean on the Oxford Ionics side? Or?
For the IonQ side, right? Like, so it drives, in these sub-microsecond, and we can... I can post their papers on that, but that's why this was very important for IonQ to acquire, is because it's speed. That when it just trapped ions have so many things that are good, but they're just not fast enough.
I didn't know Oxford Ionics had a fast
gates.
Speed.
Yeah, so that's why IonQ wanted them. So imagine. If IonQ didn't get this deal, well, then they're going to be slow. Yeah, they're not going to be as fast.
그리고 또 옥스퍼드 이오닉스 인수가 중요한 게 얘네가 이제 높은 충실도, 이제 낮은 오류율이죠. 그걸로 이제 세계 1등인데 여기에 이제 게이트 속도도 빠르기 때문에 이 두 가지를 다 취할 수 있었기 때문에 아이온큐가 앞으로 1등이 될 가능성이 높아졌다. 그래서 이 인수가 여러 불확실성을 극복시키고 이제 기존의 이온 트랩 방식이 뭐 양자 결맞음 시간도 길고 또 충실도도 좋고 이런데 이제 속도 느리고 확장성이 없다 이거였는데 이걸 이제 극복할 수 있는 기반이 마련이 됐다는 거죠.
So again, why IonQ is different is that they have Oxford Ionics for the gates, they have light sync for memory and transport, and then you have Capella space for QKD and ISR. So those three together, that's why they said something very important. They said this isn't 1 + 1 = 3. Right. It's 1 + 1 = 30. Right. And they're exaggerating, but what their point being is that these teams coming together produces something much better than any of them could have imagined. Because you could just see in their faces that, like, you have to imagine like a competitor. You look and these were like your fiercest competitors, and now they're your colleagues. You get excited because you're like, oh my gosh, look what we can do if we're all on the same team. So but that's what they bring is speed. That's what they bring.
그래서 옥스퍼드 이오닉스는 이제 속도를 가져오죠. 연산 속도가 빠른 거, 그리고 카펠라 스페이스는 우주 역량, 그리고 첩보, 그리고 QKD라는 기술을 가져오고 라이트 싱크는 양자 메모리를 가져와서 이제 포토닉 인터커넥트를 가능하게 해주는데 이것들이 다 모여서 니콜로 데마시가 뭐라고 했냐면 1 더하기 1은 2 또는 3이 아니라 30이다. 우리가 그걸 만들고 있다는 거죠. 그래서 필요한 기술들을 흡수합병해서 그런 시너지를 앞으로 만들 거고, 이들이 원래 인수합병 하지 않았으면 서로가 경쟁사이기 때문에 힘들 수 있는데 함께 하기 때문에 우리가 뭘 할 수 있을지 기대한다. 이런 눈빛들이 좀 보였다라고 얘기를 하시네요.
And see, where this is going is, IonQ's argument is that, and Chris Monroe made this argument originally, is that you're not going to get the powerful quantum computer. This, like IBM is like, we're going to build this huge quantum computer and it's going to be super powerful. No, you're going to have a bunch of little tiny quantum computers all connected together. Well, the way you do that, they're all going to be connected together photonically, and now they're going to become one big computer. The only way that works is you need octadionics for the fast gates. You need light sync for memory, because that's what that quantum repeater and everything that they were talking about. And you need QKD, and you need the orbital layer that Capella brings. Like that, so that's why they're really imagining that the vision that Chris Monroe imagined, which was a bunch of small quantum computers all connected together, not one big machine, because it's just not practical. Yeah. So that's why all this is relevant.
그리고 또 IBM 같은 경우는 엄청나게 큰 양자 컴퓨터를 만들어서 큐비트를 많이 넣겠다 이렇게 하는데, 아이온큐는 그게 아니라 작은 양자칩에 수많은 큐비트를 넣어서 이걸 이제 연결하겠다. 그래서 거기에 필요한 옥스포드 이오닉스, 카펠라 스페이스, 그리고 라이트 싱크. 얘네들을 가져와서 이제 크리스 먼로가 꿈꾸던 이제 양자 모듈 칩들이 연결되는 이거를, 크리스 먼로 박사님이 실제로 나와서 얘기했어요. 내가 이걸 구상했는데 실제로 구체적으로 필요한 기술들이 우리는 좀 부족했는데 이제는 준비가 되고 있다라고 했다는 거죠. 그래서 이런 배경으로 아이온큐가 이제 1등이 됐다, 이렇게 좀 얘기를 하고 있고. We only have 8 more minutes.
Okay.
We could record.
Okay.
So
yeah.
make it short.
Yeah. And then I think the other compelling thing was that slide that Jordan Shapiro was talking about how the power of having quantum computing and quantum networking. So everyone pay attention what's happening in Tennessee, because then that EPB quantum network happens. This is significant. And then I think that one down, which is, there was somewhere where he was like showing something. It was really, really. Go down one more. Yes, this one, where he was like, there's the compute zone and the interconnect zone, and how they're kind of shuttling and able to use them for multiple purposes. The way we imagine it is just interconnect or just compute, but like I didn't quite. I have to study this further, but I thought that was really interesting. And also that slide you showed, that's up. That's again that
one shot.
That's. I mean, that is a bold statement.
Right.
That is a bold statement. Like they're like, we are going to be the place for networking. And that's Cisco. So in a lot of ways, they're being NVIDIA and Cisco combined. You have that software layer of NVIDIA, that control layer with Cisco, all in one. And so this is, this is going to be a very powerful company.
Right.
They're going to have a lot of leverage and a lot of control. Yeah.
그래서 또 조단 슈피로 상무가 전무죠, 이제 발표했던 내용을 보면은 몇 가지 진전을 얘기해 주긴 했는데 깊게는 얘기를 안 했어요. 이제 맛보기적으로 얘기를 해줬는데, 특별히 이 칩 내에서 계산하는 존이 있고 이 합쳐지는 인터커넥트 존이 있는데, 이걸 왔다 갔다 하면서 큐비트를 쓸 수 있다. 그러니까 큐비트를 효율적으로 더 적게 계산도 하고 연결도 하고 이걸 할 수 있다. 이 부분은 우리가 정확히는 이해 못했는데 어쨌거나 이런 기술적인 진전이 있었고, 또 두 번째로는 이걸 얘기해 줬어요. So they were able to use the existing fiber to do the.
That's amazing. Yes,
right?
yes.
This
because
was an important one.
This is another important one, because the thing to understand, everyone, is that there's been like trillions of dollars invested in telecom fiber, right? Like telecom fiber has been laid everywhere around the world. So what they're saying is that in order to do quantum networking, you don't have to change, you don't have to make this investment to lay new fiber down. You can use the existing fiber. The other part of this was what they were saying with Oxford Ionics, right? Like in order to do this manufacturing, you don't even have to retool anything. You can use the semiconductor, you know, existing semiconductor wafers or however they build that. So if I can, so the reason why they're thinking how massively they could scale is if we use existing semiconductor wafer and existing telecom fiber, we can instantly scale. You know, and that's a huge that collapses the timeline. You know, that takes from something being years and years and years away to being like urgent and right now. Yeah.
그리고 또 다음번으로 얘기한 게 One Stop Shop for Full Quantum Networks라고 했는데, 그러니까 완전한 양자 네트워크 전체를 아이온큐 오면 한 번에 살 수 있다. 그래서 뭐 양자 연결부터 시작해서 양자 장치 간의 안전한 통신 뭐 이런 것들, 이걸 이제 아이온큐가 전부 갖췄기 때문에 이제 양자 공격이 두려워? 그럼 아이온큐한테 와. 그럼 우리가 너희한테 필요한 거 다 줄게. 요게 앞으로 굉장히 큰 매출을 낼 것이라고 생각하고, 또 두 번째로 발표했던 게 미 공군연구소랑 지금 하고 있는 게 양자적인 신호를 주고받는 거를 새로운 통신선을 까는 게 아니라 기존에 깔려있던 광통신선을 쓸 수 있게 하는 거를 성공을 했다라고 합니다. 그래서 이런 옥스퍼드 이오닉스를 인수함으로써 기존 반도체 라인에서 양자적인 부품들을 생산할 수 있는 거, 그리고 이 양자 네트워킹을 기존 광섬유 통신선에서 할 수 있는 거, 이것들이 이제 양자적인 제품을 조만간 큰 투자 없이도 깔고 만들고 팔 수 있다는 거는 굉장히 빠르게 기술이 가속화되면서 상업화되고 있다라고 우리가 볼 수 있었고요. So maybe we could go to conclusion.
Yeah, we have a few minutes. Yeah, just you know, what were your kind of final?
Well, I like that Nicolo emphasized a lot that we are 5 years ahead of our competitors, and they will never catch up.
But I think too is the concrete reasons why behind that. You know, because sometimes you say 5 years, and the reasons why is that the power requirements. You know, they just need less power than everyone else. So again, when you start looking at cost per qubit. So if you think about like a manufacturing mentality, it's like the unit economics start being important, right? So it's like the cost to produce this stuff. There's going to be a big difference between what IonQ does and everyone
else. Almost like 20 times difference.
Exactly right. Yeah. So it's going to be way more. You know, it's going to be cost prohibitive for a lot of folks, and so I just think overall what a difference it is. I think is meeting people in the room, like in person. Right. It's very different than like objectively, you know, kind of how you see them from a distance. You kind of get the sense of like, you know, who they are. And my read, which I could never have done if I hadn't had this experiences, is that these are very competitive people. Right. Like they want to win.
That's a good find.
They want to win. They are not, you know. If you're out looking at the outside in, you're like, oh, you're doing these things because you want some kind of acquisition. No, these are folks that are they want to have their names in that chapter of, you know, the technology story, and that came across to me offline, you know, outside of it very clearly, and so that's very compelling to me.
그래서 저한테는 어떤 점이 좋았냐라고 해서 전 니콜로 사장님이 우리는 경쟁사보다 5년 앞서 있고 절대로 못 따라잡는다, 그 부분이 굉장히 좋았는데, 그게 결국에는 이제 데스먼드님이 말씀해 주셨지만 기술력뿐만 아니라 큐빗당 비용도 굉장히 낮다. 그래서 뭐 결국엔 궁극적으로 경쟁사들은 수십억 달러가 드는데 우리는 수천만 달러 선에서 20배 차이가 난다. 이런 면에서 굉장히 이제 아이온큐가 잘 하고 있구나라는 걸 느꼈고, 특히 이제 온라인으로는 우리가 그 사람들을 봤지만 오프라인에서 만나면서 어떤 사람인지 감이 오잖아요. 근데 이 사람들이 굉장히 열정적이고 파이팅 넘치는 사람이고 자신감이 있다. 이런 부분에서 투자에서도 좀 더 자신감을 얻었다. 이렇게 좀 얘기를 했습니다. Alright, so we did interview for 45 minutes.
We did.
Now we
Okay.
should go and have some fun.
Okay. All right. Thank you, everyone.
Thank you for watching.
Thank
everyone.
you. Yes, this is a great experience. I'm having a great time here with Sean.
I love that nobody is losing their money in IonQ for at least for this night.
Yeah, correct.
We
correct.
are at the all-time
high. So we're heroes.
could
So we're
party
okay.
now.
We're okay. For today, for the weekend, we're going to be okay.
그래서 이제 제가 마지막으로 얘기한 게 이제 신고가를 찍었으니까 아무도 물린 사람이 없어 너무 행복하다. 그래서 우리가 또 다음번에 좋은 시간을 내서 인터뷰 해보려고 제가 또 노력을 해보도록 하겠습니다.
But also, everyone, we're just getting started.
네,
This is
이제
just getting,
시작입니다.
just getting. This is the beginning of the story. So many more exciting days and many more transitions and developments. And so I'm much even more excited now than I've ever been. So this is the very beginning of the story.
이제 막 시작이기 때문에 앞으로 우리가 기대감을 가지고 또 지켜보자라고 얘기를 했습니다. Alright, we'll
Okay.
later. Thank
Bye.
you.
Thank you, everyone. Bye.
고맙습니다.
Good night.
자, 그래서 여러분들 총 6개, 7개 영상을 지금 거의 4시간 이상 걸쳐서 보셨는데 뭐 아이온큐 초창기부터 중기 지금까지 오면서 뭐 임원들이 했던 말 중에 지킨 것도 있고 안 지킨 말도 있고 한데 어떤 흐름의 변화가 있었는지 또 여러분들이 이런 것들을 보면서 투자 판단에 도움이 되셨으면 합니다. 그래서 긴 영상인데 한번 쭉 봐보시면은 정말 도움이 되셨을 거라고 생각을 하고요. 오늘 영상은 여기서 이만 줄이도록 하겠습니다. 네, 감사합니다, 여러분. 항상 현명한 투자하시고 건강하고 행복한 투자 여정 걸으시길 바랍니다. 감사합니다. 가을바람이었습니다.